Welcome to the GeekConf. 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 Welcome to the GeekConf.
Lots of cool discussions, lots of yummy coffee and food outside. We're just going to take a couple minutes to review some of the details about the conference because it's my first time here. Is it y'all's first time here? Yeah, because this is the very first The GeekConf, am I right? Yeah? We are making history. Give it up for yourselves for showing up. So we are here. We are going to be hanging out today in this beautiful venue that we've got here. And we are totally on board with the technical challenges thereof. There we go. All right. So we are going to be enjoying this beautiful Kulturbüro for our venue today. What's up? Hallo Berlin. Guten Morgen. Wie geht's euch? Okay. Have folks already explored this beautiful courtyard out here? Get some breakfast, some caffeine, some bicycle-ported coffee. So we are here in the main conference area. As you all know, out in the outdoor lounge is where meals will be served, breakfast this morning, and we will have lunch out there and breaks and things like that. Also, if you just need some fresh air, hopefully it looks like the weather is cooperating today. Then there is the building 2, which is just across this little alley right here, which is where the demo booths are going to be. Also the registration desk will be in there. And there are bathrooms in both this building and in building 2. So if you need a quick break, there are bathrooms on either side of this entryway here, and then also some more in the next building over. If you, yes, so lunch will be outside, and if you could please be mindful not to bring anything but water into the main hall, so no coffees or sodas or anything that can spill and food that can get everywhere, that would be much appreciated. Thank you very much. Water is totally fine. And yes, breakfast, you already got that memo. Okay, so now, we are here building geeky community, right? We're all here to be good to each other, to learn from each other. The GeekConf t-shirts, who are all volunteers on the staff, and they can get your message to where it needs to be. Can we please give a huge round of applause for the GeekConf volunteers and organizers? Yes! So much work goes into putting together a conference like this. So please show some love for the conference on socials, hashtag the GeekConf, and you can tag the GeekConf in your tweets or whatever they're called now, X's, I don't know. And let us please also give a huge thank you to the sponsors that are making this all happen. You can read all about their cool tech on the site. But let's please hear a big round of applause for our sponsors. You can talk at the booths. Yeah. Amazing. And of course, you all have probably already found the website because you're here with us today. So great, good job. And you can keep up to date on what next amazing talk is coming up with the schedule there. And of course, also links to all of the other stuff you could possibly want to know about the GeekConf and its speakers and its venue and its amazing sponsors. So that is pretty much it for me. Now, we are going to bring on one of the major driving forces in the tech world, and definitely the driving force behind the GeekConf. Also a driving force behind massive adventures. Anybody into camping out there? Because this next speaker, who's going to be opening up our conference, has an amazing camper that you definitely want to ask him about in the breaks, okay? So please give a huge, warm, we are so caffeinated and energized that we just don't know what to do with ourselves. Welcome to the founder of Geeky Ants, Sanket!
Yes.
I'll give you this back.
Yes.
All right. I'm pretty stoked for this day. Are you stoked?
I'm very, very pumped to see everyone.
It's amazing.
Yes, yeah, super excited.
All right, leave it to you. Everybody
Thank you
give
so
it up
much.
for Sanket!
Hey everyone, good morning. Good to see happy faces, all of energy, yeah? I need to figure out the technicalities again, so. All right, hey, so that's me, if you're trying to figure out who this guy is on Twitter. So that's my DP on Twitter. I'm Sanket Sahu, and I hope to match the energy what Anjana has, what she left the energy on. So I'm Sanket Sahu. I run this company called Geeky Ants. And you might know us from our React Native ecosystem, maybe with native base, UI component library in React Native. These days, we have renamed it to GlueStack UI. And I also happen to run and co-organize React Native Bangalore meetup group, which is one of the largest. And as a part of this, as a part of the story to extend it as the next step of React Native Bangalore, we are here at the GeekConf. Yes? All right. And this is the caravan and camper van what Anjana was talking about. So I built this in the past 2 years, 2.5 years, and did a lot of interior work, and along with one of the definitely vendors. This is an off-grid caravan where this is back in India, by the way. I'm from Bangalore. Yeah, this has everything. This is a fully off-grid caravan with sleeping, eating, internet, and you get to work, see the mountains, see the beaches, and whatnot. So yeah, so that's about it. And today, to set the context of this conference, I'm going to talk about the state of React Native and how it relates to the modern web. Although React Native started as like native Android and iOS library, but now it's like everywhere. So let's look at the numbers. React Native by numbers. I went to NPM trends and tried to figure out the weekly NPM downloads of the React Native library. So what you see on the screen is around 2020, it was a little under 500K weekly NPM downloads. And if we move to 2 years later, 2022, it was around 750K. And where we are at today, any guesses? So we are at whopping 2.28 million weekly NPM downloads. That's huge for a mobile app library. And not just that, I mean, we keep hearing like surprising facts on Twitter, on Reddit. And this is a tweet by my friend Harry, who I've known from the early days of React Native. He says he was surprised that even Kindle uses React Native. And then Mike had to say something Like there is so many wow moments yet to be discovered when it comes to companies using React Native on their custom hardware. I don't know what he's talking about, but probably in a few days you'll get to know. Great. Look at Evan's tweet where he keeps doing it every month. So in the month of May 2024, top 100 apps, 100 business apps in the App Store, out of 100, 26 uses React Native in some extent, maybe brownfield, greenfield, but it has the React Native library in the bundle, which is amazing to see. And what we have seen recently in the past, I think 1 year or so, React Native, the core team, they recommend using a framework, just like the counterpart of React on the web, like how Next.js is now the recommended way of building things. We have a framework approach. And this started with an RFC in a very standard way, like how we should have frameworks on top of React Native as a library. And now we see it in the official documentation, like on the very landing page of reactnative.dev, you see, like, get a head start with a framework. And obviously, it's Expo, because Expo has been there for a really long time. And the community around React Native has been growing massively. I have a few examples. So this is, again, my community friend. We used to work together. This is Nishan. Nishan keeps pushing things to the core of React Native. And he's just an individual somewhere in India or somewhere in the world, and pushing things to the core of React Native, which has an impact like to billions of apps and devices, which is amazing. So this is an example of how he pushed gradients recently. This was, I think, just last week or so. He made it possible to have gradients in React Native core. Before that, he also pushed the rotation and transform origin, which maps to the CSS equivalent available on React Native and on all the platforms. Not just that, he has also done something on translate percentage and flex cap, and it goes on and on. This is just one guy. There are like umpteen number of examples. For example, Nick, he contributed to the core of React Native on Android, where he implemented box shadows, which was missing. I think he's still working on it, but we have got some examples up and running. And I just try to bring and download all the contributors. Not all, but I think the top contributors to the React Native core library. You might see some familiar faces. Might spot yourself, maybe, in the grid. And this goes on and on. And huge shout out to everyone who's contributing to the ecosystem, to the core. Yeah, needs a round of applause, I guess. Yeah. Just to be fully transparent, I use this API so that don't come back to me that you didn't showcase me. And this grid that you saw, it was generated by ChatGPT, because I asked ChatGPT to show the top contributors and just ran the HTML file and took the screenshot. So yeah, that's about the core contributors. Not just individuals. There are companies now getting into the world of React Native. We know that it was started by Meta, but we have seen good adoption by Microsoft. And now Amazon, you can see the showcase page of React Native and how Amazon is using React Native. Then we have this project IDX, which is a code editor, in-browser code editor, built by Google. And now we have full-blown support of React Native. So it's not just like one company. It's like something that is an actual community project, and that is what I love about React Native. I love this tweet. So last week we had Chain React in Portland in the US, run by our friends at Infinite Red. This tweet says, it takes a village. And then when all the companies come together, then it becomes something. But I think we missed a few of the logos. Let me add a few. So we have all these companies, and I'm pretty sure I've missed another set of companies again. But when everyone comes together, it is called, I mean, it's meant to be great, something like React Native. Yeah, so let's look at the updates of React Native, the latest version, the 0.74. It comes with Yoga 3.0, which, again, moves it closer to the web API. The first one is, like, you might have used row reverse, which behaves differently on web and React Native. Now it's the same. When you flip it, you still use margin left, and it is margin left. Then we have space evenly, and then static as position. These are available in the latest version of React Native. We have bridgeless by default. We have been talking about the new architecture for a long, long time, and now this is the default in React Native core. So if you spin up a new React Native or Expo project, you get bridgeless by default, which is amazing for more performance. Then we have on-layout batch updates for better performance. What we are looking at is, as we are moving forward with React Native, we have more web standards that we are trying to adopt. And that's why we call it, like, React Native is moving in the direction of, like, modern web. We have seen something really fascinating by the Meta team, browser-like APIs in React Native. And that's React Strict DOM. So earlier, even today, if you have to use React Native on web, we have got React Native Web. So it's like React Native first API being used in the browser. But the core, the foundation of React Native lies on the web. Why to do it, like, twice? So React Strict DOM flips the game. So you get all the HTML APIs and web APIs on React Native, and it works everywhere. Here's a quick example. This is by Nader. You can now build mobile apps with HTML. And this is not like Ionic, not like web views, but this is more like you get full native mobile apps with the knowledge that you already have of HTML, CSS, or maybe React for web. And this is amazing. And this comes with Stylex, which is a CSS and JS sort of library. This is a styling system that powers Instagram, WhatsApp, Facebook.com. All these are run with a styling engine called Stylex. And this comes with React Strict DOM, much closer to the web APIs. We have more RFCs that align with the web. If you look at, say, RFC 0744, this talks about how we can bring event loop, the processing model that we have on the web, more closer to React Native. And we have seen brilliant examples. I'm not sure if you guys had a look at App.js conference, the talk about the SpaceX and Starlink app. So what you see on the screen is 100% React Native. The 3D model that is rendering, that's being rendered with Three.js, Expo.gl, and a bunch of React Native code. So we can render 3D model for sure. And not just that, if you look at this example from the same app, which scans the sky and then locates these satellites so that you set up your Starlink device at the right position, right angle, and you can do it with your phone. And this is all built using JavaScript on top of, like, native app. So this again uses Expo.gl, WebGL, and even, like, it renders the whole sky hemisphere sort of thing on your phone, which is truly amazing to see something like this in React Native. And this is cross-platform. Great. And talking about, like, rendering 3D models in React Native, we had Mark from Margello team. Just 2 weeks back, I think he announced React Native Filament, wherein you can just bring in a 3D model and render on screen across web, native, and which is truly amazing. In just 47 lines of code, this is actually bringing in a model from an HTTP request and then rendering on your device. And with gesture handler, you can actually rotate this device. Truly amazing. And on top of that, William at App.js Conf also announced Web GPU, which is a very recent standard on the web to make use of GPUs. And he came up with this example at the conference, wherein it's using the GPU inside a React Native app, and this works cross-platform. You can imagine, like, where it's all going. This is truly marvelous. And not just that, we're not just rendering on the screen, but also inside a whole AR/VR experience. Oscar is going to talk today about, he has spoken a lot about React Native Vision OS. So we have the bindings of Vision OS available. And we can render 3D models inside the vision device altogether. And then we have IDE and tooling. For example, Dan came up with Create Expo Stack. And then we had the biggest announcement of React Native IDE by AppJS, by Software Mansion at AppJS conference. You must go back and watch the talk where they announced React Native IDE, how we can trace back JavaScript and also native code. We can get down to the native code right from the JavaScript statement, which is really good to see. And it's very interactive. This is one of the best IDEs I've seen in a long, long time. Great. And then we have seen the rise of server-driven UI. We have a couple of talks lined up today on server-driven UI. The first one is the next talk by Mike and Eric, and they're going to talk about RISE tools. And we have also seen Evan Bacon talk a lot about server-driven UI in the form of, obviously, React Server components and how it can render truly native elements using server-driven UI, using React Server components as well. And we have Tarun as well. He's going to talk about server-driven UI later today. Not just that, we have seen React Native everywhere on the web as well, and we call it universal approaches. I think Mo is going to talk about universal as well towards the end of today. And we have seen companies using it across different industries like Amazon, Instagram, Tesla, Pinterest. All these companies are using React Native and sharing code across native and web as well, which is truly amazing. And this is made possible with a bunch of tooling around universal approaches. One of those is Expo Router v3, which brings in the API of file-based routing to native mobile app development, which is really nice to see. Very similar to Next.js app router, you can say in some sense. And we have been using it. It's really nice to use something that runs everywhere and works on a file-based routing mechanism. And we have seen native wind, the adoption of Tailwind on React Native side. And it makes it very easy for anybody to learn Tailwind and then write code that works on Android and iOS as well. We have used it a lot in the recent announcement of GlueStack UI, a component library that we built. This is a copy-pastable component library that works across web and mobile, and it is powered by Tailwind CSS and also works on Next.js and Expo. So if you use components from GlueStack UI, for example, it works on all the platforms. Great. And yeah, this is the landing page of GlueStack UI. Probably go and check it out. Great. And we have seen a lot of AI, Gen AI related things in React and React Native space as well. We've got Tejas speaking today with React plus AI, and also Simon, how he runs. OK, I'm not going to tell you about it, but it's something related to React Native and AI, and he has got a very cool demo coming today. And we had the survey of React Native 2023, State of React Native. I have got some parts of it in my talk, in my slides, looking at what navigation are we using. So Expo Router is on a rise. We have React navigation being very consistent out there. We have Salito as well. On styling side, we have got React Native Unistyle and Native Wind on the rise. That's what we can make out from the survey. Take this with a pinch of salt, because surveys can be, it can be in some sense biased, because the people who are taking the survey, they have voted for it. Not everyone in the community has voted for it. So take it with a pinch of salt, I would say. Then we have UI component libraries like Tamak UI, GlueStack UI, which are the new entrants. And the existing ones, obviously, React Native Paper and React Native Elements. Then we have seen the rise of React Native Skia, with William being at the center of the stage in 2D, 3D rendering with React Native. We have React Native Animated, Reanimated being used for animation, and I have some cool examples towards the end of this talk. For debugging, everybody is still using console logs. Come on. OK, there's a glitch. Should I do console log? OK, great. And then we have Flipper, Chrome DevTools, but I think we still do console.log 1111. I'm here, something like that. ES is now being the well-adopted way of deployment. Then I have my favorite people in video creators like William, Theo, Simon, Cataline, Vadim. All these people are like creating videos and educating people about React, React Native. There's a huge list. And then we have active people in the community, not video creators like Evan or Mark. And we have Jamin, Fernando. All these folks are like making React Native what React Native is today. So yeah, and we have some pain points. This is your opportunity to look at the pain points, what everyone is facing in React and React Native space. This is mainly React Native. So obviously, we are using console log. That's why debugging remains the first pain point. Then we have unmaintained packages dealing with native code, keyboard handling. So if you want to contribute to React Native, probably this is your list. And then we have missing features as well, like Android shadows, better debugging, keyboard handling, and these things. So probably have a look at this and go back and contribute. Great. So what's the opinion from the React Native Survey 2023 that we got last year? The opinion is console.log and copy-paste is the future. Okay, I just made it up. OK, so React Native is moving in the right direction, and more and more people agree to that opinion. And so looking into the future, I think we'll see more growth on this side, and we'll see a lot of enterprise adoption. We have been working with a lot of enterprise using React Native. More stable, more reliable, and expanding platforms. So write once, run anywhere. I feel that's the future. That's my opinion. But bridging platforms and empowering developers is what React Native is doing today. To end my talk, I have got some nice tweets that shows you nice animations using React Native Reanimated and React Native Animated. This is by Enzo. This is Animate React Native by Cataline, my friend. And then we have another example. And I really love this parallax carousel. So this uses the gyroscope and then animates it on the screen. And yeah, a few more examples like parallax and slider. Is that pretty cool? No? And the final one, this is one of the apps that is built using Skia on top of React Native. So it has all those loaders and knobs and everything, which is really high quality and really good to see what we can do with React Native. Exciting? Yes. All right, that's it from my side. Thank you so much. Yeah.
Thank you.
Awesome. Thank you so much for kicking off this exciting day of React Native goodness and other web goodness. Are we still feeling that nice mid-morning caffeinated energy? Oh, I'm sorry, I couldn't hear you. Are we still feeling that mid-morning energy? Are we excited for our next talk? Yeah! And even more exciting, our next talk, we get a 2-for-1 deal. Because our next speakers are, longtime contributors to the React Native core team who are going to be sharing some delicious nuggets of goodness in their next talk. So, without further ado, please give that huge caffeinated welcome to Mike and Eric.
Hello. Hey.
Oh, no. I know you could be louder than that. Give it up for Mike and Eric.
Yeah.
Yeah, that's right. And it is my job as MC, just so you know, to make you clap and cheer all day. So buckle up. I'm not going anywhere. All right, let's give it up for the tech team. Yeah, making all this happen. Connected. Yes. All right.
1, 2, 3.
All right.
Okay.
Oh, well, we are so excited to be here.
Yeah,
the very
hello everybody
first
again.
Geekconf.
Yeah.
Wow. All right, so today we're here to talk about how to server render without rendering on the server.
Yeah. So before we start, I guess, let us introduce ourselves.
Yeah, absolutely. So this is Mike Grabowski. He's a founder of CallStack. And they hosted this little conference earlier this year called ReactConf. I'm sure you've heard of it. Now he's a founder of XPlat Labs. And Mike started contributing to the React Native community back in 2016. And you helped with the release process and did a bunch of work on the React Native CLI.
Yeah, thank you, Eric. So we met with Eric actually pretty much about that time. Back in 2015, he was member of the React Native core team at Meta, and he created React Navigation together with other contributors from companies like obviously Meta, Expo, and Community. He's now CTO at Seed Hypermedia, which is a decentralized publishing system.
All right.
So
I think we've done hyped ourselves up enough. We can get to the talk.
Oh yeah, right. So I found out on Twitter a few months ago that Eric was working on something very exciting that I was always dreaming about, which is combining server rendering and native apps. And so we decided to team up together to show you some exciting things today.
Yeah. So today we are so excited to talk to you about server-driven rendering. Now, this technique allows you to define components on the server that are already ready to go on the client. And you're basically just reconfiguring what's going to be rendered on the client. Now, you might hear this and you think, well, that's not really a brand new technique. Like, this is already actually an incredibly popular technique in apps all over the industry. You've got Instagram that uses a technology called blocks to achieve this. And it's used in countless other enterprise apps, including Shopify and Lyft and a bunch more that I couldn't even name, because everybody's doing this.
Yeah, Eric, so if that's the case, seems like this technique clearly predates React server components. But I guess my question is, why don't we talk about it more often in the open source then?
Yeah, we don't talk about this very often in open source. And part of the reason why is because it's so difficult to do. It just takes a lot of doing to accomplish. But we want to make it super easy.
Yeah, so that's why we're introducing Rise Tools.
Rise Tools is a suite of libraries to help make server-defined rendering super easy for you to use in your mobile applications.
So I guess let's take a look at how you can incrementally adapt SDR in your app. And me and Eric, we happen to be working on this top secret application, so don't tell anybody what you're just going to witness.
Yeah, this app is super brilliant, very unique. But our idea is that we can deliver anything straight to your home with this gorgeous application. Oh, that's beautiful. And as you can, as you can see, the app is almost done. And on the home screen here, we have 3 sections. Delivering groceries, delivering food from restaurants, and delivering people in a taxi.
Right? And on a slightly lower level, what we have here is 3 React components for each section: groceries, restaurants, and taxis.
OK, so we're about to ship this application to production, but the marketing team actually wants to be able to experiment a little bit with the home screen. They want to be able to rearrange the sections of the home screen after we've shipped to production.
So I guess we can do a code push, right?
A code push. Well, we don't want to wait for the update to go through. Our users don't want to accept the update. And we really just need to be able to immediately make changes to our application in production.
So what about using server-driven rendering then?
Server-defined rendering, let's go.
Yeah. OK.
So we're going to use this new Rise component for the entirety of our home screen.
Yeah.
Let's see how to use it.
Let's do it. So as you can see, we are replacing the entire home screen content with this Rise component. And as you can see on the slide, it takes 2 props: components and model source.
Right. So the model source is the client that's going to connect to our new server that we're going to build.
And then you have components registry, which is a map of your client-side components that you can refer on the server by the key in the map. And here's what it looks like all together. So you have components registry, you have your model source, and obviously the Rise component.
OK, so to render the exact same UI that we were rendering before, we're going to send down JSON from the server that's going to correspond with each of these components that we've defined on the client.
Yeah. So now if you want to rearrange, all you have to do is send different order from the server that matches what you want your users to see right now.
All right.
So we're kind of ready to ship, right?
Yeah, Mike, I'm sorry. I just got a last-minute request from the marketing team. I know, I'm sorry. But it turns out they want the ability to prompt the users to collect some feedback. They want to run a forum, and they're running it next week. They haven't even designed the forum yet. I know they're throwing this at us last minute, and we really want to ship the app.
Yeah, I got you. So you all remember when we defined components for server rendering a few slides ago. I actually knew that this was going to happen, so I went ahead and I included the entire design system in there so that we can sort of satisfy ambitious requests of our marketing team, even after we ship.
It's very sneaky. All right, these developers. All right, so let's go ahead and add that to the top of our home screen so we can ask the users for some feedback.
Yeah, so we're going to sort of go line by line. And first we'll start with our container, a view. Then we'll go ahead and define its children. Obviously, we need an icon. Luckily, we have a dedicated icon component. Then we need the title. It's a simple string with, as a children. And then we need the button.
All right, so we've got this button.
Yeah.
And so what's going to happen when the user presses the button? Like we're defining this from the server. Obviously, we're just sending JSON. So how can we send a function from the server?
Even though this looks nothing like React, it has a lot in common as far as like mental model. So we can do it with the props. But obviously, we can't use a function because there is no way you can transfer a function from the server to the client. Instead, we can write something that is an action, which defines the operation to run on the client when something happens.
OK, so you've got this navigate action, it looks like. But where has this been defined?
So, there is one more prop on the Rise component, and that's called actions. That's where you can define actions to run on the client. Just like with components, it's a map, and you can reference each action by the key. In this case, we have navigate with the handler, and the handler will be called each time navigation happens on the client.
OK, so here we're defining our on-press action, and we're specifying this path.
Yeah.
So how is this path going to be used?
So Rise component takes one more property, that's path obviously, and path lets you choose what to render from the server. So in our Super Deliver app, the concept is very simple. We have React navigation, and this is just dynamic screen. Like this is React navigation screen. It has Rise component inside. So when we do navigate action, what happens on the client is we're pushing another client-side route that is just rendering a different server route from the server using Rise with different paths. So you can think of path as a React navigation route param.
OK, so we can push screens that haven't even been defined on our client by the time we had shipped the app.
Yeah.
All right, so I guess we're now ready to ship the app.
Yeah, let's go.
All right. OK, this is exciting. Actually, how about we take a look at the code to see what it's really like? How does this actually feel like to develop on?
Let's do it.
All right, we're going to dive into our code. It goes perfectly every time.
Yeah.
OK, so here's the app. Wow, it really does look like that.
Yeah.
We weren't kidding. Oh, jeez. OK, well, so here's all this JSON. So when we edit the JSON, I guess the app will update?
Hopefully, yes.
OK, nice. So I guess, is that because this is like a development build of the app?
Yeah, and the server is actually running, it's subscribed, like the mobile app subscribed to the server, so every time we change something on the server, the client will see it. So, I'm kind of making those edits inline, but you can think of it as doing instant deployments to production.
Right, but so it's not actually the development build of the app. It's that the production app is connecting to our server with WebSockets, and as we make changes, the changes are happening in front of the users live right now. That's how you can think about it.
Yeah.
So we've got all this JSON here. I'm laughing at this because I see at the top it says children, children, children.
Actually, a few more. Look at that. There's more.
Every time you define a component, you do this $ component thing. Like, this is crazy. Have you been developing like this?
Yeah.
This is insane.
Man, you remember, like, people used to be like, JSX is bad, and we prefer JavaScript. Like, this is what happens, you know?
But this is 2024. People love JSX.
Yeah,
We're in a room full of React developers.
Yeah, I guess we're now like talking about different things on Twitter
Come on,
JSX.
there must be some way we can use JSX on the server here, right?
Yeah. Okay. So let's go to 2024, I guess.
Wow. How did you just do that? Is this real right now?
Yeah.
It just instantly changed. What is even happening here?
Yeah. Let me go ahead and change the text again.
I think they're faking this.
So we can see this happening as we speak.
OK. All right, well, that's cool. So we've got JSX.
Yeah.
I see a bunch of weird components I don't understand. Like this Y stack. We've got like gap with $2. Like that's not a number.
Yeah, so this is our design system, by the way. But what it is in fact is Tamagui, which we love. Tamagui is great.
It's Tamagui.
So we're using Tamagui here. So Xtag, Lucid Icon, all these components are coming from Tamagui. And the $ is, Tamagui specific way to sort of reference variable, theme settings, and stuff like that.
OK, so let's go ahead and press the button. We got to send some feedback.
Nothing happens.
Oh.
That's
I
probably.
guess we forgot to finish this.
Yeah, we didn't do the on-press. OK, so let's go.
We're going to go ahead and add the on-press handler. And we're going to call this navigate helper, which is going to help us create this action that we had defined earlier. And here you can see we're referencing feedback form. And this feedback form, there's like a type error. It's like the page doesn't exist yet. I guess we've got to fix this quick because our users, they're looking at it like an empty screen right now.
Yeah.
So let's go ahead and add a feedback form page in our model definition on the server. So this is going to add it to that dictionary of paths that are available on the server to query. And the feedback form is going to be a component with a stack, a vertical stack. Of course, get the padding in there. We want it to look beautiful. So we need a form here. So we're going to need to have like some sort of interactive form. Is that part of our design system already?
Yeah. 1 second, let me finish this up. I'm trying my best, but it's so cold here that my hands are like...
Don't worry, we're still getting warmed up, everybody. Yeah, exactly. Okay. The whole GeekConf is getting warmed up.
So yeah, we obviously, we do have a very clean way to do forms in our design system. Instead of doing a bunch of boilerplate, we do have this rise form component that we use. It's pretty cool. You'll see.
Nice. Okay, so the rise form has some interactivity baked into it already.
Yeah, totally.
And so we want to collect comments. So we want to like a comment field.
Yeah, let's do the input field.
The input field. Yeah.
It's like a normal input, but it has the label inside, which is
okay. So we want it to be a comment, and we'll have a label of like, what do you think, or comments. It's all good.
That's what Copilot thinks is better for us.
Yeah, exactly. Copilot's really in charge here.
That's the real person behind the demo, by the way. I'm just faking it.
Yeah, exactly. So we also need a button, right, for submitting.
Yeah.
What are we going to call the submit button? Is that going to be called? It's called submit button, of course. Okay. Yeah.
Nice movie, right?
Yeah, exactly.
Thank you.
It's a very well named
API.
Okay, so it looks like this would work, but I can see there's a type error. We should fix all the type errors before, and it's telling us that we need the onSubmit handler.
Yeah.
Okay, so we're going to have a function here, but we need this actually. This isn't like navigate, where the action is happening on the client. Like this is an event that we need to go to the server. From the server side, we need to see what our users are saying about the app. Like I'm sure they love it. This is the first time they've ever had something delivered. So the super deliver app, where it's a game changer. So we need a callback here. That's like a server-side callback. What are we going to do?
Yeah, so we can type in a function here. I know I said we can't do functions, but the thing is, every time we write it, something nice is going to happen.
Right, so what we're sending is a different type of definition down to the client that's going to come back to the server when the form gets submitted, right?
So let's see what happens.
Hello, okay, submit, and
Nothing
then
happens.
it's going to go to the server. Can we see the server logs?
Yeah.
Oh, there it is. Oh, you've been practicing.
Man, I know. I'm fast typing, yeah. So many shortcuts here.
Yeah, so can we get the values shown on the server?
Yeah, sure. So onSubmit takes, receives values as a argument. So when we console log it and we submit it, we get it.
And then the server is going to need to respond with some behavior on the client. Like maybe it'll do some validation. Depending on the validation, it'll send a message to the client. What if we do a toast saying, thanks for the feedback?
Yeah, sure. So we can return an action from our server as well. That way we can show a toast or do something extra as well. Mm-hmm. So let's say if somebody submitted feedback, we want to show them this toast, right?
Yeah.
OK, we're back.
OK, so we're returning a response, which is going to tell Rise tools that we're actually going to be providing an action. Because otherwise, if you send data straight back from the server, then that is going to be available asynchronously to the form component onSubmit handler. So it's actually entirely transparent. It's going to be able to send async data down to the client. So thank you for your feedback.
Yeah.
Let's see if that works.
Yeah, I already did it.
Oh, OK. Sorry. Yeah. I'm not paying attention. All right.
Of course.
So
you can look there. That's right.
Yeah. So we've got the toast. OK. So what if they don't provide a comment? Like we should say, we need you to provide some comment.
Maybe I flip those if statements.
Oh, this is better.
Yeah.
OK. We need return the response. Please provide some feedback. So now we have validation. What if they say they hate it, though? We don't want to know if they hate. Can we check to see if they're sending negative feedback and tell them to try again, be a little bit more positive? Yeah, if the comment includes hate, we can't trust anyone who's using that kind of language,
Please provide. More constructive.
Yeah, constructive feedback, exactly. All right, so let's make sure this works, right? We need to filter out all the negative feedback. Oh, wow, that's dark. OK. All right, good. So if they send good feedback, we would basically write it to the database at this point. But we want to navigate back as well. So how are we going to do that? We can do two things at once. We need to toast the user, thanks, and also navigate back.
We can return an array, and then we have a special action, which is go back. It's from the same package as navigate. So let's say this demo was awesome.
Oh, there we go. That's the kind of feedback we want to hear.
There you go.
There we go. Check it out. We built this entire feature in production. Cool. So as you've seen, we're doing this entirely in a JavaScript server, but actually this entire protocol between the client and server is fully documented. So if you want, you can implement servers in other languages, and we might even start to build other languages too. So let us know what language you want to see next.
Yeah.
But I think that was a lot of fun. And now we've seen what it's like to actually use server-defined rendering using Rise in an existing React Native app.
Yeah. So even though this demo was simple, we were showing you a lot of different features. And that's our vision for Rise, is to give you everything you need to build production-grade experiences. So that's why we were introducing Rise Kit, which is a suite of tools that enables you to deliver production experiences and quickly prototype new features for your users. And it has a bunch of things that you've seen already, like forms, obviously. Like this whole design system that I was referring to is just a sneaky way to tell you that we have this kit full of exciting features. And we would like to get your feedback on the roadmap, because our most important thing for us is to make sure that everything you need is there from the get-go.
Yeah, so the Rise Kit is really helpful. You can use this in your existing React Native apps. But what if you just want to experiment with Rise tools? Or what if you have a greenfield experience that you want to prototype? We want to make it so easy to get started. And that is why we've introduced Rise Playground. And this is an app that you can install. And what you can do is once you install it, you put in the URL of your server. The Playground, it has all of Rise Kit. It connects to the server, and it allows you to quickly prototype things as you develop.
And it's available on the App Store and Google Play Store.
Yeah, actually, I'm going to go ahead and download it right now. If you can, you should probably do the same thing, because we have a demo coming up, and you're going to want to have Rise Playground. We're going to go to the App Store right now. We're all going to install it. Even if you're watching at home, it's probably a good idea to install.
Yeah, because it will be obvious after the talk. Anyway, the Playground, like Eric said, supports all the Rise kit of components and actions, and it's the easiest way to get started with Rise if you want to prototype it and see it for yourself.
Yeah. Sorry, I'm just showing off our new stickers as well.
Oh, here's one as well, just for the people on the stream. The biggest one we have. Yeah, the big one. OK, so how do we get started, right?
Yeah, so the client, this is a really exciting client. It's so easy, but I wish we had a way to get started developing the server side really easily.
Yeah, and this would be this if somebody remembers our previous talk where we had this what every open source project needs type of question. This is gone obviously, but there is one more thing that open source project needs. And that's the npm create.
Yeah, the beautiful one-line command. And this command gives you the entire server development environment that you need to get started. And it even will output a QR code that you can scan using the Playground app. So that way you can start prototyping really, really quickly.
So I guess what we can do now is we can do another demo and see what it's like to develop with npm create Rise.
Yeah, let's do it. This is the risky one. We've never done this demo, and it's going to be pretty exciting if it works. I don't want to get your hopes up, but do try to download Rise Playground in the App Store if you have the chance. I just downloaded it.
Ooh.
I totally didn't already have it downloaded. I was an impromptu decision. Oh, so there's the QR code that we talked about.
Yeah.
Wait, but this is a local IP address. We need this to be available for the whole world to see, right?
Yeah, so normally if this would happen, like if anybody scanned the QR code, maybe it would work if you're on the conference Wi-Fi, but probably not. That's why we have this exciting built-in feature that I'm so proud of, which is built-in tunneling. We have proxy.rise.tools, which is our custom, based on open source, Golang proxy. It's super awesome, by the way.
Okay,
and,
so I'm going to scan it. If you have the app installed, you should scan it. Actually, I'm not scanning it. I'm taking a selfie. Hey.
Actually, I should make one as well, but oh.
All right. Well, we got to get to the demo. So hopefully you've all connected, or some of you have connected, and hopefully on your screen you see what I see. It says "Hello World." You just have to click like connect when it asks if you want to connect to Vibes. So Vibes, is that?
Yeah.
That's what we're prototyping
you feel
here.
the vibe?
Let's get started. Yeah, like we're going to try to like suss out the vibes, like how people are feeling about Rise tools and what we've built so far. So I think we're going to need to get started with like a little bit of boilerplate that introduces like what the available vibes are.
Yeah, so let's get started. Like this is what you see when you do npm create Rise. Like obviously there is nothing with the vibes in here. So yeah, let's go ahead and add the vibes.
Oh, they're emojis. Yeah, I was wondering what the vibes were. Yeah.
There you go. Only good vibes, you know.
Good vibes only, of course. Yeah.
So let's go ahead and maybe render them, because right now we have this hello world.
Let's get rid of the hello world. We want to show the vibes. Wow. Oh my God, your typing speed is really improved.
Thank you. I've been practicing.
Yeah.
this.
So I don't know if you see this on your phone, but I've got this like question. What do you think about Rise tools with all these different buttons to press? And then I'm also looking at this code. I see there's vibes button. It's like this is a component that's defined on the server. This is not a client component.
Yeah, so it's not only client-side components you can refer to from the server. You can also refer to other components defined purely on the server. In this case, vibe button is a server-only helper that sort of encapsulates the button logic. That's why you can pretty much organize your code on the server as well.
Awesome. So I'm pressing the button, but it's not doing anything. So we want to actually collect the vibes in some sort of server-side state. Can we do that?
Yeah, sure. So before we actually start this, we need to define the state, right? So I guess we can use the state.
Okay. So I see there's like this state sort of hook thing that we're calling, where it gives you the state and it gives you a setter.
Yeah.
It's kind of like use state.
Yeah, but it's not. This is server-side state. It gives you, syncing across different clients. This is in memory one, but we got a bunch of different ones as well.
Yeah, we have different models you can use, and state is just one of them. And here we have this like transaction function. When the send vibe gets called, we set vibe state, and we are going to basically just increment the vibe that's being set.
Yeah.
Okay, so let's go ahead and use this send vibe. Okay, so now we're going to send vibe, and also I can see there's a toast. So now I'm going to press the button. All right, so it's now interacting, and I guess it should be tallying the vibes as well.
Yeah.
It says thanks for the fire emoji.
Yeah.
Ooh.
So yeah, let's go ahead and preview these things, right?
Yeah, like we're saving the state, but we're not actually using it anywhere. Like, what if we had a screen that was going to show us all of the vibes that people are sending?
I like this idea.
From in this room and from around the world, maybe. Everyone at home is following along, I'm sure.
So look at this.
Wow.
See how fast this is?
Wow, you're a fast typer.
This is an unreleased AI version of me.
Yeah, I'm not going to read all this code right now. It doesn't really matter. But we need to sort of add this. Hide it. No, we need to add this component to our models, right? And of course, it's going to need to access this state atom that we have on the server side.
Yes.
So in our models, we're going to need to go ahead and add this new thing.
Okay.
Oops.
Working with things like Jotai on the client with React, this is pretty much it. When you call get vibe state, this will automatically subscribe to changes, so your client-side view will refresh automatically whenever there is any state change.
This is great. So it's all tied in with the WebSockets.
Yeah.
As soon as the state changes, the view reruns, and we're rendering the new screen. Yeah. So we need to navigate now to this new screen because we're not able to see it yet.
Let's do it here. I guess it's a good place.
Okay, so we're going to have a button that says see results.
And this is the showtime.
Okay, so I guess we're all going to send some nice vibes, and then you can open see results. Wow. Whoa, we're on fire. Look at this. Well, thank you for all the good vibes. Wow.
And we're not pressing, so this is not scripted.
Yeah,
you know?
usually I'm jamming the buttons, but this is truly you all who's contributing to this, to the amazing vibes. Wow, it seems like they really think we're on fire.
This reminds me of those YouTube videos that show, the stock value of different businesses changing like for 20 years. This is pretty sick.
What if we started voting for the rocket ship because we want to go to the moon? Can we all vote for the rocket ship right now? I'm going to vote. Oh, look at that.
Yeah.
Oh, we're going to the moon. Okay, this has been fun.
I think it's
thank you for
time.
participating.
Yeah, thank you very much. Now it's probably a good time to close this before it breaks.
Yeah,
right?
your whole computer is going on fire.
We
this is the server being used around the world, right?
Yeah, totally. Oh my God. The fact that I remember all the screenshots, all the key bindings here is like amazing.
Oh,
all right.
This was fun.
Yeah.
So yeah, we just built an entirely new experience and tested it on our phones within like 5 minutes. This has been super fun.
Yeah. My hands are warmed up now.
Yeah, now you're warmed up, but the talk is almost over. So
yeah. So this has been our introduction to Rise Tools. Obviously, check out our website at rise.tools.
Yeah, we want to give a huge thank you to our awesome contributors. Rise Tools is actually just a few weeks old, but we've already had some amazing people, especially Arpit, who helped make this CLI possible and gave us a really beautiful new homepage available now at rise.tools. Kohan helped make the CLI so beautiful. And thank you to all these amazing conferences that are inviting us to speak, because we really are excited about what we're doing here.
Yeah. And so you're obviously invited to join our community. Please follow us on Twitter, join our Discord server, and start our repo on GitHub, because we want to be trending. And it's a great time to get involved right now, especially if you're looking after getting to know React internals a bit, because we're trying to sort of do some very, very exciting low-level stuff that is coming up. And we will be speaking at React Universe Conf in September. So come join us. That will be fun.
We've got some really exciting stuff to talk about.
Yeah.
We hope you love this concept of server-defined rendering as much as we do. The Rise Tools ecosystem enables you to deliver incredible new experiences to your users faster than ever before. So thank you so much for joining us.
Thank you very much.
Come find us. We have stickers. We have stickers for you.
We have stickers, by the way, a lot of them. So grab them, because this is the first batch, maybe the only one. We never know, right? All right. Thank you very much. Enjoy the conference.
Yes, keep it going for Mike and Eric.
Thank you.
Woo-hoo!
Thanks.
Thank you for delivering that excellent experience for us as conference users. How we feeling, everybody? Doing all right? Woohoo! Okay. So our next speaker is going to come up and give us another great user experience at our conferences. Everyone, please give an initial welcome to our next speaker, Oscar. Woohoo! All right, and while Oscar is getting situated, just a quick reminder that if you need the bathrooms, they are at the back of this hall on either side, inside the entrance. And there are some also in the next building over, which also has the sponsor booths and reception desk and things like that. And yes, as folks are discovering, if you need to quickly grab something from the courtyard, you may do that, but I think we are going to keep pressing along with amazing talks right now. Are you ready? Yeah. Okay, so when I ask you this next question, you're going to respond like you've just had another coffee, right? Everyone, are you ready to hear from Oscar?
All right. Okay, hello, Berlin. So today, I want to take you on a journey and share the story of how did we bring React Native to Apple Vision Pro, which at the time was an unreleased platform with many unknowns. Additionally, we did all of this without actually having a device. And of course, we requested to get the developer kit from Apple, but unfortunately, we never got it. But even that didn't stop us from making this happen. So my name is Oscar, and I'm a React Native developer at ColdStack, and I'm currently working in the R&D team on React Native Vision OS. And I'm also a React Native core contributor and an open source maintainer. So let's start with a question. Who tried Apple Vision Pro before? OK. We've got a few people. Cool. So let's begin the story from the day we watched Apple review their new device. So the conference took place in June 2023, where they showed our new macOS and iOS updates. But then, at the end, they said this well-known sentence, that they have one more thing to show, and that thing was an Apple Vision Pro, which got revealed after almost 9 years without having a new device. And the keynote showcased what everyone thought the future looked like. We've got huge flying windows that you can control using your eyes and hands. And immediately, we started to wonder, how can we build apps for this platform with React? And we envisioned a world where you could port all of those awesome React Native apps, execute a few commands, and have your app running natively on this new platform. And to create cross-platform applications until now, you would need something like Unity combined with C#. And Unity is great for building games, but it's not so good for creating spatial apps. Additionally, you need to pay for Unity. So that's something to keep in mind. So who used Unity before? Raise your hand if you did. OK, great. But in contrast to Unity, React is a universal app building language. And thanks to React Native, it allows you to ship your code to 10+ platforms. So adding XR devices to the list makes a lot of sense. So our goal is to make spatial apps easy to build for any device. And that's what React is all about with their Learn Once, Write Anywhere slogan. So now let's discuss some already available out-of-tree platforms. So React Native is capable of shipping to iOS and Android by default, but thanks to awesome open source projects called out-of-tree platforms, we are able to extend its capabilities to additional platforms. So we've got React Native macOS, we've got React Native tvOS, which should be renamed React Native TV because it can ship to React Native to tvOS and Android TV. We've got React Native Windows, React Native Web, and React Native Skia, which uses the Skia as the renderer, and it currently supports Linux and macOS. And now this family is joined by React Native visionOS. And everything we've been working on is available as open source software. So you can check out our GitHub and take a look at the code base yourself. So let's take a quick look at the new operating system called visionOS, which thankfully is based on top of iOS, which made our job a lot easier. So let's start with this. Spatial apps are different. We don't have a mouse, keyboard, and what we have is hand and eye tracking. We are not sitting in front of a screen, but we are immersed in a real, by screens in a real surroundings. And we can render our content everywhere using immersive spaces. So Apple Vision allows us to display our content in 3 main ways. We have normal windows, and we have volumes, which allow people to view 3D elements from any angle. And the third option is the immersive spaces, which allows you to render your content around the user. And as you can see on the video, the user can change the spectrum of immersion. So they can set it to, for example, to 50% if they want to. And apps need an explicit user permission to enter into this immersive mode each time. And with the release of the new operating system, Apple is pushing their new way of building apps, which is SwiftUI. And this is an important detail because React Native is not using SwiftUI as of today, so we needed to do some refactoring. Last but not least, we've got ornaments, which allows us to present controls and information related to a window. And recently, Apple introduced visionOS 2.0, which unlocks many new great APIs for developers. And now we get access to the camera feed, and we can process each frame buffer to react to what user is seeing. And this has to be probably one of the most requested features by developers. So now let's talk about how we actually did it. So bringing React Native to visionOS was full of unknowns. We experimented with something until it finally started to work. So in June, the visionOS Developer SDK has been released, and we started to investigate if bringing React Native to this platform is even possible. So as it turns out, there are 2 ways Apple Vision can run apps. On the left side, you can see the native mode, and on the right side, you can see the compatibility mode. So compatibility mode has some limitations. For example, resizing increases text, background is not translucent, and the app generally feels flat. And on the right, you can see we've got the UI elements from iPhone. So for example, the alert component comes from an iPhone, but on the left, the components are styled to fit visionOS. And on top of that, we also can't leverage any of the visionOS APIs that I've just talked about. So skipping ahead to the release of the device, users want native apps. And there were even blog posts listing all of the native apps that you can download right now because they were just so much better. And in the developer SDK, we also got the simulator, which is a bit different than what you already know. Because we are actually standing in a room and kind of wearing the headset. We can look around using our mouse, click on stuff, and even change the rooms we are in. So for example, now I'm in the kitchen, and now there is a living room. And Apple did a great job on the simulator for 2D apps. But for 3D, I will get back to this later. So who tried to run their app on visionOS on the simulator? OK, we've got a few people. Awesome. So how to bring React Native to visionOS? So in order to visualize this, I've used some Lego bricks. So first Lego brick is to fork React Native. Then we need to fix the build infrastructure for libraries to even link properly. Then we can adjust the source code. We can then bring native platform features. And finally, release. So all of this seems pretty simple, right? So let's go. The first step was to create a fork. So we went ahead to the React Native repository and clicked the fork button. And that's how React Native visionOS was born. Next, we opened the Aaron Tester app, which is an internal testing application for React Native, selected visionOS as the target, and clicked the Run button. And Xcode is working hard on building our app. And oops, we got tons of issues. So let's take a closer look on why we got them in the first place. So APIs that were deprecated before iOS 15 are unavailable on visionOS. So we needed to migrate them to their newer counterparts. And on top of that, some APIs don't really make sense. So let's take UI screen as an example. So here is a piece of Objective-C code that, don't worry, you don't need to understand, but it's using the UI screen main screen API to retrieve the size of the main screen so that we can properly initialize the React Native root view. And this is not possible to do on Apple Vision because we are actually looking at the main screen. So it doesn't make sense. And Apple Vision actually has two screens, one for each eye. So we needed to shift our focus from screens to windows floating in space. And visionOS puts our app by default in a shared space. So our app coexists next to others. So in order to properly initialize React Native in this scenario, we needed to retrieve the size of our main apps window. And on top of that, users can freely resize the windows. So that's something to keep in mind. So let's talk about React Native build parts and the ecosystem around it that we needed to adjust in order to make React Native work on Apple Vision. So we have the Android-specific part, iOS-specific part. We've got the shared layer, which contains some C++ and JavaScript. And there is also Hermes, a JavaScript engine optimized for React Native. And we mostly needed to adjust the iOS-specific part and Hermes. So before that, we needed to make sure that native build tools are working properly. So CocoaPods is a native dependency manager for iOS. And CMake is a build system that's used by Hermes. So thankfully, CocoaPods received an early on support, thanks to Gabriel Donado from Expo. So let's take a closer look on how React Native uses CocoaPods. So React Native depends on many internal and external dependencies, which CocoaPods call them pods. And each of them has their own pod spec, which defines the platform support. So you can think of it as like a package JSON. And CocoaPods is the key tool for properly linking and building React Native and its dependencies on iOS. So we also need to bring CMake in order to build Hermes. So at first, we disabled Hermes altogether. But after coming back to this a few months later, we discovered that CMake was actually passing a wrong flag. So it was an issue with the build tools, which resulted in it always building for the real device and not the simulator. And as I mentioned, we didn't have the real device, so it was an issue. And on top of that, what was confusing during the work on Hermes is that VisionOS had a code name XROS before, which Apple changed just before the release. So you never actually knew if you should call it XROS and VisionOS. So this proves the point that even Apple ships some legacy code on day one. But thanks to CMake maintainers, the issue is now resolved, and the pull request adding VisionOS support to Hermes is now merged. So next, we need to adjust the code base. So here's a piece of Objective-C code that fails to compile on VisionOS. It uses UN notification, which is just not available on this platform. And the quick and easy way was just to comment this part out. And that's what we've jokingly called comment-driven development. But after that, we obviously used a proper way of commenting out code using if-defs. So the piece of code between those if statements won't be compiled for this platform. And obviously, in most cases, we need to implement a VisionOS compatible alternative, but in this case, it was fine. So after lots of hacky solutions, we finally got something on screen. And this shows a React Native app with a famous red box that's floating in the simulator kitchen. And everything looks a bit broken now, but that's what we will fix next. So after we got a proof of concept working, it was time to clean things up for the initial release. So we started off by setting a solid foundation and bringing out-of-chip platform support to React Native Community CLI. So first of all, we added support to the init command. And thanks to this change, React Native VisionOS uses the same code as React Native init, so that you can initialize your React Native VisionOS application. And then we refactored CLI platform iOS to be CLI platform Apple in order to provide a reusable set of utilities that out-of-chip platforms can use to implement their own CLI commands. And by default, we get React Native run iOS, run Android. But if you want to have React Native run VisionOS, previously you would need to re-implement half of the CLI in your own out-of-chip platform. But thanks to this PR, creating CLI commands requires just a few lines of code, and we get React Native run VisionOS. So we wanted to make sure React Native VisionOS is as easy to adopt as possible. So we made sure that both old architecture and the new one, together with bridgeless, is supported. Although I highly recommend you to check out React Native VisionOS with the new architecture enabled, as that has been our main focus. And starting probably from React Native 0.76, this will be the default. So React Native has an API called platform, which allows us to retrieve the information about the platform we are running on. And the platform.os returns the current operating system. And at first we thought, OK, let's return VisionOS here. But unfortunately, this wasn't the best idea, as most of the code relied on actually having the iOS as the platform. So we needed to add a lot of additional code to make VisionOS work again. And platforms like React Native macOS and React Native Windows change platform.os to macOS and Windows respectively, but they are a bit different and not so closely coupled with iOS. So we decided to leave platform.os as iOS and look for a better idea. So we introduced platform.isVision that allows you to check if you are running on Apple Vision. So as I mentioned before, some APIs are unavailable on VisionOS. So we've upstreamed a bunch of fixes to React Native in order to make every core API work smoothly. And don't worry, these PRs are actually merged. This is how Meta merges PRs. So this is a good time to mention that during this effort, we've been focused on giving back to the community. We did that by contributing more web-compliant APIs, better iPad support, macOS, and tvOS support. We also did easier brownfield integrations for native iOS apps, and more. So now, let's talk about bringing VisionOS-specific features to React Native. So in order to click on something on Apple Vision, first we look at an element, and then do this pin gesture to confirm the tab. And thanks to React Native, just using the platform, we got gesture handling working basically for free. The only thing we need to keep in mind is that multi-finger gestures using more than 2 fingers won't work on Apple Vision because users only have 2 hands, so the gestures won't be translated. And regarding eye tracking, Apple doesn't expose any information where the user is looking, because this is a potential privacy threat. but we can opt in to applying a hover effect when user looks at an element. And this is how this hover effect looks. And this feature has been introduced to React Native Core, by the cursor pointer style. So you can apply it to any view, but you should mostly add it to views that are clickable. And this API is also available on iPad. So if you are running React Native Core 0.74, you can add cursor pointer to touchable elements, and users that are using a trackpad will get these nice hover effects. So we also introduced Window Manager API, which allows you to spawn and manage multiple windows in your app. And you can also pass and update data from your main window to the newly created one. And recently, we also added support to Ornaments API, which users can use to attach ornaments to their windows. And on top of that, we added the default ornament that you can see here, which allows you to trigger the dev menu when running in the dev mode. And XR API allows you to blend your content with real surroundings. So in order to open a new immersive space, which is a canvas that you can render into, so this allows you to open a new immersive space, which is a canvas that you can see here. So I will get back to rendering in immersive spaces in the next section. But for now, in order to enter into the immersive space, you can use xr.requestSession. And to close it, you can use xr.endSession. And we designed those APIs by the web spec. So after a few months of work, released the first version of visionOS. On the very same day, Apple Vision was available to buy in the US. So we could start building using React Native on day one. So building things in the open is great, and the community got really involved in this project. So React Native heavily depends on community to augment core with features. So bringing new platform required us to migrate key libraries to visionOS. Thankfully, most of the libraries got migrated by awesome community members. So thank you for that. So for the past few months, we've been traveling the world with Apple Vision and showcasing React Native running on visionOS. And the reception was great. We get lots of wow moments and questions about the framework. So if you look closely, I got Mike and Eric wearing the headset here. Look how happy they are. So if you want to try it out, I have Apple Vision Pro in my backpack, and I'm happy to share it to you. So React Native Directory is a page that allows you to discover React Native community libraries. And it received visionOS support, which enables easier discovery of community modules. Last but not least, I wanted to thank Microsoft for helping us with this effort and for bringing visionOS support to React Native Test App, which makes visionOS library development a lot easier. And going back to the story for a second, around end of May, we finally managed to get the device. And obviously, we couldn't just order it. It would be too easy. We had to fly to the US, buy the device, fly back, and then customs hold the device for 3 months in Poland. After waiting for 2 months, we decided, OK, they're not going to release the device. Let's get another 2 devices while being on a trip to the US. And somehow Michał Pieszchała managed to get them through the customs this time without any problems. So after 4 months from the release, we got the devices in Poland, and I was ready to work on them. So now let's talk about going beyond 2D rendering. So RealityKit is a framework from Apple that allows you to render 3D content. And combined with ARKit, it can be used to render inside of the immersive spaces that I mentioned before. And the demo that you will see in a moment uses this technology. And the primary language for writing with Swift is, the primary language of writing with for RealityKit is Swift. But I would say that's one of the React Native superpowers that you can always fall back to native code whenever you need to. And our primary focus for the past few months was allowing developers to render 3D content using JavaScript. And in order to achieve that, we've been working on bringing Babylon.js that some of you might be already familiar with to render natively using Metal on visionOS. So in order to achieve that, we used Babylon Native. And in the previous talk I gave, I showed this simulator screenshot saying that we are getting closer, only to uncover that when we built the app for the actual device, we saw a black screen without nothing rendered. And this is the graph that shows how Babylon Native is built. We got the core, plugins, and polyfills. And we mostly needed to adjust the BGFX, which is a 3D rendering engine, to use the new Apple framework called Compositor Services. So together with Mariusz Pasiński from CoStack, we rewrote part of the metal rendering pipeline in the BGFX library. And next up, it is something that I'm actively working on right now, which is the rewrite of the native XR plugin to support the new ARKit APIs from Apple. Because for VisionOS, they changed the whole API surface, so we cannot reuse any of the previous ARKit code. So I don't want to bore you with some low-level metal rendering engine code, but why didn't the rendering work? So in short, the simulator of the compositor service that's used to compose views on Apple Vision is way more complex on the device than on the simulator. And simulator only shows the output for one eye, tricking you into believing that your code works perfectly, when in fact it doesn't work at all on the device. And funny thing is that after the first week of debugging, we got to render only to the left eye. So you could feel a bit like a pirate seeing only with your left eye. But then after the next week, we finally got it to render properly. And if you want to learn more, I wrote a pretty long tweet explaining this in detail. OK, so let's see it out in action. I've prepared a small demo app, which is open source, so you can check it out on my GitHub. So this is the application running on iOS. As you can see, it uses React navigation to render into the screen, to go into the screens. It uses a flat list to render the list of items. So now let's see how the very same app looks on VisionOS. So we've got the same list of screens. We can go into the detail, but now for VisionOS, we've added this additional button to preview this item in 3D. And as you can see, we have the 3D model of a chair that's spinning. And the spinning is actually done on the JS side using React Native Reanimated. And the gestures are done using React Native Gesture Handler. And when we enter into the immersive space, you can see a bunch of CoStack 3D models. And yeah, we can interact with the 3D space. And we can look around and change the spectrum of immersion of our immersive space. But I have one more thing to show you today, which is that React Native VisionOS is just the beginning. We want to enable React developers to deploy their code to even more headsets and make React Native the best choice for building spatial apps. And more on this topic is coming next year. So if you want to help us, feel free to reach out. So you can start building for VisionOS today and hopefully contribute some bug reports and fixes. You don't need the Apple Vision Pro. You can just use the simulator. So you can scan the QR code here. It will take you to the open source GitHub repo. Don't forget to leave a star there. So I also want to thank Michał Pierzchała for giving me a chance to work on this and supporting this project along the way. And also Matt, who is our technical guidance and poked us with the idea of actually bringing React Native to VisionOS. All right, thank you.
All right, keep it going, y'all, for Oscar. Woohoo!
Thank you.
Yes. Excellent. So a couple of notes before we welcome our next speakers. For the smokers among us, if you are headed outside to have a little cigarette, please go to the far end of the courtyard, just because if we're smoking around the building, it'll waft in and then never leave. So just a small note for that. And also, don't forget that the sponsor booths are off to the right over here. So feel free to check them out when you are out in the courtyard. But next up, we are going to welcome our next speakers, another 2-for-1 deal. Very exciting. So please give a huge warm welcome to Mina and Tanisha. Woo! And while they are setting up, don't forget that throughout the course of the day here, we are going to be having a lot of fun conversations in the hallways and whatnot. But yeah, if you can please keep those also a little bit farther outside from the entrance, then we can make sure that the people who are inside trying to listen to the talks are not disturbed. So thank you all very much for cooperating with that. And again, don't forget that the amazing thegeekconf t-shirt wearers are here to assist with anything you might need, any questions or any concerns you might have. You can find one of our volunteers in the GeekConf logo t-shirts, and they will be able to point you in the right direction. Okay, so while we are getting all set up here, I think we're all good. All right, we are going to take it away with another amazing 2-for-1 deal. Everyone, please give a huge another round of applause to Vinu and Tanisha. Take it away.
Thank you, Anjana. Okay, so take a look at these amazing looking websites and apps. Have you ever wondered what's stopping you to achieve this level of seamless perfection? What if that is miscommunication? Hi, I am Meenu. I am a developer at Geeky Ants, specializing in React and React Native. And this is my friend Tanisha, who has now started to get dev jokes.
Hi, everyone. My name is Tanisha, and I am a designer at Geeky Ants. Designer, right? OK, yes. So apart from getting the dev jokes, I have also started understanding the developer mindset while also working with my team. And that's exactly why we are here today. At Geeky Ants, we are not just about coding. We are also masters of memers, hackathons, epic trips, birthday celebration, and we also have our share of foosballs, tennis, and pool games. But if you look closely, like very closely, you'll find that secret ingredient that binds us all together, which is our passion for researching, collaborating, and building amazing things together. Meenu and I work on the same team, which is mostly in the React Native ecosystem. And even though we sit like next to each other, like just like this, we've realized that there are a lot of gap in communication that has possessed a lot of hurdles when we work in the same project. And that's exactly what we are here to talk about today. It's like when a designer says that, this is just the last change, and the developer starts becoming pale.
So this is just not coming from us. We have encountered these tweets which emphasize the collaboration between design and development. Some even say that designers should learn to code, and developers should also learn tokens and all the design terminologies. So that's why we chose this topic, bridging design and functionality. So this is the agenda of our talk. First, we'll delve into the issues that we face. Then, introduction to the solution, which is maybe one of the solution could be tokenized system. And then we'll share our experiences around how we built universal component library. And then we'll talk about the contributions of the community related to this, new standards like Figma, etc., are doing things.
Now, before we dive into the different issues that we face, first up, we want to acknowledge the fact that the designer and developer mindset are very different. And mostly, it's not like a designer versus developer situation. It's more like an and situation. And this is how a designer mind works whenever we hear any brief or any project. Like, we think about user interface and what can be added to this. What does the branding look like? What would be the UX flows? How will we maintain consistencies? And this is the primary thought process of a designer. Meenu, what do you think goes in the developer mind?
I think developer mostly focuses on the performance, like functionality, and all those API designs, and all the technical things, not at all about design. I don't think developers mainly focus on design.
Right, and that's why, given these different mindsets, certain inevitable issues arise that we want to address. For example, let's take this animation. Now, as a designer, when I look at these websites, I feel, OK, wow, these are amazing. can we add something more? Can we check the layout? How did the designer even brainstorm about these ideas? The color palettes look amazing. Can we have any global token that can change everything? Did we add audio? Is there any way we can add some audios and maybe improve the UI or maybe accessibility? Do you think if we change the layout of it, it'll look different? Can we add one more last change to this?
Designers. Nice monologue, though. So when I see the development side of it, my most favorite concern is how will this perform? Because we actually researched on 20 such websites, and the results were not that amazing that it should be. These are the average results that you can see on the screen. So, yeah.
OK. Next up, let's talk shadows. Now, when I'm designing shadows as a designer, my first mindset is about disclosing the purpose or the functionality of the shadows. And the second would be like deciding the light source. Where is the light source coming from? What is the intensity of it? Which will, at the end, result if it is a hard shadow or maybe a softer shadow. The third would be like, what would be the shadow properties? Like we have properties like blur, the spread, and what is the shadow color that we are using. But how does this translate into development?
I think development side of this is very different because there are shadows on web, Android, and iOS, and all works differently. The native side of shadows is very different from what you see in the web. So these are the APIs in React Native, if I talk about specifically. So in Android, we have elevation. And on iOS, we do have shadow color, shadow offset, shadow opacity, and radius, etc. Then, web also works very different. So if you look at this, I came across this open source shadow generator tool. So what it does is it takes the depth means elevation on Android, and it translates some properties on iOS. It has some formula, which is open sourced. So it takes the depth, and it gives the same depth as elevation on Android, and similar properties maps on iOS. So this is a very nice tool that I came across. So when I see design and development of this shadow, the first one is what she designed. And when I was actually implementing it on different devices, it didn't come as same as she designed. Because the design tools like Figma works very different. And these are designed for web-specific design, not for native. So I think I came across an idea like we should be having some shadow generator tools that is designer friendly, like you could design on that tool, and I can translate similarly, because the one that we have is for web, I think, for shadows at least.
Right. I think a tool like that would really help us and avoid any development surprises. Anyway, now let me blow your mind with this one riddle. We have 3 squares here. All are of the same specification, which is 170 pixels. Now, but as you can see through the guidelines, they all look different visually. Do you think you would notice this while developing?
For me, I would not. I'm very confused because all these have same dimension, like 170 into 170. But this actually looks very different. Like all 3 boxes looks different to me. What is this?
Right. So let me sort this out for you. In component design, we have, as designers, we have the flexibility to choose strokes which can be inside, outside, or even from the center. However, popular design tools like Figma, Adobe XD, they do not count this visual differences, as an outcome of which you can see that they differ visually, but when a developer inspects them, all the specifications are of the same. Now, this leads to a difference in visual, but no difference in specification.
For us, it's just borders, not like inside, center, outside. And you also name it stroke. We call it border. And that's not coming in the dimension of actual box. The box dimension is 170 and into 170, and border is outside that dimension.
Right.
So as you see, like we have summed up these issues into some technical, like some keywords. The first one is technical limitations versus creativity. She'll go all around, create some amazing design, which developers might find difficult to translate into code because of some compatibility issues. One could be like browser compatibility. Everything doesn't work on every browser. And other could be like framework. Like a framework can have some constraints, which is like not translating the exact design that you built on development. Let's show the second one. Maybe navigating UI UX discrepancies. So while you see the overall design, overall look and feel of the website, but when I actually develop, I tend to get into the functionality of a very minute, maybe a button. How will it perform? So due to these differences that we have, we need to bridge this gap. Right. Other one is contextual awareness. I don't have an idea what context you might be having while you are like designing something.
Right.
And as a developer, can have different context.
Makes sense. I think now that we have established the different kinds of issues that one may have, what would be the basic solution for this? First up, obviously, we should have a common language between designers and developers. And we've realized that even when we explain the same concepts, the terms differ. For example, for a designer, it's an artboard. For a developer, it's a viewport. It's a situation of opacity versus alpha, layer versus z-index, view styles, guides versus CSS frameworks. So the thing is, we need to improve communication. We need to learn each other's terms. But the problem is, where do we start? And that's exactly where we started a small side project where we address this issue. Meena, do you want me to disclose it?
Yes, I would like to, because I don't know these terminologies.
Sure. So presenting Bridge the Gap, we are trying to have a website where people designers and developers can come and understand concepts based on each other's perspective. We aim to add each topics in such a way that it becomes easy for anybody to know what's cooking in the other side without having faced the guilt of or the shyness of asking if it is relevant at all.
I think it's going to help.
OK. And the second solution here, which is accepted industry-wide, is a tokenized system. And this system is essential for fostering collaboration between designers and developers. And this is something that many companies have already adopted as a part of their design system ecosystem.
So a question might come to your mind, like why we chose to speak about this. Actually, we are currently developing BlueStack UI. And earlier, we have also experience of developing native base, if you have ever heard about that. So we have came across those challenges. And despite of we are having we sit very close and we discuss a lot of things. During native base, we had long meetings. Since we feel like we should bridge the gap, there are minute things that we miss out on. That's why we are here. One problem that we are into developing universal solution. So we have some unique problems to discuss about, and we have faced those. So one of them is modal versus action sheet. So I was talking to one of the developer. He is into some famous design system. So he was what they do in the company is they render modal on the web, and on the native devices they render action sheet. But while we were developing this solution, in a universal customizable component library, this was not working for us because we cannot be restrained towards, like, we cannot pick our opinion on something. Like, we have to be more customizable around it. So we kept it to the users, like how they want to use it, either modal or action sheet, however their preferences.
Right. Up next, we have another problem, which is like designing gradients. As a designer, when I'm designing gradients, I focus on the gradient type that I want to include. It may be linear, it may be radial, or it also may be like angular, or maybe a big mix of all the three. The other thing that I am concerned about is about the color choices. Obviously, it should reflect the brand identity. Third point would be understanding the depth, dimension, and the position of the gradient, which describes how much focus this gradient should have. But how do you develop these gradients?
OK, let's see how I developed. Actually, it seemed to me like a background gradient, which is in very trend right now. Everybody does this on their landing pages and all. So while I was translating your design, you gave, like, I had to give a lot of absolute values. And while having that fixed on all the screen sizes, I had a hard time building this. This is, I could be able to develop, which might not work for every screen size. Also, like, this is a radial gradient that you give. On React Native, we do not have radial gradients. Either we have to use some third-party libraries, which is some hack on radial gradients, or we directly use SVGs for radial gradient as of now. So that is one thing. Again, this is the web-specific solution that you designed on Figma, right, which might not work for native devices, like native development.
Makes sense. OK, so far we have discussed very common issues designers and developers face, some very common solutions, and the unique issues that we face as a part of the universal ecosystem. But let's discuss how or what did we do differently as a team. First up, instead of challenging the conventional team structure, we found ways to bridge these teams together so that communication is more smooth. For example, many of us acted as design developer advocates to ensure both the team understand each other's wants, needs, desires, constraints, and also work styles. We also formed integrated squads that promoted daily interaction between the teams and shared responsibilities for any outcomes. We had some design system leads that helped maintain design components and also document everything that anybody in the team can refer to. Apart from these team structure changes, we've also made some process changes, which is more about collaboration, in fact, early collaboration. We ensured that different teams sat together every day and collaborated and discussed on every single detail. We held regular cross-functional meetings, demos, and design reviews and developer demos. And of course, this was supported by continuous feedback loops.
There are a few other things that we took care of. One is, like, can you change the slide? So we held like common workshops and talks where we were discussing about, like, these were the common workshops that designer and developer both could attend and understand each other's perspective. Like anybody could attend those. Those were not super technical that the designer might feel a bit lag of. So we have had design meetups, design system meetups, which is combination of design and development altogether. So yes, this was the first initiative that we took, and few other things.
Right, like for example, in terms of design files, we've laid down some foundation structure. So if you see here in this flowchart, we have the GlueStack library, and we have an open source version of it. We've taken that community file and forked it and added customization and made our internal design system. Along with that, we've added components for our own repository, and a combination of this is being used in several different projects internally.
Yeah, similarly, we also have a development structure of it. We do have amazing BlueStack UI library. And then what we did was we created a template repository for the design system that had all the components already, because the components are copy-pastable components. So we built a template repository which had all the components. And then we could do all the customizations, like the brand color changes and all those design changes, token changes. Then we could get the internal design system of a product, which is with all the customization of brand guidelines. And then we could develop composite components along with that, using those primitive ones, and have your patterns set. So we have the internal design system, which has all the primitives, and composites, which has all the patterns also. So this was a storybook project that designer also can review. So that package of having the primitives and composite sets, we could use that package in different projects. So that's how.
We also have formulated different checklists for different different phases that guided us. For example, in the requirement gathering stage, we sat down together and ask existential questions, like if you're adding any components to the library, what is the primary purpose of the component? What are the core functionalities? Are there any specific use cases for this, etc.? These brainstorming sessions not only helped us develop a very core foundation, but also educated us with any terminologies that are very specific to any component. When it comes to design consideration, we had checklists that would basically not only involve the component, but also how the component interacted with other components. How should this component align with the existing design system, or maybe how are the visuals or any stylistic constraints? What would accessibility look like? And these considerations are again taken forward into dev.
Yeah. With dev considerations, I would like to highlight some examples as well. Like the first one, we have how will this component integrate with the existing ones? So we had an input component. So input components has its own functionalities, and while we were actually building new component, form control, it should respect all the functionality of input component as well. Suppose there is an error, form control should know what error did input throw. So while introducing new components, we should be see if it is compatible with the existing components as well. Second consideration would be are there any dependencies or external libraries required? So we recently have Goram bottom sheet. A huge shout out to Goram bottom sheet. So we had that incorporated in our bottom sheet. So that's third-party library integration, we call it. And third one is how we can actually design this component to be reusable in multiple places in an app. Suppose we can have multiple variants of a button that can be used in different parts of any application.
Makes sense.
We also started preparing this developer handoff. We call it spec sheet. This is the specification sheet which has all those details like APIs, all those inspirations that we took from different libraries, all the tokens, and we developed this developer handoff along with designer to help us with the design and APIs we built. So this for a specific component, we have a developer handoff ready so that anybody in the team can refer to this. Yeah. So we have also taken one step further. We have incorporated all those changes, but next step that we took towards bridging is we developed this tool DSX. We call it Design System Builder. So it makes the foundation level tokens for you So designer can also use this because it is like very friendly to designers. They can just switch it off like they do in the design tools. So we can actually decide all the tokens here itself, which it can give JSON file, which directly can be used in the code. And we can also design different components here. So it's very handy. We use it internally. The next we have is, we have also developed some Figma plugins. One of the plugin that we developed is which translate any code to like Figma designs directly. We use this mechanism. So we have the code ready, and we translate that to exact Figma file. Yeah, that's one plugin.
Yeah, I think additionally, we have also published a GlueStack plugin into the community that helps designer link all the typographies and colors into into the local libraries that are available in their design file. So basically, it's not like we're just helping them generate new Figma files. We're also helping them adapt to the already existing files. As we grow, we also understand that our community is also expanding, and we'd like to highlight some of the community contributions that have helped improve collaboration between designers and developers, including us. Let's start with these tools that have made collaboration between designers and UI developers very easy. Figma Dev Mode is something that everybody knows, and it's basically a game changer. A developer can inspect all the details, and it now comes with VS Code plugins, and it just helps developers understand all the changes that the designers has done. Talk about seamless collaboration, right? It even provide code suggestions, so yeah, that's there. There are other tools like Zeppelin and Sketch that bring harmony in design handoff. Other set of tools like, for example, Framer, Webflow, Wix. I think for me, it serves like a very nice education platform for designers, because here, without developer dependency, we can actually publish websites, but most importantly, we can understand what a developer mind is going on when they are developing something. So these also have very nicely explained us concepts of like Flex, Grid, and media queries, making it easier for designers to grasp development knowledge. And then there are tools like Rive, Marvel, Storybook, Prototype that helps in documentation and also rapid prototyping. For example, Prototype is an application which helps designer include all the dynamic changes that he or she wants, and you can test the entire user flow before it goes to any development stage. Finally, I think we've come to the conclusion of the talk, and like you can see in this GIF or GIF, whichever you prefer, all we want to emphasize is a balance is required between the design and the development team, a balance of mindset, a balance of collaboration, and a balance of communication. Achieving this balance ensures that both of the teams are working harmoniously maybe with some banter, but yeah, leveraging each other's strength and creating seamless experiences. It's all about blending creativity with functionality, aesthetics with usability, and innovation with practicality. This is the equilibrium that drives any successful projects and fosters a thriving environment for both designers and developers.
True that. So before we thank everybody, would you like to thank us for listening to you, all the developers?
Right, yeah.
Which we do not usually. OK. If you want to see all banter, you can connect us. We can connect.
That's all. Thank you.
Yeah, thank you. I think she'll come.
Keep it going, everybody. Thank you so much. Everyone, big round of applause. You know how it works. Yes, exactly. All right, so I see we've all been enjoying a little bit of the sunshine out there. If you did not hear my little memo earlier, if you are enjoying some tobacco or whatnot, if you could please keep it away from the entrance to the building so it doesn't waft inside, please go over to the street side of the courtyard. And another quick note, if anyone left a laptop outside in the courtyard, the volunteer desk, the registration desk, has it. So if you are missing a laptop, I salute you, because sometimes I want to throw mine right in the trash. You've all been there, right? But yes, we do have it at the registration desk, so please come claim it. All right. I believe without further ado, we're going to welcome on our next speaker, who is going to keep this party going for us. Everybody, please put your hands together. Give a huge warm welcome for Kitze.
Hi.
And a quick note, don't forget to stop by the sponsor booths. We're also going to have, after this next talk, we're also going to hear a quick word from one of the sponsors. And yes, if you find yourself out there and you want to have some chats, find out more about all of these amazing companies that are making it possible for us to be here today, they will be out there at the booth. So while we are getting set up, if we can also take another moment to give a huge thank you to all of those sponsors, because this stuff does not come for free, am I right? So please give a warm welcome to our next speaker and a big shout out to our sponsors with a huge round of applause.
All right, is this thing on? Hi everybody, I am Kitze, thegeekconf on Twitter. That QR code has been done a very long time ago on a very shady website. So if you scan it, you might get a virus, or it might take you to my blog. You can find me on Twitter. That's the safest option. I'm from Macedonia. I live in Poland. I stopped using any of these ways to describe myself, and I call myself just a rectangle mover. I think more developers need to accept this is what we do. We take some JSON and we paint some rectangles. It's not more complex than that. I was wondering whether I have ADHD or not. And I Googled ADHD tests, and I bailed in the middle of the test, which basically answered my question whether I have ADHD or not. I'm working on way too many things at once, and I forgot to include a few here, which is recently I became a father. That's the most important thing out of these side projects. And a new thing is I started a rap reaction channel. Like, I'm already packed in life with so many things. I'm like, I should also react to rap songs. So I'm all over the place with my ideas. As soon as I get an idea, I just pursue it like a golden retriever. I don't stop and think like whether it's worth making or not. And one of the best ideas that I had, and one of the things that I've been living from in the last few years, has been CISY, the browser for developers. So a torture exercise I want to do to myself at every conference is to ask people who is actually using this. And usually there's like 2 people in the back, usually some employee or ex-employee of CISY. So that's my torture exercise. The project I've been focused on for the last 2 years is called Benji. I'm not going to even bother with raising the hand, because you're developers. If you're not using CISY, you're probably not using Benji. I made an app for myself, like a life OS that combines a to-dos, calendar, habits, Pomodoros, and I have to read these because there's like 79 features. Meal tracking, hydration, packing, goals, mood tracking, journal, fasting, workouts, and a billion other things into one app. So this is the thing that I've been focused on. And I also released a course. Yes, the mascot is made with Midjourney. That's why it has 3 mouths. It's supposed to be a boat with a mouth, but it has 3. But sometimes it drives clicks because people make fun of the mascot, and they actually bring new customers to the course. So I'm guilty for not doing a technical talk, because most of the speakers will be doing some sort of technical talk. So I'm going to do 5 quick ones, and then we're going to get started. So the first one, I'm going to pretend to leave the stage, and then I'll come back. All right, how to build an Electron browser from scratch using Electron, Next.js, and MobX State Tree. Don't. Your mental health will thank you. Thank you for attending. All right, next one. Woo! The missing explanation for use effect. It's still missing. Thank you for attending. All right. Next one. You need to applaud. Thank you, whoever applauded. What's new and exciting in React? Nothing unless you're the fake. They keep releasing stuff, but no one is actually used, so whatever. Thank you for attending. One more. This is the last one, I promise you. Practical use cases for Web3. Thank you. Thank you for attending. All right. So my talk is called GitHub Stars Won't Pay Your Rent. This is an article that I wrote at this point, I don't know, 5 years ago or something, and it goes viral on Hacker News like clockwork every year. It's a bit of a longer article, but I would recommend you to read it, because you're going to see the difference between more hopeful Kitse. Like back when I wrote this, I was like, fuck yeah, we're going to build startups, we're going to crush it, blah, blah, blah. And now 5 years later, there's a little bit more of the bitter, angry Kitse. So there's a difference, even though the talk is titled the same, there's a difference between the article and the talk. So my 2 goals with this talk, and you're going to forget about the second one, I guarantee you that. The first one is to motivate you to properly start charging for your work. Whether you have an open source thing or a startup or whatever, you need to increase your prices. This is going to be part 1, so I'm going to get you hyped up to the point where you forget, wait, he said there's going to be a part 2. And there's going to be a part 2 where I'm going to discourage you from making paid things. So everything I ever worked on was for one reason. I just wanted to build solutions to my own problems. This is a little bit stupid sometimes because you cannot always prioritize this, but good things have come my way because I followed this mindset. Like recently I released this because I was wondering, like, I have a closed GitHub repo, and I want people to be able to pay to get access to this boilerplate or whatever. Why isn't there a solution for this? So I sat down for a weekend and made this where you can like connect it to Stripe or whatever, and suddenly people can pay to access your GitHub repo. It's just like a golden retriever chasing an idea, and you release it and you move on. But one of the first ones I released was, this is 2016, so I wanted a list of all of the commands that I can ask my Google Assistant, basically. Back then, there was like no ChatGPT. It was like a list of commands. Even Siri right now is dumb to a point where you have a list of things you can ask, and if you ask in the wrong way, she's not going to answer. So I was working on this for probably a month, and I was going to a co-working space, and people were like, why are you wasting on time on this bullshit? I was tweaking the animation, like the intro animation is a little bit crazy. And they're like, what is this going to bring you? And I'm like, I don't know. I just know that I want it, and when I want something, I'll freaking pursue it until I finish. I didn't even think like, wait, there's no way to monetize this. Like the only benefits of this is like, some grandma will learn how to set timers. And I still get emails to this day, people blaming me for the Google Assistant not working properly. They're like, I told you to do something and this doesn't work. I'm like, I didn't make it. I'm not the maker of Google, for fuck's sake. So, but I didn't expect this benefit, like out of nowhere, randomly. Like I was nobody, I didn't have following, I had nothing. And it got featured on TechCrunch. I didn't plan this. So I was just pursuing a dumb idea. TechCrunch liked it. They're like, look at this list. And suddenly brought me more followers, and suddenly snowballed into like more things happening in life. But it wasn't any plan of some it wasn't like a part of some grandmaster plan. So a lot of people ask me and DM me actually about this freaking thing, and they're like, how do you get followers? How do you get success? How do you get this? How do you get that? And I like this mindset, even though sometimes it's a bit stupid, because money-driven for a lot of people goes first. They pursue money, they're like, I want to chase money, so I should do the things that actually bring me money. I was always solution-driven to a fault, actually. Like, I'll find something that needs a solution, and I don't even think about monetizing or whatever. That comes later. I just want to solve it right now, and we'll think about stuff later. And most people have this twisted, like, I keep saying this, like, build things and document them wherever you document them, on Twitter, on a vlog, or whatever, and good things will come to you. Hashtag build in public, that's the hashtag that people use. But most fuckers get this wrong. They just are in public. They're like hashtag build in public. I'm like, you're just in public, you're not building anything. So you'll find them 90% on Twitter and 10% actually building something. And they're like, this formula doesn't work, bro. It doesn't work because you're not doing the build part. It's actually like 2 problems with this approach. You think that your problems are not worth solving, and like 90% people, they have this. Like you think of something, you're like, but this is not worth solving. Like, who's gonna use this? And second thing is like, you don't see things as problems. So nobody else has my problem is a very wrong mentality, because you're thinking, and I'm thinking, anytime, even with new ideas that I have, I'm always thinking of my closest friends, like Twitter people. Like, you close your eyes right now, and when you think of releasing something, you're gonna imagine how the people closest in your bubble will react to it, right? Your mom's not gonna get hyped about anything that you build. She's always gonna tell you to get a job, right? Even if you have a job, she's gonna be like, yeah, we could have gotten a better job. So like, don't think of the bubble, don't think of the Twitter friends, don't think of your mom, just think of, you know, a little bit outside. So 2 types of people I mentioned. Most things are not a problem, and finds a problem in everything. So on the left is my sister, on the right it's me. It's one of the reasons why I moved out. My parents thought, oh my God, he's so ambitious. It wasn't. I'm going to tell you why I moved out back in the day. We had 2 remotes, one for a DVD and one for a TV, and they both had the same batteries, and one of them died. So my sister, for a freaking year, she was swapping the batteries a few times per day whenever she needed to use I was dying in that room, like just seeing her casually. She's like, what? It's not a problem, chill. So I cannot, like, because my mentality is like, I need to solve everything. Down to a point, I'm cutting cherry tomatoes, and you know those fuckers, they splash in your face, right? You've never eaten a cherry tomato without some of it getting in your eye, right? So I'm trying to cut it, and I'm like, there has to be a fucking solution for this. And I present to you, I mean, I love my family, but I love this more than my family. You can find it on Temu, AliExpress, whatever. I use this every day. It's my favorite thing, dude. You load it with cherry tomatoes, you do like, and it slices all of them. So once I think, like once I get this idea that something might be easier, it's over. And then when I have the solution, there's no way I'm going back to the knife. So I did the equivalent of that, just like the software equivalent was actually the birth of Sizzy. Why? I was working for clients, I was freelancing, and my client was like, we need this web app to be perfectly responsive. And I was like, cool. I was using Google Chrome back in the day, and I would open, you know, the regular view, and I would switch to an iPad, I would switch to an iPhone, I would switch to a phone. 3 times I would switch, and I'm like, wait, this is how I should, like, how will I know if it works on all of them at once if I keep switching them? So I was like, this is what I've done. This is literally a tweet from 2017. I put a bunch of iframes on a page. That was Sizzy version 0.001. A bunch of iframes on an index.html page, and I tweeted, hey guys, does anyone want this? And a bunch of people were like, oh, cool, I would like to see my website. And that's how it snowballed into what Sizzy is today, like a full-fledged browser for developers. But then as we kept developing, like people always thought like, okay, this is the line of innovation. There's nothing he can add more to this. But I always was like problem-driven. Like anytime I would have a problem in Sizzy, I'm like, this should be solved with a few features. So I would call it like a problem-driven development. Like I was tired of switching between users, like logging in and out to try the admin, to try the guest, to try the other user. And I'm like, why don't we give these frames like different sessions? So you can choose like, you can look at your admin and a few other users at once. So it became not a thing only for responsive design, but you can test across multiple scenarios at once. And this was literally happening every once in a while. The customers will be like, we want this, but I'm like, yeah, but I have a big problem and I want to solve my big problem first. And a lot of times they don't even know that they had the same problem. They're going to see this and they're going to be like, oh, cool, I didn't think I wanted that. So of course I was tired of course. Everyone is dealing with course issues. Applause for the pun, please. No, don't. It's a shitty pun. So there's a button to just disable course. You can be like, I can disable course for localhost. It's going to work fine. Tired of Googling how to kill a port? There's a kill port thingy. So this is, I'm tired of driven development. I'm using it in everything. And it's a little bit shitty when you prioritize your own problems over the customer problems, but it has proven as a strategy that worked. Because like when you think about like the invention of the ATM, like people were fine with going to the bank. No one was sitting at home thinking like, oh man, it'd be nice to get money from a machine, right? And then they invented it, and probably I assume back in the day there was no hacker news, but there were a lot of haters. I don't know where, in newspapers, in magazines, they're like, fuck that, I can just go to the bank. There's always a haters who are like, I'm gonna do the thing manually because you don't know you need some. Someone needs to invent something for you to be like, oh shit, I might need that. So problem-driven development. When you solve a problem, we have this classic Shakespearean deal. You solved it, right? I solved Sizzy, let's say, as a problem, and I always like have this dilemma: should we open source or should we not open source? So a lot of people keep doing this thing, like they open source all the things, and it's like I wouldn't be here, like I wouldn't have any products without open source, and I'm thankful for everyone who's done open source, and I've done open source in the past. But I think why people choose it a lot of times is because the path, like you have this solution here, you have solved the thing, and now you have the path. The path to open sourcing it is like one click, right? You publish on GitHub, you're like, it's live, you go prepare your tweet, you add a bunch of emojis, you're done. You're happy for the day, right? Because you want to get to that finish line faster. The path to actually making it a paid product, it's a giant pain in the ass. You need to think about integrating Stripe and customer portals and a bunch of other things, and a lot of people don't want to take the long path, so they'll just take the short one and they'll open source the thing. So that's what I did. We open sourced Sizzy. And over the course of, I don't know, less than a year, got 5,000 stars. It was product of the day on Product Hunt, and also they had some summer, like product of the summer. We were ahead of Raspberry Pi. Like Raspberry Pi was below Sizzy. Isn't that bananas, raspberries? No? God damn, you're hard with the puns today. Thousands of active users, and you might think, okay, all of these metrics, they make sense. Number one on Product Hunt, so many stars, right? So many active users, because on the Chrome extension you can actually see users, so it must mean money. So I'm going to ask you to do a little drum roll like this, and I'm going to tell you how much Sizzy made as an open source product for more than a year. There you go. A year of dealing with pull requests, closing issues, commenting on issues, like so many requests that people have in open source, like working all day, every day, just to make $92. And you're like, okay, there's something, this doesn't make sense. I mean, nowadays, with the way that I do open source now, it makes perfect sense, because most of my repos have that yellow thingy, like, we detected a vulnerability, something, you're gonna get hacked or a virus, whatever. And my FAQs look like this. I just cannot bother, just read this. You're like, hey, does this, no, do it. Open a pull request, but I'm not doing any of that. So now it makes sense that I have a single GitHub sponsor paying $1. I think he even churned out, but whatever. But back then, it didn't make sense because I gave everything to make this open source. There's so many active users, and you only make $92. So here's my wild and crazy theory. I never thought of this, right? If someone hands you a sandwich at the airport or whatever, there's like two reactions. First of all, it's a free sandwich, right? First of all, you'll be skeptical, like, is this good? Is it going to poison me? Second reaction, no one has said, no, I don't want this for free. I'm going to pay you $30 for this. Everyone will be like, fuck yeah, free sandwich. So the same applies to software. So the same thing repeated with Benji. For a while, I was like, I'm going to be Mother Teresa. I had this wild goal in my head that I'll make a life OS which is going to give you your habits and calendars and everything, and you're going to fix your life to a point where you're going to stop using all these bad things like social media and TikTok and YouTube, blah, blah. In my head, bro, I had like a freaking discussion that one day this is going to get so big, this is going to disrupt the usage of TikTok and Twitter, all sorts of things. Like, nothing happened. It's been 2 years. There's no disruption happening. And I was like, I have to give this away for free, most of it, because I want this to get to so many people who are going to improve their lives. Reality was like, people didn't care, and I was working on something that didn't make a lot of money. So slowly I made like an optional pro plan, and it started to make a little bit of money because it was optional. I'm still, droning on the optional thing because you give people the option to pay. And after, it's been almost 2 years, and in the last month I was like, you know what, fuck it. I'll just make this, you get 7 check-ins for free, so on any 7 days you can just use it, and then it says like, hey, if you want to join our app, you can continue with this plan or with the other plan. And you'll be mind blown. It actually started making money. Like, it's such a simple concept. You take away the free option, and you're like, okay, I've used this for 7 days. I liked it. I'm going to start paying for it. And if you're skeptical, like I see some skeptical faces in the audience, like, no, bro, I pay for my software. I always pay for things. Really? Have you seen any of these sliders? Let's be honest right now. Who has dragged this to the right side? No one, because on the right side, no, you haven't. Put your arm down. Because when you drag it to the right side, there's going to be a bunch of dust popping up. Like, no one has touched the right side. You're pulling this to the left. Even if it's $1, you're pulling to the left. I want it to be 0, right? You don't want to pay. So no one has paid for things that are given to you for free. So a few years went by after CZ. I didn't develop that many websites. I started doing conference talks and workshops and blah, blah, blah. So I didn't need like a browser. So after a while, I stopped with that and I started developing websites again. And the perfect storm has happened. So I started developing websites. I couldn't go back to a regular browser because it would be like going back to slicing the cherry tomatoes with a knife. It would be annoying. But Sizzy was in such a shitty state. It was like a Chrome extension, which doesn't give you all the power. Like it doesn't simulate like the real thing. Then I got a DM for Praneet, which was actually the first employee who DM'd me, hey man, I want to make more money in life and I want to, succeed and do this and that. And I was like, how about we make this together? So we turned it from a Chrome extension into a full-fledged Electron browser. And the last one was I tried to use GitHub stars as a payment method, but that button wasn't there, so I was like, fuck it. We're going to have this classic Shakespearean dilemma, which is like very hard, especially when you have many stars and many users. Just closing this repo was actually a very hard decision. First of all, because I kept thinking, so now we went from nobody else has my problem, right? You prove that people have your problem. You see the analytics, you see the downloads, you see all the things, and now you keep doubting yourself, well, yeah, but nobody's going to pay for this. Like, who in their right mind is going to pay for this? No matter how much proof you have, you're not going to think of this. Because again, we're thinking about our bubble, and we're not thinking about the world. So when we launched CZ, I was just sitting there with my jaw dropped. Like, when I remember the moment when we got a sale from Japan. I'm like, I don't know, I don't have anyone in my closest Twitter bubble from Japan. What is going on? Like so many random companies and stuff, and we're so fixed on, can I sell something to my closest circle? Not thinking that people in the world, millions of them, actually have the same problem, and they would pay a price to solve that problem. Now the question is, what price would they pay? I had the same thing with Sizzy as I have with Benji, the Mother Teresa thingy, where I'm like, this should be as low as possible because every developer in the world is going to use it. It didn't happen. No matter how you price it, like the price was very low, and still developers who decide not to use something, they're not going to use something. So the idea was I wanted to get this to as many people as possible, and also we're competing against free browsers. We have Chrome, Firefox, all of these other browsers which are free, and now you need to convince people to pay for your browser, which is a little bit insane. So we decided on something that in retrospect is a little bit stupid. It was $5 per month. So when I talked to investors, when I talked to they were laughing. They were like, there's no way this is your pricing. Like you have a huge features page with like a bazillion things, and then when someone's going to see $5, they're going to be skeptical, like, are they stealing our data? Like, what are they doing? Like, why is this $5? And it's actually true. Like, when you get the free sandwich, right, you're immediately skeptical. Like, it shouldn't be good if it's free. So we had that effect on CZ. So I realized this as a conclusion, that there's people who get it and people who don't get it. And people who get it will pay any price, the $5, the $9, the $19, they're like, oh my God, this saves me thousands of hours. Like, I'm actually gonna pay whatever price. And there's people who don't get it. You can just get it down to $1 or like whatever price it is. They're just not going to use it. And this was actually proven with GitHub Copilot, right? In the beginning, everyone was like, oh my God, GitHub Copilot is so... Oh, it's $10? It's not that good. I can just write my own code. It's fine, right? So we decided to actually close the open source app and make it paid. And immediately the mob started like, no, boo. Like the Chrome extension ratings just immediately went down. They're like, no, it shouldn't be like this. And everything should be free. And this is not fun. But these are some valid complaints, right? People are like, I want to pay only once. I'm going to make my own version. Isn't this literally Google Chrome with, my favorite part, isn't this literally Google Chrome? And then I'm going to list like 50 other things with 50 other things. Yeah, it makes sense. Desktop apps shouldn't be, like I agree with some of them, but people take too much freedom to tell you online like how much you should charge for your own thing, right? Like translate this scenario in real life. Imagine you just walk into a supermarket, the cashier just chilling there on her phone playing Candy Crush, whatever. You enter the supermarket and you start saying, I can go to the other side of town and buy a cheaper milk and I can raise a cow and she'll be like, yeah, okay. Do that. But people online will tell you, no, you should price it lower. This is how you should price it. So anyway, we closed the open source repo. We priced it what we priced it. We launched it. And the launch was actually the best part of this entire journey. This is how I felt. I've turned on like a ka-ching sound every time I got money from CZ. It was like mind-blowing that you're finally making money from something that was open source for a while. So the payment provider, I was using paddle.com. They actually blocked my email, my IP address because I was refreshing the money like so often. I would just command R all the time and they're like, IP blocked, please try again later or whatever. It was crazy. My wife joined after a while as a full-time not employee, basically. We were like kind of like co-founders. She was doing a lot of things, including she decided to dress us like Sizzy vomited on us, like from top to bottom. She made merch. She was so excited about all of this, and I'm super thankful that she helped me with everything. So until now, you forgot about part 2, right? I got you hyped. You're like, some people here on their phones, they're probably texting their boss like, fuck you, I quit. You're closing your repos. You're going on Tinder. I'm going to find a wife. She's going to get us merch. We're going to make, right? But don't forget, we have part 2, right? From this moment on, this will be you for the second part of the presentation, which is called Fuck Having a Startup. So let's start. Also, I hate the word startup. People will make like a localhost 3000 thing and they're like, launching my startup. No, you're not. It's an app. Whatever. So let's start with the basics. I tweeted this, and it's still true to this very day. I know engineers around me who make more money than I am with my startups, and it's freaking annoying that people don't agree with this. So when I tweeted that most engineers with a salary make more money than startup founders, people got mad, and these were the replies. So no, actually, before the replies, everyone secretly is craving to write a tweet like this. I can guarantee you, when you see other people getting to any MRR or anything, you're like, oh, I wish I could just write all of those emojis. It would be nice, right? So some of the replies on the tweet were, I'm going to read, it's not about the money. It's about ownership, doing things your way. You're motivated and fulfilled work gives them meaning. This will put more effort, blah, blah. This replied you. They're making a dent in the world. The only dent is in my head from reading Electron documentation. There's no dent in the freaking world. A lot of us came here because we simply love to build things. Why not act on your own ideas? And my favorite reply, and this guy has been in these slides for years at this point, it's nice being able to do what you want. This is bullshit. Doing what I want? I woke up one day to an email from a customer. This is a screenshot. I'm not shitting you. This was an actual email. Dude, this is in the subject. He didn't even bother to write in the body. Like, this is in the subject. She's like, fuck you, this shouldn't be paid. Doing what I want, this is what I want to wake up to every day. So the DJ Khaled GIF, like the celebration is right there. And inevitably, no matter how many products I launch, this is always the truth. Like, you get hyped until you launch it, and then the hype dies down, and you have to deal with customers and bug fixes and all of the things, and you inevitably burn out, especially if you're bootstrapping the thing. And if you don't trust me, I put a second shitty chart, which tells you that it's actually 90% not fun, and it's 10% fun, only until you launch it. Because every job has the job part that sucks. When we see like superhero movies, we see Scarlett Johansson, she's the Black Widow, but she also has to go on Hot Ones and eat wings and be turned into a meme forever and burn her mouth just to promote the thing, right? Every job is actually sucky in a way. Like even, I don't know, the Queen. Is it too early for that joke? Because she doesn't have a job anymore? Whatever. Customers. I'm grateful. Actually, no one raised their hand, so there's no customers here. I can freely talk bad about customers. Like, they will find all sorts of ways to turn your day into a nightmare. They'll always send an email. Bro, you cannot hide your... You know how nowadays it's very hard to find emails on a page. You got to go to the footer and to the docs and to the thing, and you need to dig for the email. They'll find it. No matter what, they'll find it because how do I know? Someone emailed us, hey guys, you don't have an email on your landing page. How did you email? Did you guess it? Like, how did you freaking, like you'll get all sorts of payment requests. Like the amount of things, like sometimes I stare at an email, I'm like, how did you even, like what is going, like they have things like this. Hey, this is the simple one. Crypto, like any coin out there, shitty coin, dog, whatever coin, they're gonna ask you if they can pay with it. Or they'll be like, hey, we're on a team plan, but on a 3 plan, I was on a trio plan, I wanna change, but add the discount, and someone is in Germany. They'll write the most complicated thing, and sometimes, I swear to you, I just give them for free. I'm like, take it for free. Just, I don't wanna deal with the logistics, just please don't email me again. And of course, this is a browser, so we have the classic, like where do they find even these Linux distros? Like there's so many versions of Linux and whatever where CZ doesn't work on, it's annoying. And we have discounts, which is partially our fault because you get hyped, right? The first Black Friday comes along and you're like, oh my God, we're gonna have a Black Friday discount. And then you're like, okay, but also Halloween, why not? And also Christmas, and suddenly it snowballs into like having so many freaking like we had, I don't know, a Kim Kardashian got divorce discount, like so many reasons for discount. And then people who want these discounts fine, they want to stack them. Someone was like, hey, I got this for the Halloween one last year, but there's Black Friday one, can I stack the two? And I'm like, let me pay you for the app at this point. Like, no, you cannot stack them. But I want to thank my wife again for the politeness. If you ever use CZ and you received a customer email that's long and nice with paragraphs, it's my wife's email because she's super polite. If I would be in charge of replying to every customer, most emails would look like this. I just can't. I can't. It's the button is there. Just search for it. Don't email immediately. Next, we have the second one. Yeah, I worn a CZ shirt at a conference only once, and even just, I want to tell this story to motivate people and whatever, I cannot tell it without mentioning the products. I feel like, as a developers, we always find talking about your thing cringe, right? And Shakespeare agrees. So when I say fuck marketing, I mean particularly to this lovely group of people, including me, I'm also a developer, because we're the worst audience to sell something to. Like it's almost impossible. My next product that I'm gonna make is gonna target everyone in the world, including, I don't know, snakes, lizards, whatever, but not developers. Like they have all sorts of experience. I can build this by myself. I can do this in 5 minutes. I like it. They just invent all sorts of things. And I mentioned the GitHub Copilot example. It's good until it's paid. Then it's like, no, I don't need it or whatever. Next, we have hiring. So I've done one round of interviews in my life a couple of years ago when I decided I'm going to grow the team, there's going to be more people, yada, yada, yada. And then I had to hire people. This was on Upwork, so, you know, take it with a grain of salt. And these are some of the experience that I had with interviewing people. This is literally, I tuned to the first call. The guy's late. He's on a balcony. He's zooming on his phone on a freaking balcony. And he's like, yo, bro, let me just finish my cigarette. And she's just smoking on the balcony. I'm like, all right, you're not getting hired. Next, I have an interview with a woman, she's in a cafe, and I'm really trying to hear what she's trying to say, but all I'm hearing is, but the player's gonna play. Because I hear the music, there's no audio setup, microphone, nothing, and we can barely have a conversation. Next interview I had, in the middle of it, everything was going good. I don't know how we got there. It was like a blink and we got there. This woman started convincing me that COVID was a hoax. She was like, and the vaccines and the hospital. And I'm like, okay, I don't know how you think you're getting that job. And the last one, there were some connection problems. There was something, it looked like a basement scenario with a chair or whatever. I see only like a black picture. I'm trying to make, you know, who's talking out of there. And I just hear like, hello. And I'm like, I would love to interview you, but are you kidnapped? Should we call 911? Like, what the fuck is going here? So that was my hiring experience. And I can go on and on and on. There's like so many other things, like meetings and electoral bullshit and meetings and writing a privacy policy before ChatGPT, okay? Now you can just tell it to write you. But all of these things and meetings are a thing, even when you find your own thing. Only that you're the asshole who schedules the meetings. Then it gets worse. So let's go through them again. And move here. Why don't you just hire someone? Everyone has this stupid solution, like money. That's why you cannot, like you don't make enough money to hire someone and to make sure they're going to get a stable job. So we have this class, he's tired of me, Shakespeare, probably at this point. Like, should we go VC or should we keep things bootstrap? I talked to so many people who wanted to invest in CZ, but they asked me, can you focus on one thing? And you remember the golden retriever ADHD slide? No, I cannot. I always answered, no, I cannot focus only on CZ. I have too many things boiling that I want to make. So, and second thing is like, I'm afraid of losing control because I'm pretty sure if we ever got an investment, CZ would turn into like a KFC ad and it would have NFTs and timers, like you cannot use it after 3 seconds or you have to watch this ad or whatever. So you think, oh, it must be nice to keep things in control. You don't have a VC, you don't have a boss. I keep droning on this point. Like this is so overvalued. I don't even know how to say it. Because I was like, ever since I was freelancing, I was just dreaming. When I had a job, I was dreaming of being a freelancer. When I was freelancer, I was like, no, I don't want anyone to tell me I want an empty calendar. And one day you find yourself with an empty calendar and you don't know what to freaking, like, it sounds bad if you have 17 meetings this week. You hate me for saying this. But even with an empty calendar, it's, you know, you think it's going to free you up, but it actually, it's not that relieving when you have to figure out, okay, what do I do with my week? What do I do with my day? So the pros are planning your own time and making your own decisions and planning your own tasks. And the cons are the same, planning your own time, making your own decisions, and planning your own tasks. Because a lot of days, you would kill for someone to give you a daily CSS puzzle or a task or whatever. You finish it, you go home at 5 p.m., you watch, I don't know, House of Dragons or whatever, and you chill. This way, you don't know when does your workday start, when does it end, when, like, you know anything, you're left on your own to figure shit out. Like, this is way over, like, everyone wants to be like, I'm the CEO, whatever. Like, we planned, back when I had a job, we planned, one day we're going to quit, we're going to call an orchestra and trumpets and fuck my own boss. And people think, like, there's only working for someone and working for yourself. But in between, there's working for someone better. Like, if you don't like your job, doesn't mean you have to be the next indie hacker or whatever. You can just find a better one, a better scenario. Because at the end of the day, you'll always be working for someone. For me, it flipped from working for a boss to actually working for customers. You have to work for every single customer. They have complaints, they have things that you have to fix. So eventually you turn around and suddenly you have thousands of bosses who actually want to tell you how to do things. So everything seems more glamorous from the outside. Do I have 2-3 minutes left? Can I wrap up? Yeah? Got it? Okay, so we're going through slides. So hiring people, huge responsibility, because you have to plan their work days. You have, like, I would think, like, if I want to be a good boss, I'm going to let them do whatever they want. Most people don't like that. They panic. They're like, no, give me instructions. What do I do today? What do I do tomorrow? So I started building this, like, prison walls for, while building this startup, I felt like, you know, what am I doing? But prison has more benefits than being a founder, and this slide is a proof for that. So yeah, so because we don't have time, I'm going to skip the story of how I was so stressed that I almost got hit by a bus, but let's just skip that one. I would say that on some days I want to quit, but on most days I actually want to quit. And it feels unfair to quit. It feels like after so many years, so many customers, it feels unfair to just be like, no, throw in the towel and just be like, I'm going to get back. I want to escape and build something else, but I remember this chart. If I go back, it will be fun until here, and then the slide begins, and it's a cycle. And yeah, like this sounds a little bit, you know, you thought it's going to be easy peasy. I'm going to do this and that. I'm going to buy a Tesla and stuff like that. It's not that easy. You know, what you don't see is you don't see the behind the scenes, how stressful the journey can actually be. When you have something paid, you have so much responsibility. This is, you know, a bit lame and corny, but it's actually freaking true. And I don't want to feel the way that I feel during COVID, like super stressed, super anxious. Few final slides, like 3 final slides. There's no next level. I always thought there's like a next level. You can make the current level where you're at. You can be happy at the current level. It's fine being number 2. Actually, I would say number 2 is the shit. Not one pun you laughed at, goddammit. And happiness is a mindset. This sounds like also another corny thing, but it is. Knowing all of this, last slide, somebody asked me at a conference, knowing everything you went through, would you do it again? And I hate the person who asked me that question because I have no freaking idea. Thank you. Scan that QR code. Follow me on Twitter. Sorry for taking a bit more time. Enjoy the conference.
Right. Thanks so much. Keep it going. Yes. All right. Woo-hoo-hoo. So we are chugging along with our action-packed schedule today. Next up, we are going to hear from some of the sponsors of the conference. So everyone, please give a huge warm welcome to Sarav, who's going to tell us about Engage. All right, and keep in mind that we are going to be keeping it rolling with the talks after these sponsor talks are done, so don't go anywhere. And if you have more questions, the sponsor table is over that way for after when we have the lunch break in about an hour. So we are going to be hearing from another member of the massive, amazing sponsor group that we have to thank for getting us here today in a moment. But we will keep going with the talks without much more fanfare. In the meantime, just another reminder that we will be having a little lunch break later in the courtyard, and that will be a great chance to talk to not only all of the speakers that you've seen so far and who are going to be up on the stage in a moment, but also our sponsors, should you have any questions. So without further ado, please take it away, Sarav.
Yes. Oh. No. No. I think. Oh, technical glitches are always there. So let's see if I can solve out. Then slideshow. No, still not. I get something else. I just put it on mirror. Screen mirroring.
Let's take this opportunity to give another big thank you to the amazing audio, visual, tech team that is making this show so beautiful and making you listen to my very loud voice in this very echoey hall. So you're welcome.
Oh, okay.
All right.
That's better.
Computers. Woohoo! All right.
Let me take that off. And this is Saurav from Ant and Cage, and I don't know if you've had a talk with Tanya. That's one of the bots from Ant and Cage. We've put it together for GeekConf specifically. It's on the QR codes that you see with the information name written all around here. And who we are a small company of 6 people right now, and this is what we do. We are trying to look at customer engagement in the AI space with a completely new viewpoint. What makes us special? We do the usual stuff of multimodal, et cetera, et cetera. For example, when you talk to Tanya and if you ask her for directions for how to get to the lunch area, et cetera, that's basically Tanya speaking from a JPEG file, a map of this space, and it gives you directions based on a JPEG file. So we do multimodal, usual stuff, but then what do we do extra? We do emotion analysis, and that's brilliantly useful for businesses. So when you have calls been taken by the AI, you actually get an emotion report of how much is likely of a conversion for a sale or marketing call, et cetera, et cetera. Intelligent callbacks. So if you're talking to the AI and you tell them, like, I'm driving, can you call me in 30 minutes? It recognizes, reschedules the call in 30 minutes, or says, if you say, oh, just never call me, it understands that you're not interested in that particular product or something. It's filed in and stuff like that. We use a multi-layer LLM at the core of it, so it's not one LLM, and then there's intelligent prioritization. So if you interrupt a particular conversation with saying, there's a fire in the building, I need to run out, it knows that it needs to cut the conversation right there and not try to sell you more of whatever it is trying to sell. So it understands different priorities. And if you tell it, like, I really like your voice, so it knows that it's the same priority job, so responds gracefully and comes back to the conversation, maybe trying to sell you the same stuff again. But quickly moving on, so I've a few audio clips. I don't know if they'll play, we'll try, but. So the first one you'll hear is a health assistant trying to look at a chronic hypertensive friend of mine. And I don't have audio, but
Connect to HDMI RGB link is.
Okay. So
Sound,
that.
yes, and then RGB HDMI, yes.
Yeah. Okay. Let's try it again.
Records, we need to run serum electrolytes, renal function tests, and lipid profile blood clot tests. Could you tell me a bit more about how you've been managing your hypertension?
Yeah, I have been doing exercises.
That's wonderful to hear. Exercise is such an important part of managing hypertension.
Okay, so it's from trying to look at health companions who can keep you cheered up or whatever, follow up on certain tests and stuff. Let's look at another one which is completely different. This is going to be about a restaurant call.
I was planning dinner with 2 of my friends.
I see. What kind of food do you and your friends like?
Just to remind that Vasuki is vegetarian. Shivam is allergic to gluten, and myself, I am a meat lover.
For your appetizer, I would recommend the calamari fritti. It is lightly.
I'll skip that. And it's just that it understands conversations, and since we use an LLM and not a rule engine, you can, as you heard in that, like when you're being asked about the menu and you skip to, let's say, food preferences, it understands and filters the whole thing out in real time to get you food preferences. The last one would be what we have in our website. So if you scan one of those and you end up at antengage.com, you can experience the bot that is, if I can play that. Let me see. Oopsie.
Hello there. This is Flowify calling from Antengage. You expressed interest on our website. So I'm here to answer any questions you might have about our AI-powered customer engagement solutions.
Yes, tell me about your product.
Lo-Fi is our AI agent that uses natural.
Interest of time, I'll shut that down. But then here is the interesting fact that, we train it on a basic set of parameters. It's hard guardrailed, so specifically designed for businesses. You can tune it out very specifically, and there's, as I said, there's multiple layers of LLMs that determine the guardrailing and the business context, et cetera, It's not, which helps us stick to business context very, very closely. Now, I think we do not have time enough for this, but then this is, let's see if that works.
Good afternoon. I'm Tanya from Antengage. I understand. Excellent. I'm here to make sure you have a great GeekConf experience. You can start by telling me what you're most interested in learning about. For example, are you interested in learning about our sponsors or checking out the speaker schedule?
That's all good, but then I am really hungry. Can you guide me to where I can get something to eat?
Of course. We have some great food options at the GeekConf. Are you looking for a quick snack or a full meal?
I'll stop that there, but the interesting thing is that you saw the interruption, that yes, it handles interruptions gracefully and switches contexts pretty okay. So that's me signing off. I would really encourage you to try out Tanya. It's on there. You can always meet me at the booth for the co-sponsors. It's in the Track 2 building. Thanks again for listening.
Okay, thank you so much, Sarav. All right, keep it going, everybody, because we have another great talk coming up next from another amazing sponsor and someone you'll recognize the face of. Everyone, please give it up for Atul and Sanket. Woohoo!
Thank you. Audible? Is the mic? Oh, okay. Now it's working. Great, I'm here again. I wanted to talk to Atul about something that he's building. And also I was talking to Kidze backstage about his problems and how he's trying to maintain a mobile app and a web app and trying to share code between them while he's struggling with a bunch of basic things. So let's wait for the screen. Okay, so Atul, what is that on the screen? All right.
So imagine you are a developer. I mean, most of you already are. And then you've got a brilliant app idea. You are pretty excited to bring your vision to life. But then reality hits you. You need a lot of decisions to make before you can jump into the development cycle. You need to decide, do you want to be mobile first or web first? And then accordingly, you need to set up your development environment, set up the tooling libraries, set up your database, your backend. I mean, decide on what kind of UI you want to make. how you can make it universal, or do you want to make it, responsive? And then, you are still struggling to set up your development environment, and weeks pass by, and then you're still not developing your actual business logic. Now imagine a world where you could skip all that and jump right into the development process and start building your unique features and start working on your innovation, your vision. So how would that be? That would be pretty cool, right? So that world exists, and that world is called App Launch Kit. So App Launch Kit gives you, ready-to-go development environment, which is full stack, and it includes Next.js, Expo, and Supabase for your backend. And then it has your authentication system already built in, your Google login system already built in. And if your app idea needs payment integrations, we've already done that for you. So authentication, payment integration, and a lot of other features are ready, and ready to go and right setting for you. So in the startup world, we have seen this mantra a lot, that fail fast and fail often. And to fail fast, you need to launch fast, right? So that's App Launch Kit for you.
Interesting. And does it give me like native mobile app?
Yes. So it leverages Expo and Expo's router v3, which gives you universal application. And it gives you a native application. At the same time, it gives you a web app.
Okay.
And we also have a Next.js setup with the app router, which you can use for your, say, marketing websites if you need any. And then, so you've got all bases covered. You've got your web and mobile app all ready to go.
And how about like Tailwind CSS? Do we have Tailwind CSS as well?
So it's interesting. And then we have leveraged the APIs of Native Wind, which works on obviously the class name patterns, what Tailwind prescribes. So that's already built in, and it gives you universal UI components that works seamlessly across Next.js as well as Expo.
All right. I think this looks amazing. All the best for App Launch Kit, Atul. Yeah.
Thank you very much. Please go ahead and give it a shot, and let us know how it looks like. If you want to talk more about it, you can feel free to meet me outside.
Thank you.
Thanks.
Thanks.
All right. Thank you so much. Okay, and now we are going to hear, ooh, they're both working. What's worse than an MC with a microphone all day? An MC with 2 microphones all day. All right, we're now going to hear from Kunal for a few minutes. So everyone, please give a warm welcome to Kunal. Woohoo! And you'll use this speaker, right? This microphone? It's all good. Do you use that one?
Check, check.
All righty. And while Kunal is getting set up with, I believe, also a little bit of audio, once again, don't forget that this day has non-stop cool stuff going on. So at the end of the day, around 4 p.m. in the sponsor area, there will be some goodies given away. So you definitely don't want to take off at lunch. You want to stick around until 4 p.m. All right, everybody, put your hands together for Kunal.
All right. Let me should have done it before. How's it going, everyone? It's my first time at GeekConf. I'm just going to mirror my display. All right, that looks good. Cool. So I live in London, and I'm here to share a bit about our conference, Evo Navigate. First of all, shout out to GeekConf for giving me the opportunity. And Berlin has been really nice. I've been here for 2 weeks. We went to some techno clubs, which was fun. But I'm excited to be back in September. I won't take too much of your time. What I'm here to do is share a bit about the conference and give some free tickets just for the GeekConf attendees. So the codes I will be sharing will be free. Please don't share it on social media, but feel free to register. Otherwise, the tickets are like 400 or something, but you can get it for free because you're an attendee here. You can share it with your friends, but please don't share it on socials. I'll just play a quick clip of our previous event. It's just a minute and a half, and then I'll share the code with you.
Oh, it's awesome. Love the conference, love everything. Weather's great. What can go wrong?
I really love the venue associated with this conference. Open air, beautiful weather. I really love the nice places to just sit down and have conversations with people. The actual speaking venues where the sessions are happening are just fantastic.
I'm so happy to be in Florida, hot weather, much better than New York. We have free ice cream, free coffee, free everything, and it's just amazing.
We've had a lot of great people come by, but the quality of the people that come by has been really great too. Lots of people asking really great questions, giving feedback.
One of our finals today. We got to meet Steve Wozniak.
It was amazing.
I know, it was amazing. It was amazing.
I mean, opening the conference with Wozniak is pretty bold and aggressive play, but, you know, I could have sat and listened to him for hours.
I told my father, I'm going to own a 4K Data General Nova computer someday. And he looked at me and said, it costs as much as a house. And I said, I'll live in an apartment.
Sivo had pulled a simply staggering lineup of speakers. There's actually the who's who of Kubernetes here presenting.
But one of the things I love about conferences like this is just sort of the melting pot effect, right? I got so accustomed to dealing with two-dimensional people in Zoom meetings that it's really cool to have three-dimensional people again that we can interact with.
I love it. Really interesting to learn more about Cloud Native and all the different products at the booth here. Met some great people here so far. Already got plenty of business cards in my back pocket that I'm excited to follow up on and learn more about.
Some of the stuff is 2-3 years out into the future, so we're seeing a lot of the stuff that was going to be emerging over the next couple of years already here.
Yeah, so for everybody that didn't come, you missed out. You missed out. It's awesome. You should have been here. But stay tuned for the next one then and go there because this is awesome.
Cool. So this is our fourth event we're doing in Berlin. If you don't know Sivo, we're a cloud native service provider, and it's not a vendor-specific conference because we do it for the community. We're expecting around 800 people. The last one we did was 750 in Austin, Texas. We did in London. We did in Tampa. I'm very excited for Europe. Our keynote speakers are Kelsey Hightower and Frank Thillen. And a lot of amazing speakers. All the agenda and everything is mentioned on the website. So I won't go too much into it. Feel free to check it out. And that's the code for you. If you can take a screenshot or picture. Sorry. That's the code that you can use. And if you scan that QR code, it'll get you to the registration page. And you can get the tickets for free. So hopefully see you in September. If you have any questions, I'll be here around the conference. I have my flight today, but I'll be hanging out with some people here. Listening to some talks, but yeah, can take a picture of that, and I'll see you in September. Thanks a lot, everyone.
Woohoo! All right, alrighty. So we have a couple talks separating us from some delicious lunch out there. Thank you again to our sponsors for making that happen. Am I right? Let's give it up for the people who pay for all of this. Yes. Okay, but between now and then, we have a couple more talks. So without further ado, please join me in giving a huge welcome to Bruno from N26. Woo! Yeah, that's right. Yeah, I hear you at the back, right? Woo! Woo-woo! All righty. And don't forget that after the lunch break, we will be back here around 2 p.m. If there are any adjustments to the timing, I'll let you know. Don't you worry. But I believe if the computer cable connection gods are with us today, it just seems that they are, that I'll be handing it over to Bruno.
All right. Thank you so much.
Alrighty. One more round, y'all.
Awesome. Let me just see if I can arrange those displays here. Display. What's going on? Is it mirrored? No. There we go. Yeah. That's better. Oh, actually, no. I'm lost now. Let me put it back here. I need to mirror this thing. Wait a sec.
We are figuring out monitors because
definitely.
there's a lot to figure out with all of this. Just another note that all of the sponsors and speakers and everything are all up on the geekconf website. So if you have been popping out to get a little sunshine in and out of the talks, don't worry. You can find out more and find the links to everybody's profiles and everything on the website. And the live stream is rolling. Heyo, live streamers, how we doing from the interwebs? And so you can also catch any of the morning sessions so far that you might have missed or just wanted to check again for reference. You can find all of that on the YouTube channel. So that is pretty exciting. And if you are joining us from the live stream, hello, hello, and we really appreciate having your positive vibes come to us through the interwebs, so keep them coming. All right, and let's use our in-person IRL positive vibes to summon everything working with the computers. Ready? Everybody, let's give it up for computers. Yeah. I know, I feel that way about them today too, because my site's not working. Is yours? No. But seriously, huge thanks to all of the volunteer staff and the staff that are making this all happen, because obviously it takes a village to run a conference. So thank you to all of the folks from Geeky Ants and other community conferences, folks from the React India team, who are really like going above and beyond to make sure everything is coming together today. All right, let's build some JavaScript. Woo!
Thank you so much. Thank you so much, everybody. I'm happy to be here. Yeah, so I'm here to talk about JavaScript, right? Surprise, surprise, no app conference. But I want to take you in a journey with me, so I want to peer behind the curtains and actually show you how interpreted languages work, right? Like, you probably have heard about Python, Ruby, all those amazing languages, by the way. And they all work in a similar fashion. JavaScript is no different. There are a few components that we'll talk about them very soon, and hopefully it's going to be fun. So yeah, a little bit about me. My name is Bruno. I'm a tech lead at NE26. I'm currently working in the platform engineering team. We're basically building tooling, for the web engineers to actually build the product. It is pretty interesting to me. I'm really deep into monorepos, CI pipelines, infrastructure for web, and so on. I'm not a front-end guy, but I really love React. So yeah, don't judge me by my front-end skills. You're going to see it at the demo. But hopefully it looks good enough. Yeah, I'm a software engineer by trade. I have been working as a software engineer for the past 14, 15 years. I'm originally from Brazil, but I have been based in Vienna for the past 8 years. I'm soon moving to Barcelona, so this slide is going to change slightly. I'm also a big fan of programming languages in general. I try to learn new languages every so often. I'm really into Elixir now and Rust. But I'm also a big fan of web technology, right? The browser, it's an amazing thing. I mean, I was watching the other talks about React Native. I was really impressed. I didn't know React Native was in such a really cool state. I had no idea. I really needed to look into it because it's really amazing. But the coolest thing is that the technology that powers React Native, it's also powering the browser, right? And all those really cool platforms that you see out there. I'm going to talk about this a little bit. I'm on Twitter. This QR code should lead you to my profile. I'm also on GitHub. My DMs are open. I'm happy to chat. I'll also be around here the whole day. So I'm happy to grab a coffee and then have a chat later. But before we start, did you know that the console object is not part of JavaScript? So this little object that you use every day and love, it's not really part of the language. But somehow you manage to use it, right? But it's actually a gift from the runtime. So you use it every day, but the language doesn't have it. It's because this is not a part of the spec or the ECMAScript spec, but it's part of the runtime. We're going to see those two components together. And this is a little agenda for today. So I want to take you in this little journey coming all the way from your source code, right? Like you start writing those blobs of text in this index.js files, and then somehow like magic. It just happens to show on your screen and do computations and so on. But I'm a guy that I don't really enjoy magic so much, so I want to actually see what's going on behind the scenes. So I want to take you in a little side quest. So I want to talk about the JavaScript engines and runtimes a little bit so you have a better understanding on how those things work. Then we jump in, we come back to the main quest of our journey here, and then we talk about tokens, lexers, tokenizers. Some people call them scanners as well, and why they are so important, so helpful. Then we jump into the parser phase, which is actually like one of the most interesting parts to me. That's where you actually build your abstract syntax tree. If you haven't been dealing with abstract syntax trees on a day-to-day basis, that's fine. You're usually not doing that often. Generally, you're doing that when you're dealing with tooling. But that's basically what's happening with your code at the end of the day. Then you jump into the interpreters, and this is the guy that actually makes the magic happen in a sense. So it takes out your syntax tree, and then it magically, resolves all the nodes, and then make the magic happen at the end, and then show pixels on the screen, or make a database call, and so on and so forth. Then at the end, I have a little live demo to show to you. I mean, my plan was to actually build the whole tokenizer, parser, interpreter during the talk, but just half an hour, it's tough, and I'm also getting hungry, so that would be quite a task. Okay, so let's just start with playing a JavaScript file, right? You start your journey by writing your program like this, right? You write your JavaScript there, very simple statement there, let result equals to 1. But let's see what actually Chrome does to actually make this a reality, right? You're binding a value to a variable, right? But how does that work? Chrome has this incredible piece of software called V8, and this is really what makes your JavaScript so fast in the browser. It's really fantastic. And those are the steps that V8 takes. And a rough picture, I mean, it does a lot more than this, but this is basically the big picture. And it started from the top. V8 in the browser, fetches your JavaScript file from a remote server, from your HTML page, and then it shoves it into the parser. So the parser, analyzes your text, basically a stream of text, and then it transforms it in this abstract syntax tree, right? This is a representation of your program at the end. But this is not executed yet. It's just like this picture of your program and what this could look like when it runs. And then when the syntax tree is ready, then this is passed down to the interpreter. In V8, this is called Ignition. It's its own little software inside of V8. It's really incredible. And this is the guy that's analyzing the syntax tree and then processing your code, basically, not line by line at this stage anymore, but basically node by node. But V8 implements a very neat architecture where it not only compiles down to bytecode to execute it faster, but also if it detects that your JavaScript is running like that specific function that's really like running several times a second, it detects it as a hot path, and then it sends this portion of your JavaScript program to turbofan. Turbofan is this just-in-time compiler, so it takes your portion of the syntax tree, and then it compiles down to machine code, and then it makes it even faster. Sometimes this doesn't work as well, like it can actually be slower than the bytecode. So turbofan is analyzing the metadata, basically the metrics of this running code. And then if it turns out that's not really performant, it sends it back to Ignition, and then Ignition continues to execute the bytecode. But this is just half of the picture, right? Where do you see, when you're working in the browser, where do you see your window object, right? Like where's the console object there? This is because the browser and many other environments, they're actually composed by mainly two pieces, right? You have the JavaScript engine on one side, and then on the other side you have the runtime. And the console object actually comes from the runtime. I have two runtimes here, which is the browser and then Node.js. In the browser you can see the console object, the window object, timers, event loop, the DOM API, all the web APIs, right? This is the runtime binding those objects into the engine and then make it available to you. In Node, you have different APIs, right? You have file system calls, you're doing sockets, you're doing HTTP calls. You also have the event loop there, callback queue. And by the way, the event loop is not a Node.js thing. It's actually a pattern. It's also implemented in different languages. For example, in Rust, there's this famous library called Tokyo, which is the async runtime. It also implements a event loop there, basically. So this is a pattern that's implemented everywhere. And in Node.js, for example, you have this library called libuv. You see this little dinosaur with a bit of a unicorn there. libuv is the library that makes the magic happen between different operation systems. For example, imagine you're doing a file system call, or you're reading a file, and you need to read this file on Windows, Linux, and Mac, right? Imagine that you have to write 3 different APIs for doing that. So the folks from the Node.js who wrote this library to kind of like abstract this away, and then the JavaScript APIs can call in. And libuv is so good and so popular that's been used by other programs too. Like I think Neovin also uses it. There's a bunch of other software that uses libuv as this foundational layer to provide this API on the operation system. This is interesting to me because that's why you see so many companies improving their runtimes, right? Like you see them investing a lot of money and time and effort on creating new runtimes. For example, Bun is doing that in Zig. They're not using V8, they're using JavaScript Core, which is the engine from Apple. Dino is writing their runtime in Rust, but also using V8 as the engine. And then the Cloudflare folks are also doing a runtime as well with different APIs, right? You have all those edge APIs. But they don't want to reinvent the engine. The engine is doing its job really fantastically well. And they just want to piggyback on it and then make sure that you can just reuse it. And that's the main difference between the engine and the runtime. But let's come back to our main quest, because I want to focus on this here. We only have half an hour, so I have to be quick. We want to focus on those 4 boxes at the top. I'm not going to go into detail on the other ones, but hopefully we can cover those pretty quickly. So I want to focus on fetching the file, passing, generating the ST, and then interpreting at the end. But at the end of the talk, we're going to see a demo that everything that you see in those boxes I have implemented only using the JavaScript standard library, and basically powers this whole thing. So yeah, let's go back to our first example here. Start with your JavaScript file. You have your stream of text, but they don't mean much, right? It's just plain text at this point. And that's where the lexical analysis come into play here, because it basically does this phase where it analyzes your string, like string by string or character by character, and then it tries to make sense of them, And the way it does is basically like, okay, you have a language. This language has specific keywords, right? Some of them are reserved. You have to use them for certain constructs. Some of them you don't have that in the language. Like for example, result is just the name of the variable, right? It could be anything. But you have also symbols like equals, the number 1 is a literal value. And at this step, you just try to classify your tokens. You put them in boxes and then you tell, hey, this is a literal value, this is a string, this is an operator. In this phase is important because, it gives us a lot of metadata. For example, location information. Think about when you're programming and then you have a stack trace that points to, there's a crash here on line 45, column 57. This is where it comes from. This phase embeds this metadata, and then it can actually give you more information as a program language designer on how to actually show error messages. If you think about programming languages, the user interface of a programming language is usually just text, right? You're giving back feedback to the user just as text. Basically with compiler errors, syntax errors, and so on and so forth. So you have to be very good at analyzing text, basically. You also have literal values. For example, the number 1 there, it's literally the number 1. You don't have to evaluate this at runtime. At runtime, you have the value there, so you can just use it. And that's a lot faster than trying to evaluate it. So you store this information too. But you don't have syntax context there. So at this phase, I'm just trying to classify those tokens in a way that they have those little boxes. But you can tell whether there is a syntax error here. At this phase, it's not like really concerned about telling, hey, there is a mistake here. You have to fix it. This is the job of the parser. We're going to see it later. But this is already very useful. Think about like if you're working on tooling, and then you want to write like a syntax highlighter, for example. If you manage to get to the phase where you're doing lexical analysis, you can already write like a VS Code extension, that highlights your programming language, for example. That would be possible already at this stage with the output of this stage, which is just this list of tokens and then this classification of them. But let's take a step back and then let's have a look at this different example here. Who can tell me what is the value of this expression? 8, yeah, that's right. But why it's 8? Yes, that's right. You start the multiplication, right? And then you do the sum at the end, right? But how the heck does the computer know how to do this? I mean, you know this because you know the rules that apply here, but the computer doesn't have any clue about this, right? Like there must be a way to tell it on how to do it, and there's no magic here. Like it can't know it like implicitly, right? If we look again at this same example, now I'm just wrapping them in parentheses. This makes more sense, right? I mean, if you look at it, you can tell, okay, the multiplication maybe should come first because it's a group, and then it should be resolved from the inside out, so on. But if you look closer, does this line represent some sort of data structure that can tell you this? I mean, who can take a guess what this looks like? Basically a tree. So you can represent that as a tree where those nodes are connected somehow, and then they have meaning that you have to resolve them in some way. Like for example, in this tree here, you see the bottom of the tree should be the ones that are resolved first, and then it walks back all the way to the top. So let's walk through this tree. We have done this already, but now in the tree form, you have the same tree that we saw in the slide before. Now you do the multiplication first, right? Now you have 6 plus 1 plus whatever comes after. Then you have 7 plus 1, and then you have 8. Right? That's the result here. But how can you build this tree, right? Like you have to codify this somehow, so then this tree comes out. I mean, it can come out from nowhere, right? You have to apply rules to it. And this is where formal grammars come in. I mean, if you're into languages, let's say the English language, you have a formal grammar, right? You have a way of writing sentences. They have like a limited set of amount of rules, but you can produce infinite amount of phrases with it, right? And it's the same way for programming languages. You basically build up this formal grammar, those rules, whatever they are, and then you apply it, and then you can generate an infinite amount of programs, right? That's basically what we have been doing here every day. We're just applying this grammar. You know this grammar by heart. You just don't know how this is defined, maybe. But a grammar is this finite set of rules, but it can produce an infinite amount of strings. And this is divided in simple definitions. Like we call them productions, so each rule is a production. And then this production is defined with a head, which describes the rule, and then the body. The body is basically how you can actually resolve that rule. And the bodies are composed by terminals and non-terminals. Terminals are basically like, okay, if you got here, that's the last stop. If you go to a non-terminal, you have to resolve it back to a different rule. So it's kind of like a recursive data structure in a sense. And this is how you represent grammars. You don't have to be worried about like understanding how this whole thing works. But the gist here is that those rules, they have to follow a certain order, and then they have to obey this, the sequence that it comes from the grammar. For example, you start with an expression, the expression can resolve to a term can resolve to a factor can resolve to a primary to a number, and then back to expression again. So it's kind of like a recursive data structure again, but this is the grammar that makes this kind of tree possible. This is the one already for this specific tree. And we will see that in code very soon, how you can actually codify this. You see that there's a bunch of symbols there. The ones that are in quotes are actual symbols that should show up in your code. And then the terms in black are basically rules, so you have to resolve them. Don't worry about it. I mean, if it's confusing, we'll see that in action very soon. But this is what we call a recursive descent parser. So if you see this fancy term for a parser name, that's basically what this guy is doing. It's really a fancy term for a very Very straightforward recursive function. You have this big recursive function that's just walking through those rules and then resolving them one by one. It takes the list of tokens that we saw before, and then it transforms this in the syntax tree based on those rules that we defined. And it just starts from the top and then goes all the way to the leaves. That's why it's called a recursive descent, because it goes in a descent order. And if you want to visualize that syntax tree that we just saw before, for that little example that I showed you before, it should represent something like this. You have a binary expression that has like a left side operator and then the right side. And then on the left side itself, you have another binary expression. So you see the recursive element of this, right? And then you also resolve it to operator, left and right. If you really want to explore how this works, there's this really cool website called AST Explorer. You can just type it in any JavaScript code there, and then you can basically see the output of the syntax tree there. This is the representation of a program. That's what V8 is doing, for example, before executing your program. And this is super helpful, because if you get to this stage where you actually have a AST, think about your building tooling and you want to refactor a really big code base that has like anonymous function, and suddenly you want to come up with new names, or you want to rename a specific function across the code base. And suddenly, if you just do like a regex pattern, you might screw up some bits of the code base, because maybe you have this reference in a different way with a different name. But if you manage to actually get an AST out of it, you have all those references already built up, and then you can run like a lot more powerful tooling on top to do refactoring. This is really cool. There's many libraries that already gives you the AST, but it's important for you to understand how the AST works, right? So then you can actually apply those rules yourself. And once you have the AST, you're pretty much like ready to execute a program. You have this representation, but nothing happens yet. And that's where you get to this stage of the interpreter. So the interpreter, it's actually the one that just walks through this tree, walk through it every single node, and just evaluates them. We did that before, right? A couple of slides before, we saw the tree, we just resolved them, and then we got to a result. It's the same thing that you have to do in an interpreter. Basically, Ignition is doing that in V8 in a different form, of course. And this is where you can bridge the gap from your custom programming language or from JavaScript itself to different programming languages runtimes. Like, for example, in Node.js is written in C++ together with JavaScript. But Deno is in Rust, and then Bun is also in Zig. So those are the runtimes that are allowing you to write JavaScript, and transition those objects back to the runtime that's actually running like native code and so on. That's why JavaScript is so fast, because at the end of the day, you're running native code, but there's a lot of time that's spent analyzing your code, right? Like we saw it in V8. And this is called the tree walker interpreter. Basically, it's very straightforward, right? Like you do a walk across the tree, and then you resolve this. And this is the interpreter that I want to show you guys now in the demo. But before we move on to the demo, I think we still have enough time, yes. I want to recommend those two books. Those books are really fantastic if you're interested in learning about this stuff more deeply. Crafting Interpreters is a perfect book. None of them use JavaScript as a base language. Crafting Interpreters using Java in the first part of the book, then C to build out a compiler. Write Interpreting Go is Go, but it's really easy to follow along. Even if you don't know Java or C or Go, you should be able to follow along just fine. Highly recommend this book, even though if you're not planning to work on programming languages, tooling, all that stuff. But it's really good to understand how those things work. One thing that I advise to engineers working with me is like, always go down at least 1 or 2 levels deeper than the tooling that you work on a day-to-day. That's going to make you a much better engineer at the end of the day. Cool, so this is time for the live demo. I have this little QR code there you can scan. I mean, I'm going to put these slides online as well. But this is all on GitHub, and then you can build yourself and check it out. So let's see. Let's take a look. This is the app that I built. I know it's not super fancy, but let me explain what's going on here. On the left side, I have this text area that's taking the expressions. So you can write whatever expression that you want. I took the one from the example before. On the right side, we have the result of the interpreter, basically, doing the stuff that we saw in the slides before. Below it, we have an eval as a sanity check. Eval is how you can evaluate JavaScript in JavaScript, but don't do this at home. It's really dangerous. And then below it, we have an AST explorer. Like I built a very minimal version of the website that I told you before, just to show you the AST that pops out from this. So if I type in more expressions here, we should see the results coming up quickly. I can also wrap stuff in parentheses here. And then, okay, let's see, +2. Then hopefully this is right. And then the AST comes out of it, and then you can analyze this. But how does this work, right? Let's take a look at the code base here. So I have a plain JavaScript project here, just using React. There's no libraries here. So if you look at the package.json file, there's only React and React DOM. I'm using Vite to build out the app, but nothing else. If you look at the app.js file here, you should see one use effect here that's managing all the steps that I showed you before. We have the tokenizing phase, or the lexical analysis phase, that actually gives me those tokens. Then we go to the parser, and at the parser level, I pass those tokens down to the parser, and then I tell you to pass those tokens, give me back the AST. Once I get the AST back, I just shove this guy into the interpreter. The interpreter interprets this AST, and then gives me the result, and then I show it here. Pretty much like very straightforward. But let's look how this actually works. So let's take a look at the lexer first, because that's the first step in the parser phase. So the lexer, it's really not doing much. It's a while loop, and then it's just walking through the input that I gave. Basically like a big string, just walking through character by character, and then just trying to analyze and make sense of them. So I call this function here. So if it's not at the end, I call scan token. So it should go, oh, come on. Should go to scan token. In the scan token, I have this huge switch statement here, and it's just looking up each one of them, right? So there's nothing fancy here. It's really just adding tokens to this array. There's like a little helper function here that passes those tokens in certain way. For example, for numbers, I can actually support floating point numbers. So this is how I'm actually supporting them in the input. For example, if I see a dot there, okay, it might be a float pointing number. Let's look at the other half that comes around. So if I go back to my browser here and I do 2.5, it should work too, right? So this is also handling it. And then it just shoves back to this list of tokens. So let's take a look at the token implementation. It's pretty much a simple class. It could even be just a plain object, to be honest. I just kept it as a class, so it's consistent. But it's just stores, the kind of box this token belongs. It's a kind. There is a lexim. Lexim is the representation of that token. For example, the plus sign is the representation of the plus operation. And then we have the literal value. In this case, like could be 1, could be 10, could be a string, and so on. Then let's take a look at the parser now, because now that we have this list, we can take a look at the parser. And here we see that grammar again that we saw before. At the top, I just define the grammar here as a comment, and then I just try to implement that in my parser class. And what this guy is doing. So you see, it starts with an expression, then it falls back to a term. A term tries to resolve a factor. Then it tries to resolve a power, and then a primary, and so on. So let's look at this here. The constructor takes a list of tokens. We already built this. And now we start the parser phase. The parser starts from the first grammar rule, which is an expression. So if you come here, the expression just tries to resolve a term. And then a term tries to resolve a factor. If there isn't a factor there, then we do a while loop and then check to see if a plus or a minus, because the factor tries to resolve those first. And then if there is one of those symbols, and then it tries to resolve the right side and left side. And that's where a lot of recursion come in handy here, because it goes back to factor again, it goes down to factor here. And then factor tries to do the same thing, but for slash operations and star operations, right? Division and multiplication. But notice the order here as well. So this is where you can codify the order of the rules, because it's coming after. So everything that's coming after, it becomes a node down the tree. And And it also tries now to do a primary, and then a primary is either a literal value, which just resolves to a number. I'm calling this a literal. I also have like little wrappers to hold the state. Or if it's a grouping, it goes all the way back to expression. And then we start the recursive function again. You see, like, there's a lot of recursion here. It could be a little complicated to wrap your head around it, but it's very straightforward. Once you build up this tree, that's basically what we see here in the ST Explorer, you're ready to execute this. So you got the representation of your tree. Now you want to execute that, and that's where the interpreter comes in. And then here, it's basically a big switch. Again, you're just like evaluating each node, and then depending on what they tell you, you just evaluate them in a certain way. For example, if I start evaluating my expression here, and if this guy is a literal value, let's look at literal value. It's literally returning the value to you back, nothing else. So if it's a number 1, just return the number 1. If we look at the grouping, or maybe this is not so interesting. Let's look at the binary, for example. If it's a binary expression, then a binary expression is composed by a left side operator and then the right side, right? So I just grab them, resolve left here, resolved right. Them on itself, they could also be recursive. That's why I call evaluate here, and then I pass the node, because this should start my recursive tree again, and then walk the nodes back again. But if you see at the end here, depending on the operation, this is plain JavaScript, right? Like I'm doing left minus right, left division right, left multiplication right. So this is how the interpreter works. You know, this is what, for example, V8 and runtime is doing behind the scenes. It's just doing this execution in the C++ layer that's doing this for us, basically. At the end of the day, it's translating to this in the native language. And once you have this, then you basically come back here, and then you have a result, right? That's the stuff that we saw on the screen. So yeah, this is the end of my talk, and hopefully I gave you like some interesting tools for lookup and then learn more a little bit about this. I'm pretty sure with those basics here, you can actually go and build up your programming language, because of course this is very basic and it's just very the beginning of everything. But this is not super far away from defining functions, you know, variables, you know, closures, classes, and all that stuff. That's like fascinating to me, and you're definitely armed now to do that by yourself. Thank you so much.
Yes, keep it going. Everybody, give it up for Bruno. Woo! All right, we all ready to go home and reinvent JavaScript? Yes, awesome. Okay, one more talk left in our morning. You ready for it? And then you're ready for lunch? Woo! All right, so please, without further ado, please put your hands together for our next and final speaker of this morning, although we have some great talks after lunch. Give it up for software engineer from Geekconf who does front end and React Native. Everyone put your hands together for Tarun. Woo-hoo! During the lunch break, which we will be beginning right after Tarun's talk, don't forget that there are the sponsor tents to visit, and don't forget that there are lots of little nooks and crannies in the venue area. So if you want sun, you want shade, you can find your people and have a nice chat over the lunch break. But in the meantime, we are going to be hearing about server-driven apps for React Native. I think we're all ready to go?
Yep.
Excellent. All right. Tarun, everyone. One more time.
Yeah, just take a second. So, hi, hello everyone. There's nice weather out there, and the venue is absolutely beautiful. First of all, can we have a huge round of applause for the organizing team? All right. Well, so hi, I'm Tarun. I'm a senior software engineer here at geekconf, and I mostly work around and mess around with React Native, web, and everything JavaScript, TypeScript. Yep. So initially, I was going to get a raise of hands of who has heard about server-driven UI. But right now, I don't think so. I will need to ask that question because since it's a hot topic, I'm pretty sure that everyone knows it. But yeah, there's still intricacies, and I'm here to talk about it. Before I jump into my topic, I will have you to take you back to the time, right? We are pretty sure what is this. This is by far the most excellent invention that has happened to the humankind, right? But if you see, an invention happened years ago, is still being used till this day. It's in the mechanical watches, it's everywhere, right? The wheel was fundamentally the most absolutely crazy invention. They might have not foreseen what was being out there, right? So why am I taking you back this to the era, right? So you'll find out. Also, I don't need to explain why and how we are still using this machine in some or the other way, right? I'm pretty sure someone is absolutely using this machine right now, right? So I want to talk about the fundamentals that we are still using the same fundamentals that has happened years and years ago till this date, right? So how that applies to the development, to the app development, the web, and the mobile part. So if we see, years ago, we started off with the rectangular displays, and we started developing for the rectangular displays, right? We came and evolved around developing for usability, for personalization, right? But the fundamentals still remain the same, right? We're developing for showing information in a rectangular screens, be it larger screens, and now we have smaller screens. And fundamentally, it's all the same. We have to show the information, right? And if we see how are we showing the information in the screens, again, it seems different and modern right now, but it's still the same. So why not make use of these fundamentals, capitalize on that, and keep it sturdy, and also bring the modern tech around it, right? So we saw the similar layouts in the past, and we're still using them right now. So for example, if we take example of a gallery UI, right? There might be 100 ways to do a gallery UI, but most prominently, since the users are used to a couple of them, we are still sticking to maybe 3, 4, 5 at max, depends on the UI, right? So that's what I call peak correctness. We have achieved something called as peak correctness in various different things, right? We can get a callback for the wheel. Wheel has been used till now with the same exact fundamental that a round circular thing is spinning, and we are making use of that spinning, right? That's what I call as peak correctness. So yeah, we will capitalize on the fundamentals, and over the next few minutes, I will go through what, how, and everything between the server-driven UI. Can you use it in your business? That's what we're going to answer. And obviously, the right balance. Yep. So talking about what? So server-driven UI is, as the name suggests, we, as a backend, we will handle whatever we are going to ship it to the front end, right? So at its core, it's just a JSON, what drives the UI. Here, I've taken an example of a tile with prefix icon and suffix icons. And if you notice, there's an interesting thing that's an action, right? We'll come to that in a bit. So this is, at its core, what server-driven UI is. We take the JSON, we structure it to a way, and then we get the components. What if we use multiple JSONs, right? We'll get, obviously, US. We can wrap around it, we can play around the JSON, and it will give out the UI we want. Right. But how does this happen? It happens, we have, under the hood, it lies 3 main components. One is the UI generator. The second one is the component factory, the set of components your business or your apps, I'm saying the word apps because it can drive multiple apps. And the last one is the integral part, that's the JSON contract. So if we have a look at under the hood, the first component, the major component that, that we use is the UI generator. So it's just a function that takes the component name, the component factory, which we're going to talk about soon, and then the props. And using those props, we'll just modify what the function does. Right? So component factory is pretty much a map, right? Nothing new to explain here. I was going to mention about the actions. This is one of the reasons why the server-driven UI was so popular back then, and it's still popular now. So if we take a look at the actions, we have a navigate action with a URL. So if we see, URL can either be used to navigate inside our app, if it is defined, or else we can structure our JSON in such a way that either we can do an external API call. If we just add get, we are basically telling that it should fetch the next API, right? And using the power of this, we can also just similarly use post, but we just need to add body, whatever. Again, this is also from the backend. So the hassle to pass the body from the front end will be minimized. On top of that, we can also automate what and how a UI will be looking in not just a single page of component, but also, for example, here I've used an action sheet. So here, with just this piece of JSON, we can open an action sheet, pass the URL to get the response, what we will be showing inside the action sheet. So just by, I don't know, 14 lines of JSON, we have created a page which gets the response, opens up an action sheet on tap of a tile, and also passes a URL that we are going to open it inside the action sheet, which will have a loaders, and then in the action sheet, we'll get all the data, right? So this is the most fascinating thing about server-driven UI. Now let me talk about, so we saw the basic thing, why we were using server-driven UI. So here's an example of, so the Swiggy is a food delivery app in India. It's a market leader, and they are using server-driven UI to render a card, which is, they like to call it as dynamic widget. So if you attach this to having a personalized data, right? Swiggy has been operating since years. They have data which drives the analytics and also drives what should be shown to what users. So a personalized experience has been given here, where you'll be shown nearby locations. You'll be shown the pictures that's generated to your, catered to your data, I would have to say. Not only that, let's say there's a hot trending topic right now, right? There's a new TV show. You want to capitalize on that, grab that marketing opportunity, and show it in your app. If you see, the widget size is different. That affects both the page size, the layouts, and obviously the data. So here, this is all driven by server-driven UI. If you see the layout, they have defined, it's just a change of JSON under the hood, right? And just using the power of that, we have created a personalized UI for the user itself that's driving the best marketing content, the best businesses, right? So just a quick recap. Here's the what we just saw. What's the power of server-driven UI? And obviously, needless to say, the OT updates will be great. And since the JSON is very, very readable, it also be predictable. Also, development cost might be less. That depends on many factors. But one of the main things will be the cross-platform. The dream of cross-platform has been there since, I don't know, the beginning of time. Server-driven UI, also React Server components, I'm not getting there, will make this happen, definitely. And if you have to talk about how it helps inherently changing a day-to-day coding experience, so it helps us having a centralized logic because we're just using predictable JSONs and mostly driving on the server itself. Second one is, again, easier cross-platform. For development, again, since the same team might be developing for both web and mobile, it will be an absolute pleasure. Improved performance. This, I would have to say, it's a double-edged sword. If done correctly, it can really, really improve the performance, right? And obviously, a good version control. So here's another example of what the power of server-driven UI can do. Let's say we are taking the same example as the gallery we had earlier. For example, let's say the marketing team said, why not change it to a bento grid? We can do it with just a click of a button. And how about we change it to a carousel, right? If you notice, changing from bento grid to normal grid was just the styles thing, right? But if you have to change from bento grid or any type of grid to something like carousel, it also involves attaching the data to the images, right? For example, which one should be first, which one should be showed at the top, how many images should be there. So all of this data can be attached in the JSON, and all of this can be done in a predictable way. All of these were really great things about server-driven UI, right? But what's the catch? So the catch is, what if we overuse it, right? What's the exact cost of overusing it? That being said, where do we exactly draw the line? So we just talked about what server-driven UI is, how we do it, but there's also one component that is how much of server-driven UI we should be using. So there are flavors of server-driven UI. If you see from a perspective, every app is still a server-driven UI, since the data is from the backend. We are writing a logic. We are writing the Booleans. But yeah, I would like to categorize those as basic ones. We already have solutions for CMSs, banners we saw just right now. There's tools for dynamically generating the forms, right? Based on inputs, based on many, many permutational factors. But what if we go absolute extreme? Everything using server-driven UI. What's the cost of it? How will it be done? And what are we looking at, right? So this is kind of a basic diagram, architectural diagram that we were kind of implementing. Here, we divided our business logics into separate apps and used the server-driven UI to right from starting and choosing a UI library and delivering multiple apps. Not just a single app, but multiple apps, right? So if I just go through it, from the very left, we can see a UI library. That's GlowStack UI, or you can use anything. Obviously, you will be developing your own complex components on top of that. Then there will be a JSON layer, which will come back. We already saw the UI generator. And since we were kind of developing feature first, we have different set of features clubbed together. And using multiple set of features, we can create an app. For example, let's say we are shipping chatbots. For example, we have feature flags for should we enable AI or anything for that matter. We can use the feature flags in a very, very seamless way, since all of this data is coming from the backend, and ship out multiple different apps using a set of features we have, right? As I said, I'll be coming back to the JSON layer. That's the most fragile layer right now, and hooking up to an app builder. So similar to something like CMS, where we configure our JSON, drive our JSON, and then predict it. So again, coming back to the same line, it's very, very important for a business to predefine at what point we have to draw a line and how much of server-driven UI we have to use. Reason being, if we go extreme, there are many, many catches. And what I like to call is the ROI curve. So here, if you started initially adopting server-driven UI, the return on investment will be really, really good. But as we use more and more server-driven UI and club it together and kind of a merge request, the merge conflict in the server-driven UI, the return on investment will start to flatten out. So if we see, there's might be a good point where you want to create a line where to stop it. Like, this is how much of server-driven UI is what my app would need, my features would need, and how much of changes my app would want, right? So obviously, we have to consider the ROI curve. It might be similar to this. Find your point, find your drawing the line, and then make this decision before adopting server-driven UI. So that gets me to a question, I guess the most important question of this talk right now. Is server-driven UI, is server-driven app a good approach for you, right? So to answer this, we already covered first, get the clarity of how much you'll be using it, right? The reason being the hurdles it comes up with. So let's talk about the hurdles where we start adopting more and more of server-driven UI, right? Let's talk about some hurdles. So first is obviously when we will have to make the decisions pre-hand, we will have to invest more and more time on discussing many things. So initial time to market will take a hit. You remember I said if done correctly, the performance will be good. But it's a fragile link. The performance can take a hit because the communication between the front-end and back-end and the API calls are quite frequent. So performance, if not done correctly, will definitely take a hit. Next being the hassle of state management, but in the front end. Specifically in the front end, if there are too many things going on, too many interactions, and many dependent interactions, server-driven UI might not be for you, and it can get really bad really quickly. That comes to the next point, that is the contract management. So the contract, similar to having to version your code, and also you have to version your contracts as well. So let's say you have different branches, maybe dev, maybe staging, and obviously the production. You'll have to maintain the states for each one of them. The reason being, let's say we shipped JSON in the production, which is not yet completely supported in the front end. It definitely will break the front end in a very unpredictable manner, right? So we already discussed more decisions to make beforehand. And coming to the next point, that is, trust me, the developer experience. If the developer experience will also be very, very fragile. If done badly, will definitely take a hit on the developer experience. Yeah, there are many ways to overcome this. The solutions will be to have a great communication, to have a better version management system, and overall to have better communication in the whole architecture and more clarity, right? Final one being the major hurdles we faced were animation, page transitions, and in general communicating with other pages or other features, maybe communicating with other different moving parts. So even this has to be figured out and decided beforehand. Coming to next, I said that the JSON layer is very fragile. And this is where I believe most of the business decisions will have to put more and more time and effort into. The reason being, a JSON structure is kind of opinionated. We saw there are many ways to define your JSON structure, and how are you going to structure it? How are you going to pass the props? How are you going to override your functions? If the function is overridden, what consequences and what will be the fallbacks, right? So JSON layers is where it gets really tricky, and hence it's really, really fragile. Just a quick sneak peek. We are kind of solving, and basically we're creating an opinionated JSON structure for this one. So do watch out for that. This is the only thing I'm allowed to say right now. So concluding what we just discussed, if answering the question, is Solid UI for you? Just summarizing it, one, if it is content heavy, if it is dynamic offerings, as we just saw, and if the change is very fast paced, and if your app is highly personalized, then definitely I would recommend going for it. Not so much if it is having an offline support and very strict offline requirements, since we are very much communicating with the server, and that's the integral part. Having an offline support and heavy offline requirements will definitely might not be your way. Second one would be, as we discussed, highly interactive. If there are many front-end moving parts, if there are many actions, and if, let's say, we have many real-time applications where the feedback loop is very high, and feedback loops should be as nominal as possible. So that's where server-driven UI might not be for you, right? And obviously, since this is an architectural decision, since this is mostly for the masses, if it's a small-scale app, I would prefer not having to have a server-driven UI, right? More or less, it's really great, and I have a few recommendations to have a look at. These are two really great videos. One is by Ayush Singh. He combines the tokenizing in the Figma layer. He uses CodeGen in server-driven UI. And second one, the man himself, Mo. Hi, Mo. Yeah. So you should definitely watch this talk where he kind of lied about a bit. Sorry, I blew that. Yeah, this is worth watching, worth every single minute, where he mentions the core and integral part of server-driven UI with RSCs. And with that, I'll thank you, every one of it. Cheers. Here's my Twitter. I still like to call it as Twitter. We can connect and have a great evening ahead. Cheers. Yeah.
Thank you so much, Tarun. All right, folks, it is time for lunch. So don't be confused by the prices that you see on the food trucks. Everything is sponsored by our amazing sponsors, so you can ignore those. And there's also ice cream out there if you're feeling a little warm. So we're going to take an hour for lunch still, even though we're a little behind schedule. So I'll see you back here at 2:30. 14:30. All right, enjoy. Guten Appetit. And don't forget to stick around for the afternoon at 4 p.m. We have prize giveaways. See you back here at 2:30.
Welcome to the GeekConf. 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 Welcome to the GeekConf.
Predicted that Java could change the way we view the world and the way we live.
Welcome to the GeekConf.
Who would have predicted that Java could change the way we view the world and the way we live? It entertains, it communicates. Predicted that Java could change the way we view the world and the way we live. It entertains.
Welcome to the GeekConf.
It communicates. It transacts. It speeds across the ground, soars through the air, seeks out new frontiers.
Welcome to the GeekConf.
Who would have predicted that Java could change the way we view the world and the way we live? It entertains. It communicates. It transacts.
Welcome to the GeekConf. 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 Welcome to the GeekConf.
got food. We got sunshine. We got ice cream. Feeling good? Feeling ready for some more web goodness? Yeah? Ready for some more talks today? Yeah. Oh, okay. So we'll just go home then. Bye. Are you ready for more talks? Yes. Woohoo! That's what we like to hear. Okay, so we are, as you have noticed, a little bit behind on the schedule, but not to worry. We will be making up that time, hopefully. And don't forget to stick around because later today there's going to be some goodies for you over in the next building. But for now, we're going to jump right back in to the React Native swimming pool of success, I don't know, and we're going to hear from a React Native developer at CallStack. Everyone, please put your hands together for Shimon! No. Hello? Yes. Now, you know that I'm going to be making us do this clapping
no
for
worries.
these people the whole time, but the crew that has been taking care of all the speakers and all the microphones and all the setup, they have been working non-stop since before any of y'all even got here. So please, let's have one more huge round of applause for the AV crew, the photographers, videographers, making us come on through to the live stream. Thank you so much to our audio and visual folks. Shimon, take it away.
Yeah, so hello everyone. Hello Berlin. Right now Mike is working, so let's start. Today I would like to talk about AI in React Native, and this talk won't be yet another wrapper for GPT calls, but I would like to bring AI on another level. I would like to bring AI natively, locally, accessible without internet connection to React Native apps. Let me explain. But first, few words about me. My name is Szymon Rybczak, and I'm a React Native developer at CallStack. On a daily basis, I'm working in a technology team where I support our R&D initiatives. I'm also maintaining React Native community CLI and few other libraries. You can find me on Twitter or on GitHub under Szymon Rybczak handle. I'm trying to post there very often stuff that we are cooking at CallStack. So AI nowadays is everywhere. Like everyone talks about it. Whenever I talk with colleagues at work, there is a new model that is faster, that is cheaper, that is better. Or I don't know, I talk with teachers at school and they ask us like, will AI kill us or something? And there is a no-brainer if I say that AI changed the way we work, we play with technology, and in general, we solve the problems. But the problem is that right now, everything runs in the cloud. Like, cloud costs a lot of money, we need to make a round to the server, and so on. But what if we could use the power of the devices that we all have in our pockets or backpacks? Actually, the power of the mobile devices is really nice. Here's a quick benchmark which compares iPhone 15 Pro, the latest iPhone model, with iPad mini with M2 chip. And actually, on a single thread, iPhone wins. So this shows that the devices that we have in pockets have really nice performance. And also, speaking about the performance, recently Chrome added a new feature to latest Canary version, window.ai. So actually, you can run LLM model that is packed into Chrome called Gemini Nano. This is like the smaller version of Gemini. And yeah, here is a quick demo of how does it work. It works really nice. It's really, really fast. It answers correctly, like it can do some simple maths. And it all is locally in the browser, accessible anytime and under window.ai API. And imagine that in future, every browser will adopt this directive at some point. And iterating with AI inside web apps will be really simple, like adding autocorrect features or instant answers when, for example, the internet connection isn't the best That's going to be really simple. And this is absolutely like mind-blowing for me when I think about it. But what about mobile apps? And let's start with a question. So who's using here React Native and on a daily basis? Please raise your hand. All right, so quite a few people. And when I started searching about running models on mobile devices, I found out this cool project called MLC LLM. It's a universal LLM deployment engine that allows you to run LLM models everywhere, universally. So how does it work? Basically, there are three major steps, three major phases that allows us to do so. So the first step is the process of weight conversion. It's the process of downloading the model from Hugging Face. If you don't know, Hugging Face is the registry for the models. Like you can think of Hugging Face as NPM for packages. Hugging Face is like registry for models. And then after we download our model and convert it to the specific format, we need to compile it to the right format with some Python scripts. And here is the step of magic. And do not ask me what's under the hood. Some really complicated stuff. But what I know is that from this step, we can get the binaries that then can be easily linked to Android and iOS app, the platform native runtimes. And from this point, when we can access the model, the binaries from the Android and iOS side, we can access in React Native. So I had no doubts. I need to play with that in React Native. So I needed to create a library. And there's a tool that we created at CallStack called Create React Native Library. It's for creating a React Native library, as the name says. And it contains all the various templates for libraries, so Fabric, Views, Turbo modules with backward compatibility, and with really nice developer experience. And huge kudos to Satya and Burak for maintaining it. And also, as a side note, it will be soon included an official way of creating React Native libraries via Golden Library Initiative. And when I was prototyping this project, I also wanted a really simple JS API. So I looked at the demo I showed you with the Chrome, and it was based on Versal AI SDK. And actually, that's all the code you need to play with AI inside your web app. So actually, you import a method called generate text or stream text from AI package owned by Versal. Then you use the provider. You call the method. You pass the provider. You can pass any provider that you want. Here, I'm using the one from Versal that is officially supported, but you can create your custom ones. And then you pass your prompt, and voila, you have your text generated by AI model. And speaking of providers, here is the nice part. You can pass any provider that you want. So you can play with Chrome AI, or maybe you can add your provider from React Native AI module that is getting a model from native runtime, then exports it to the JS side, and then you can easily pass it to Versal AI SDK and just use it. That sounds cool, huh? Let's go with some quick demo, and let's see if this works. So, yeah. Let me mirror my screen. Cool. And, all right, it works. Cool. So on the left side, we have a React Native app. There is example app from the template library. On the right side, we have my phone that is mirroring few QuickTime. And right now, let me turn airplane mode. And let me disable the internet connection. Just a heads up, this Wi-Fi icon is there because I'm streaming via QuickTime, and it's always there for some strange reason. You can like think about it because it's like 2 p.m. right now, not 9 a.m. And yeah, like I can validate if I have internet connection. Oh, sorry. I have no internet connection. So let's play with my app. I can ask, hey. And right now, LLM model is executed on my device. It's working locally, and the answer is generated. And voila, we have my answer generated from on-device via that simple API working in React Native offline. Like I can ask, what's React Native? Short answer. And right now, the model is analyzing my question, like doing some C++ low-level stuff. And let's see if it will answer. And yeah, React Native is an open-source mobile application framework created by Facebook. That's true. I can also ask some math question. Also, if you have any question, I can ask it. Like, it's going to be fine. Or maybe fun. What's Flutter? Oh, no, maybe no. So yeah, if anyone has any question, I can ask it. But yeah, it's working. It's a full React Native app. Here's a dev menu. And yeah, it's accessible LLM model through Vercel SDK on React Native. And here, let's take a look at the code. So yeah, I'm calling my method getModel from React Native AI package. Then I'm using generate text function from AI package from Vercel. And then all I need to do is just a few lines of code, call the method with my model ID that I've packed here, get the prompt from text input, and that's it. Yeah, cool. Demo worked. This is the most stressful part. So yeah, let's back to the keynote. All right, so let's take a look on how does it work in detail under the hood. So React Native AI is React Native library. And under the hood, there's 2 native modules for each platform that I support right now. There's Android. And in Android native code, I write a wrapper for calling the binaries that were produced via compiler. This second step that was mentioned in the how MLC engine works. And then from Android module, I access binaries produced by MLC engine. And here that is .so binary that is used by Android module, which contains like tokenizer and all things for executing LLM model. And same deal on iOS. So on iOS, I execute the model, access the binaries. And actually on iOS, there is a few more binaries at .ai, static libraries. They're linked during build time, so they're accessible. And what's really cool here is that then I export this module to JavaScript part, and I write the JS shim that is compatible with AI SDK from Vercel, and I can use all the goodies that they prepared, so generate text, stream text method. And yeah, this is really cool that I can compare the native side and JavaScript part really quickly. But of course, there were some required polyfills. It would be too good if it would just work. So there are some polyfills for streaming and all kind of things. But actually, in React Native space, it's getting better and better. Tsvetan, who is maintainer of Hermes, which is a JavaScript engine for React Native, recently tweeted that text encoder will be natively supported in Hermes, and other polyfills that I've added are being added. So we are getting there. And what I wanted to say is that takeaway from it is that that's true power of React Native, that we can play, we can compose. If I wanted to play with C++ low-level stuff and then export it and have really nice JS API that I can plug into with a few lines of code, I can do it. This is true power of React Native, where we can leverage the possibilities that this technology gives us. Let me grab a sip of water. All right, so what's next? What's with this project? So this is the first iteration of this project. The API is not complete, and this is just the early prototype. Also need to sit down with Oscar, who had a talk earlier, and compile it on Vision OS. So I can play on Vision Pro with the AI model, because Vision Pro actually have M2 chip, which is really nice and performant for executing LLM models. So it actually could work well. And also, taking into account that Apple is working on integrating AI models into OS, maybe in the future we'll be able to plug via nice API to models that are shipped with the OS. And yeah, I've just open sourced my work. So if you're curious how does it work in the detail, you can scan this QR code or go to my GitHub account and search for React Native AI repository. And yeah, thank you, the GeekConf, for having us, having folks from CallStack here. And we, as CallStack, we organize the conference in a month or so in Wrocław, Poland, not that far away. And yeah, if you're interested, here is a promo code, just scan it. And yeah, hopefully see you in Wrocław. And that will be it. Thank you so much.
Yes, all right, thank you so much. Keep it going, Shimon, yeah! Woo-hoo! Okay, thank you. So we are going to keep this party train moving with our next speaker, who is perhaps one of the few folks who can be even louder into a microphone than me. So get excited. Everyone, please put your hands together very quickly and very loudly for our next speaker, Tejas!
Tejas! Hey, thank you so much. Hey, everyone. How are we feeling today? Thank you, Carmen. This is Carmen Huidobro, everybody, the only person awake here. Let's maybe try that again. How is everybody today? Yeah, maybe better. Thanks so much for having me. I'm really excited to talk to you about things today. The conference is React Native x Modern Web. I'm here to talk to you about the modern web side because the previous one was React Native, but the thing we have in common is AI, specifically Gen AI, okay? It's a hyped topic. I'm trying to not deal with a lot of hype today, and I want to give you a balanced take on AI, and specifically AI engineering, and convince you that you could be an AI engineer. If I try to see how confident you are saying I probably could be an AI engineer, can you show me? Okay, like 4 of you. Hopefully at the end of this, there will be more. My whole thing is eliminating imposter syndrome and actually helping you do your best work and live your best life. Okay, so with that little bit of an introduction, my name is Tejas. That's pronounced like contagious. Don't worry, I'm not. And over the years, I've had the privilege of working at a number of different tech companies in some capacity, as a consultant, as an employee, whatever it may be. And I got to learn from the very best. And I'm here to share not just things that I've learned, but things that I've learned from experts and really great people, some of whom are sitting here today. Today, I'm a developer relations engineer at DataStax. We do Gen AI stuff. In fact, we make a lot of open source Gen AI stuff, which is why I joined the company. I believe in open source, and I believe in Gen AI, and I think we can really combine these to make some great things. Today, we're going to do a detailed look at AI engineering. AI engineering. I want to start by looking at this term specifically, AI engineer, because before coming here, I talked to a bunch of folks, and I was like, hey, kind of like we did just now, do you feel like you could be an AI engineer? And like, exactly like in this room, maybe 1% or 0.5% of people said yes. And the rest were like, I don't know, I don't know Python, I don't know linear algebra, I don't TensorFlow, I don't know about math, I didn't go to university. And so there was a lot of like uncertainty there. And I want to eliminate that today, okay? So I asked people, and the big mistake that they made was they conflated AI engineering with machine learning engineering, because that's all we've known so far. And even worse, with machine learning research. Research and engineering are fundamentally different things, as is science and the application of science to solve problems, which is called engineering. So some semantics are not crossing. So let's just start by establishing a working definition for our time together about what an AI engineer is. And for this, I'm not really the best person to come up with such a definition, but there are people more qualified to do so, better suited to do so because of their companies that they have and the positions that they've had. There's a great blog and newsletter called Latent Space by my friend Sean Wang. Some of you may know him as Swix. And he wrote this article called Rise of the AI Engineer. And in it, he makes the definition of AI engineer. What is AI engineer? What is this? And he uses this really great diagram in his blog post. And it's really a foundational post about what makes AI engineering. And this diagram, I feel like, is foundational for what makes up AI engineering. On the very left, or on the origin, you've got machine learning research. That's very different. It's science. It's doing things like training models and doing evaluations on those models. One layer up is machine learning engineering. This is doing inference on the models reliably and coming up with new synthetic data that you can use to fine-tune those models. But you see this big line down the middle, the dotted line, is the API. And really everything after the API, Sean puts it in his article, is AI engineering. So it's the interface between software full stack engineering, as you can see at the far end of that, and machine learning research. So what is AI engineering? It's communicating with an API behind which is a machine learning model, fundamentally, right? And then at the end of the spectrum, after AI engineering, where also you find things like front-end engineering, back-end engineering, DevOps engineering, you've got full stack engineering, which combines these across the stack, okay? This works well, this mental model, because fundamentally, as an AI engineering, you're applying the technology, that is AI, to solve problems. Engineering is really just problem solving. And so if you want to make it really crude and just hand-wavy, you could say that when you make a fetch request over JavaScript in a React Native application to an HTTP API where some large language model is hidden behind, that's AI engineering. Doing a fetch to ChatGPT to get answers to solve a problem, you could call that AI engineering. This is Sean's blog post. Underneath it, though, is a really important sort of corroboration. There's this quote. It says this. It says, in numbers, there's probably going to be significantly more AI engineers than there are machine learning or large language model engineers. One can be quite successful in this role, and pay attention to this last part. One can be quite successful in this role without ever training anything. Okay, and this should really speak to a lot of the people went like, oh, I don't know anything about training models. You don't need to be an AI engineer. And I think this is very important because who says this is Andrej Karpathy. Anyone know Karpathy, like about his track record? He was I believe it was the VP of AI at Tesla, responsible for self-driving, and one of the co-founders of OpenAI, the company behind ChatGPT. The co-founder, pretty much invented ChatGPT. Also, as a YouTuber, he's got a ton of free content, hours and hours long, about how to build your own GPT-2. So a great resource. And really, if anyone knows anything about LLMs, it's definitely Andrej. And this is what he says. So he sort of agrees with this. And so what is an AI engineer? Call an API, use a large language model behind the API to solve a problem. Boom, you're an AI engineer. Okay? This article also goes on to say that this will likely be the highest demand engineering job of the decade. And it sounds very hypey, but there are people working as AI engineers earning like $600,000 a year. Literally, this happens. And so where there's hype, there's money. And this is not like crypto money. No offense to Web3 people, but like value has been shown time and time again in the land of Gen AI through protein research that is showing real promise in the medical industry, to learning. I've learned a ton through using tools like Perplexity and Claude. So there is value being demonstrated. Let's now go a little bit further. We've talked about AI engineering. Let's talk about AI. What is AI? Why is it hyped? There's really multiple kinds of AI, right? There's rule-based AI, which is, yes, the system can be artificially intelligent with a bunch of if-elses. You, as a programmer, write the rules ahead of time. And like Pac-Man is a great example of this. You eat the little cherries, and the ghosts turn blue and start avoiding you, if you've ever played Pac-Man. That's AI. It's just rule-based, meaning developers wrote those rules, and the computer simulates intelligence. That's totally AI. There's also predictive AI, which finds its roots in a paper published in 1906 by a mathematician named Andrei Markov. You may have heard of Markov chains, right? These are the basis of neurolinguistic programming and large language models, but that's where the roots are. And what they do is they help you predict the next state based on the current state of a system, probabilistically. So on your phone, above your keyboard, if you have these little word suggestions for the next word based on what you've written, and I don't know if you try this, but you just tap the middle word like a bunch of times, you end up with a nonsense sentence. That's because that's a big Markov chain. And the problem with Markov chains is that they're limited by memory. They can only give you the next state based on the current state, not all the states before it. Okay, it's called the Markov property. But that's an example of predictive AI, which isn't very intelligent, but it still has its place. The hyped AI is Gen AI, generative AI, or sometimes called Gen AI. And this finds its roots in a 2017 paper published by Google. If you ask me, it's just my opinion, but I think it was maybe a mistake for Google specifically to publish this paper, because now a bunch of companies are eating their lunch. In any case, it's a good thing that they published it. And this paper is called Attention is All You Need, right? And it models a way of taking input tokens and paying multi-headed attention mechanistically with programming to not just the one piece of state, but the surrounding tokens in parallel. The surrounding, by a token, you could say it's equivalent to like one English word. So you take a word, you take the surrounding words, and you model literally attention to context. And based on that, you give 3, 4, 5. You give a set of output tokens. And this paper, for sure not. And so the answer we're going to see from 3.5 Turbo, depending on the internet, If you're on Wi-Fi, maybe get off. We'll see. I don't know, we'll see. The nice thing is it says thinking, you see? But we shall see. Also, oh, there we go. I'm sorry, but I'm unable to provide real-time information as I do not have access to it. This is pretty standard. It doesn't have access to the internet. So let's do RAG and fix this. How can we do that? Well, we need an embeddings model, we need data, and we need a vector store. We have all of those things. So we can get data from like the BFI, the British Film Institute. This website, this web page has all the list of the Oscars, right? So we just take this and crawl this website, break it up into a list of numbers, that is embeddings, and store them in a vector store, okay? How might we do that? Well, this is Astra, it's a database, and I'm gonna create a collection or a table. If you work with databases, you think of tables, right? I'll create one, I'll call it, I don't know, stuff. And I can say I want embeddings from OpenAI. So I'm going to choose an embeddings model. You don't really need to know much about it. So we'll choose an embeddings model, and I've created a collection. And here I'm going to store the contents of that web page as lists of numbers, okay, as vectors. So now I need some way to get the content of that British Film Institute website and store it here so I can search it, okay? This is also modeled in Langflow. So if I come to Langflow, just if I scroll down a bit, this is a write flow, not a read flow. So let's look at this a little bit. So I have a URL, and this URL is the British Film Institute. It's that thing I showed you, the blog post. We take that web page and we break it down into chunks of text where it's no more than 1,000 characters. So we just break it. We get the English text, we break it down into chunks. We then take those chunks and insert them into AstraDB, into the collection that I just created called Stuff. Okay? We also attach an embeddings model to convert each chunk of text into a list of numbers. Is that clear so far? Yeah? So we're just going to store this web page in my database. So I'm just going to click play, and it's going to crawl that website. And as you can see, it's inserting it into my Astra collection that I just made. And in, I don't know, a few seconds, we should have the data. There we go. So it took about 10 seconds. And I think now if I go to Astra and maybe reload the page, I should have just that web page, but as a bunch of text in there. So take a quick look. Yeah, so this is the contents of that page. And it's just chunked text, split into chunks, right? There's also vectors. You see this? This is the big list of numbers. And it's a very long list. Like if I go to VS Code, like, look at this. It's bananas. That's just like a bunch of text from the website. But the cool thing with vector search is we can search how similar is the user's query represented as numbers to this, right? And we find the closest match. Anyway, so now that we've ingested this data, let's go back to the playground. And I will just ask the same question again. So who won the Oscar for... And what it's going to do now is search through that data set, search for the words best picture. Remember, we talked about embeddings. They take natural language and turn them into numbers. So when I say best picture here, it's going to take this and search the database for best picture. What's close to best picture? Get the result and use that to generate text from GPT 3.5. So I'll click play, and we'll wait anxiously again for like 2 minutes. I swear it's not my fault, it's the internet. And there we go. Look, it's so terse. Oppenheimer one, it just knows this now. And the cool thing is I could even be like, give me the highlights of the Oscars 2024, right? And previously it wouldn't know anything, but now because it has the data from my database, the real-time data, it can generate new text based on the context I provide with my RAG flow. So like how do you write highlights? There you go. Some highlights include Oppenheimer winning 7 awards, Emma Stone won Best Actress for Poor Things. All of it, this is completely new stuff created from my abstract stuff from a website. This is RAG, okay? I can see that some of you are thinking like, this is cool, it's great, but I want to kind of now build a chatbot. Please do not build a chatbot. I think chatbots are cheap. I think it's unimaginative. It's like we have plenty of... You can do more. And this is what I'm here to tell you. I work with Gen AI, and chatbots are so 2022, okay? I think we can do better. So the Vercel team, I used to work at Vercel. The Vercel team is doing some really great work with their AI SDK. And they are bringing what's called Generative UI, where, I don't know if you know this, but large language models like GPT-3, actually GPT 3.5 and onwards, can call functions. So like human beings, like if you ask me, hey, Tejas, what is 274 times 9 plus 7 divided by 17.1. I'd be like, I have no idea, but let me go use a tool. So I will pick up a calculator and do that, and I'll get the answer. LLMs now have the capability to recognize when they just can't and when they need to call a tool. And with OpenAI's and with Claude and with a bunch of APIs now, you could include tools. Hey, call this function if you don't know the answer. And with the Vercel AI SDK, they make that very easy with developer experience. So what you could do is call a function that returns some value. You know what a function that returns a value is? It's a React component. So now, generative UI is your LLM will call a function that actually returns JSX that then you render in the render cycle. You see, now we're thinking beyond chatbots. So let me show you. I built something because I was annoyed. Like Kitse was saying, we build the best things when we're angry. You can tweet that. So I went to Netflix, right? And I'm like, I want to watch something. And it was Saturday night. This is my family. We share a Netflix account. And I want to watch, oh gosh, is this code of conduct violation? I want to watch something. So I went on Netflix and I searched for movies with a strong female lead, right? Why not? And Netflix doesn't have really good search. Like, it searches for keyword substring matches instead of like what I want, instead of my semantic, what I want. I could search for, how about this one? How about like romantic comedies in Europe, right? It's like, yeah, I don't, the UI just broke. I don't know. So, not very good. So using RAG, right, and Gen UI, so function calling with an LLM to return React components, I created a little project to see what happens. So if we come to here, this is movies++. This is something I created just as a proof of concept. npm run dev. Let me make sure it's actually running. And it's using those things that I showed you, RAG, okay? So localhost 3000, and I could just choose my prompt here, movies with a strong female lead, and now it functions sort of like a chatbot. So it's not the best because it's like, sure, it's giving me this list, but the kind of nice thing here is it shows me who the strong female lead is, which is pretty cool, right? But using Gen UI, we can do better. What might this look like as UI? And now we call a function that gets the posters and return. Wow, look at that returns thanks, yeah. And it's interactive. Like, it can respond to my mouse cursor. In fact, I can click on this and I can like go to the website and read more if I want. And it knows the movies with strong female leads. I could even, since we're just rendering UI, I could show me the trailer for Wonder Woman. Why not? And it's gonna like find out and just straight up like render a little video that will start. Yeah, just like right here. I just watched the trailer. Why not? And then I could go back to text if I want. Did people like, what was the critical reception of Wonder Woman, right? And what did people say? Did they like it? Did they not? And then it goes back to text. So sort of picking the right modality for the job. This user experience is far superior, right? To like, I just feel like watching something with Keanu Reeves. And like, you don't know, right? So Gen UI, no chatbots. I'm sort of using chat here to illustrate the point, but you can generate actual user interfaces with React, even React Native and AI. And this, I think, is the future. I have like 5 minutes left. Let's look at the code that does this, and then we'll wrap up. So what we have is a big AI component. This is really where the magic happens, where we have this function StreamUI, and I'm saying talk to GPT-4o from OpenAI. You could put any model in here. You could put Claude, you could put whatever, right? Messages is exactly what it sounds like. It's an array of a role. In this case, it's user or assistant or system or tool, and content, which is your text as a message. Then in the case that we return text, you can return a React Markdown component. But when you need to call a tool, this is the real secret sauce. So you have this configuration object called tools, and each of these, show trailer, create Gen UI, these are tools. They're functions. So what does a tool have? It has a description, some parameters, these are arguments, and a generate function. And this is the secret sauce. So the LLM will call this function based on this description. Literally, when the user asks for a trailer, use this tool. And that's how it knew to call the function, okay? Once it calls the function, we connect to our Astra database. That's the one I just used. And even since it's a generator function with a star, I can yield. While it's loading, I'm like, show a spinner, yield a spinner, but then continue to fetch. And then yield again, another spinner. And then finally, return a video player, React component. That's all. It's a function that returns JSX. And you can use this with React to really transform the UI of your applications. Okay? One final thing I want to show you is this is backed by Langflow that we looked at earlier, because this thing, you click this API button, and you actually get an HTTP API. So you could host this on AWS wherever you want, and that RAG pipeline becomes just accessible over HTTP. Right? And so this is some ways that you can actually combine Gen AI and Gen UI to not just build another chatbot, but build something your users are actually going to want. Not that they don't want chatbots, but something that pushes the boundaries a little bit. All right, it's time to start wrapping up. Let's just summarize a little bit, and we'll go from there. Gen AI is hyped for a reason. There's a lot of room at the table. If you can call an API that an LLM is hidden behind, you can be an AI engineer, and I would invite you to the space. Thanks so much for having me. I can't wait to see what you're going to build. It's been a pleasure, TheGeekConf.
Yes! Keep it going, Vortejas! Coming to us from the data stacks. Alrighty, we have another amazing talk for you coming up right now from our next speaker, who is, like Tejas, also a Berliner. And I don't mean the jelly donut either. So everyone, please welcome from Crab Nebula, Attila! Woo! Hey. Oh, you can clap louder than that. Give it up for Attila! Oh, come on, y'all. You got it in you. I know you do. All right, on the count of 3, I'm going to count down from 3, and you all are going to go, woo, really hard so that Attila gets all the energy he needs for this talk. Ready? 3, 2, 1, woo!
Yeah, now we're talking. Awesome. How's it going, everybody? Oh, there is my stuff. Yep. So, let's check. Awesome. So we're good to go. And good afternoon. How's everybody doing? All right? Yep. So we're going to talk today about SolidStart. And I'm going to talk to you about how SolidStart works, what are the pieces that put it together, and what's the whole idea behind it. For the ones of you who are not familiar with SolidStart, it is a full-stack framework that is built for the Solid ecosystem. So it's not React, it's a different rendering library, and it would be similar to what Next.js, Remix, Nuxt, these things are, but it's built in a little bit more particular way. So let's see what does that mean. Before we start, my name is Attila Facina. I work as a DevRel lead at a company called Crab Nebula. I'm also part of the SolidDX team, and I'm a Google developer expert. Because naming things is hard, I made this like little shortcuts with all the social media with my website, so you can find me there after the talk to make questions, give me feedback, ask about my VS Code config, whatever you want. Okay? So, as I mentioned, SolidStart is the framework that we built around Solid. So what it is actually, it's the core package and a few other functionalities that we put together into Solid to build SolidStart. So you can actually disassemble stuff. That's why we say it's a very meta framework, because the concept of a meta framework is bringing pieces together like Lego in order to build like efficient, unopinionated, and ergonomic experiences. So it's basically like Lego bricks, as I said, but a lot of frameworks, what they do is whenever they assemble the Lego bricks, they say, oh no, but to assure like the best experience, I don't want you to take it apart. So they kind of glue them together, and you cannot like split them. In my opinion, that kind of spoils the fun a little bit, because Lego is nice when you tailor it to whatever you want it to be. So SolidStart is built around having great defaults to provide you with enough flexibility to adapt the framework to whatever need you have. Which, in other words, means your opinions are welcome when you're building with a solid architecture. You can disassemble, and you can change, and you can configure it, and you can deploy whatever you want. So to get to this point, there are 4 fundamental pieces that built around this. First of all, we have the core framework. So it's the bundler, the serializer, and the server. So these are the things that make SolidStart a full-stack framework. And if you don't have that, you don't have SolidStart. But the other part would be Solid as a rendering library. So then you get the user interface. Yeah, and the third part would be Solid Router, where you have all the client-side logic and the data loading. So that's the first and the biggest piece that you would like to switch if you don't want to. So basically, it works with whatever router you want it to work, as long as you provide the necessary bindings. To this point, to the best of my knowledge, no other router has the bindings that we need to operate with SolidStart, but it is possible with a plugin, with something like that, if you build it yourself. And then we have the Solid Meta, which is going to handle all the meta tags. So the example or the ideal Solid Starter template, if you want to try out, brings these 3. And what we're going to look at it is how all these pieces they work together into building this experience that we need to have a full-stack framework. So first of all, we have the serializer, which is Ceroval. And Ceroval behaves in a pretty special way. And what it happens is it connects all the server functions. So the RPC layer of your framework, it connects to the Ceroval. And Ceroval is going to serialize that and send it to the user. What it does, though, before sending it, is that it caches by reference every artifact that it's going to send, which means that even if you have 3 functions getting 3 different requests from 3 different endpoints, that resource is going to be deduplicated, and you're only going to send and waste your user's bandwidth once. And on top of that, it also has streaming support, which means that you can serialize readable streams, you can serialize promises, and you can serialize streams and promises, and even async generators, which brings us to our first demo. So what I have here is a pretty... Where? Can't you see what's going on? Yeah, there you go. So what we have here is just a simple web page. It has a button, and as you can see from the title, it's the Raven. So what's going to happen here is when I click Start, it's going to open a stream connection to my server and send line by line of the Raven poem. And what I want you to look at is here, to my Network tab, as the size of the payload keeps increasing. So these lines don't exist in the client. They don't come in one go. They are being streamed straight from the server. The way we make it is possible. Can everybody see? Is everybody OK with this? Yeah? OK. So I'll just toss my terminal to the side. And what we have here is we have this line iterator, which is happening in my client-side part. And if you're familiar with React, it's pretty much the same thing. So instead of using state, we're creating a signal. And then we have an effect, which means every time you have something more in the source, you set the new items. And you're setting, like, for every line that comes, you're adding the line to the end. Not the most performant client-side Solid app, but that's how it works. And then inside, you just have a for each, which is our list component. But on the server, that's where the things get more interesting. Where am I? Yeah. So we have this poem.ts, and it works in the same way with a directive. So I say use server, which means my bundler now knows this code will exist only in the server, so it doesn't land in my client-side logic. Now, here I have the poem as a string. And what I'm going to do is I have a generator here. And this is an asynchronous generator, and it's going to write a new promise with an artificial delay. And then it's going to yield one line of the poem every 500 milliseconds. So it's going to keep sending it and streaming it. And that's as much logic as you want to create a stream to your server. So remember, good defaults, great DX, better performance. And my thing is gone again. So we have Serova. Oh, I went back too much with this. So yeah, so again, the second part is Vinci, which is the other building piece. Vinci is a wrapper, a very thin wrapper around Vite and Nitro. So Vite, most of you are probably familiar with, is the bundler, and it can work as a dev server as well. It's the bundler that's most used, like pretty much every framework except for Next uses them, I believe. And Nitro is an agnostic Node.js runtime that's built by the UnJS folks. So it's used by Nuxt, it's used by Analog, it's used by SolidStart, and it's going to be used by 10stack Start, which is the framework from the 10stack folks. And it does a little bit of wrapping on other, like the actual Node runtime and Vinci as well. So what we do with that is Nitro is with Vite, and H3, which is another server runtime. So what we do with Vinci is create a set of configurations that the way we use that with SolidStart is re-exporting them, and you can have without any configuration, and your app is going to work like that. But if you want to configure it, you can go very deep into it. So you can set a middleware, you set a specific file for it. With that preset, that line over there says preset Netlify, you can switch to around 30 presets, then you can deploy to anywhere. Cloudflare, Vercel, Netlify, AWS, whatever you have. And then you can even set the pre-render stuff. So if I say crawl links, this is a Nitro feature. If I say crawl links, it's going to find every link in every file I have and crawl it down at build time, and then pre-render the stuff that I have and cache it for me. I can say that if one of the links that I have in my page is a 404, I want my build to fail. And I can even set, OK, just ignore those things with a regular expression, because in this case, this is actually real code. This is from the Solid docs. And sometimes the parser gets confused with Markdown. And then if you see the last line over there, we expose to the end user the entire Vite configuration. So you can have whatever you want. We have virtual modules. You can have anything you want with Vite. So you have Serval, you have Vinci, and then you have the user interface. When it comes to the user interface, we use Solid, because, SolidStart. I think you saw that coming. And the router, the SolidStart package also exposes a file route component, which you can use as file system-based routing. And it operates in a very similar way to what you're probably used to with Remix, Next.js, Nuxt, Svelte, Kit, and all the others. So by default, it's routes, but you can change that. And then if you have between square brackets, you have a parameterized route. You can have a named route. You can have the index route. You can have a catch-all, a parameterized dynamic route. And you can have a named index route. So if it's between parentheses, this means that this route is going to be the index, but then you can name it so you don't have a bunch of indexes. So we already touched a little bit about how our RPCs work when I talked about Serval. So this is how an actual request from the server happens in SolidStart. We recommend you all to, whenever you're doing a SolidStart, you try to lift all your external data loading to the server, because we can do this kind of stuff. So if you have, every time you have an endpoint from your SolidStart, it creates a server function under the hood, similar to Next.js, Remix, and whatever. And then you're going to hit your API. But between your API, we have a cache helper, and that cache is going to set a key for that specific time lifetime of your round request, and that cache is going to make sure that all requests are deduplicated. So you're only going to hit your API once and get all the data that you need. Once that's ready, it goes through the serialization, deduplicate all the references, and send the data only once. So if these three functions are hitting multiple APIs or only one, you're only going to get one time. On top of that, SolidRouter also exposes a bunch of methods. We already saw file routes, we already saw cache. But now you have create a sync, and you have action, and you have that route, because with SolidStart, we recommend all the data loading to be done in parallel. Like, the framework is basically allergic to waterfalls. So your initial data loading would be like this. So if you have a protected route, you'd have a show component, which is our equivalent for an if-else conditional in this case. And then you have your create async that's going to request that data from an RPC request. And then if that data is there, it's going to show or not. But since that's a protected route and that's a route inside your app, you can export from that page a preload, a route with a preload key. And that preload is going to say whenever the user is hovering or preparing to go to that thing, you already start fetching things. So this means that by default, everything is kind of suspended, and the request can be done in parallel with your navigation. So this is like more of a edge case kind of stuff, because you actually don't want your user to see the profile page if they are not actually a user. But in most cases, what you're going to do is just have a suspense wrapping it around, because then you can have all the rendering already done beforehand, and then whenever the data comes in, you're just swapping them in the DOM, but the resource is already pre-rendered. On top of this, we can also, when you're doing an action, you're doing a mutation to your server, we can return the new page data together with the redirect response. So let's say, and we call that a single flight mutation. So let me show you my last demo. So in here, what we have, oh, no, not here, this. So in here, I have these little Pokemon cards. And what I'm going to do now is, in most frameworks, I'm going to add a new Pokemon. So I'm going to do like my Mon, and I want to have, I think it's this number. So let's take a look at the network tab over here. So if I add it, I have my Mon over here. And you can see that there are two requests. So the first request is the navigation, so the next route's coming in. And the second request is my data. So, so here I have all the data that's coming back. So that's the data post on mutation. And that's how most frameworks work right now. What SolidStart is, let me clean it up. So if I go and I'm going to add my Geekmon, and now if I do my mutation again, I have my Geekmon over here, and I have only one request. That happens because SolidStart is aware that only this data has changed because I told it about the pre-route, and I'm telling it how that works, how my app behaves. So because it knows it can send only the minimum that I need. And to get this working is not, that doesn't need that much boilerplate. What we do is, first, so we have this action, which is what's necessary for me to say this is a form action. Then I say it's going to be a server action, yeah. Once that's done, I serialize the data, and I connect it to my database. I bring the items back, all the counter. I set my new data, and then I can send the redirect, right? So because I'm redirecting, I'm throwing this redirect. It's already sending the redirect with the data of the new page. Because in my single flight, what I did is, So in my single flight, I have this action, and then I have the method that says it's post, and I pass the action like this. That's what you need to do. And then in the index, I define that my route data is the get Pokemons. So it already knows what data it needs for this one. So that's how you opt into this. If you see in the multi one, I have the navigation happening within it. So it's happening on the client side. So then I'm actually doing more work to dodge this logic. Right? So, yeah. So that's how we get to this, to the stage of what SolidStart is doing with your data fetching and with the whole configuration stuff. So to recap, you have primitives, you have nice primitives, you have good defaults, and you have flexibility, which allow us, for example, to mix and match. So I have this other project. I work a lot with this other framework that's called Tauri. Whoever heard about Tauri here before? Oh, quite a few people. So Tauri is this Rust-based framework to create native applications with web technologies. So it uses Rust to connect your binaries, your code to your system binaries, and it renders your app within a web view from the system web view. So what I did over here is I created this template, which it's a SolidStart template under the hood. So inside my source here, it's a SolidStart app, and you can see with all the defaults and whatever you want in this case. So where is it? Here. So my app config has a few stuff that's specific for Solid, and then in SolidStart I can say, yeah, I want you to do the client-side stuff and so on. And this means that by simply changing this one file, I can on CI determine if I'm going to build a web application, a desktop application, or a mobile application, because Tauri is inside this secondary source where I can define here which apps I want to build. So I can build from this app, I can build for every platform with the same code base. The only catch right now is that there's no way to do like the server-side rendering. So that's why for Tauri, I actually need to take out the server-side configuration, but it just works in a multi-build system. So yeah, this is what I had for you. I hope you had enjoyed. So the thing is, the point of this is not actually convincing any of you to use Solid or SolidStart. The point of this is actually looking and helping people in understanding how different frameworks behave, and then if any of these features you find interesting, you can come chat with me, you can try it out, and I'm happy to help. With that, thanks a lot.
Thanks so much. Everyone, keep it going. For Attila, yes! Solid talk, man.
So can I ask one favor from this awesome crowd? Is that I have the best kids, the most supportive kids in the world, and tomorrow one of them has a birthday. So could you please give a hand of applause for my soon-to-be 8-year-old daughter?
You want to bring her?
Thanks. No, she doesn't. Thanks a lot.
Happy birthday! So exciting! Awesome. Oh, what a lovely birthday family surprise. Amazing. Warms your heart. Oh, what will also warm your heart is another delightful talk that we have coming up. I got to see this sneak preview of this, so you can take it from me. So, without any further ado, because we are making up some of our time here, everybody, we got hugs to give. Yeah, go for it. Everybody, please welcome our next speaker, the one, the only, the amazing Carmen. Woohoo! Yes. And while Carmen is setting up her station to drop some knowledge bombs on us, just a reminder that we're going to have a short break after the following talk, and then we're going to also have during that break some goodies for the attendees to come check out in the reception booth in the second building across the way here. And don't forget, we also have our sponsor booth. There's still the community lounge outside, so lots of great spots to be in the break. I think we're just going to have another moment of praying to the technical cable gods.
Could I please see my screen so I can put my slides there? Thank you, thank you.
Yes, and again, we are really like seeing the amount of rolling with different computers and different like tech stacks and whatever that everybody has. It's really amazing, especially because this is our first time here. So we're doing an amazing job collectively getting through all of the technical challenges. Excellent work, all of the speakers and all of their MacBooks. Okay, without further ado, everyone, one more round of applause for Carmen!
Thank you so much. Hi, everyone. Can I take a moment because I have the microphone and no one can stop me? Can we give a round of applause to Anjana for absolutely killing it today? Right? Like, honestly, nonstop, all day, what a powerhouse. I'm gonna hop right in. Don't wanna keep you all too long. And I'm gonna do it here because I don't know how the clicker works. Anyway, one day on the Vienna Freelancers Slack group, I saw this message. I have a client looking for a React Native dev, remote, freelance, good rate, could end up being a retainer situation. You know, reading this kind of sounds like it could go with the music of like, I'm looking for a man in finance. You know? Kinda. Anyway, I just realized that now. Anyway, so the stack for this app was React Native and TypeScript. And like, one of the things that I love about being a freelancer is that for some reason it gave me the confidence to be like, yeah, I can try TypeScript, no problem. Something to note, when I joined, it had been a very long time since this project had been worked on. And let me just illustrate that with what I saw when I tried to run the app. Could not find iPhone 6 simulator. Now here's the thing, y'all. The iPhone 6 did not actually come out last year like I feel it did. It's been longer since the iPhone 6 and now than the release of the original iPhone and the iPhone 6. I'm just sharing some of my pain. Anyway, so I couldn't run it on iOS. Couldn't run it on Android either. I don't know, something about Java. And I thought, well, okay, I'll just upgrade everything. It'll be fine. I'll just, bump React Native, which, just to give you all an idea of where we were at that time, version 55 to 74. So I gave it a try. I was like, okay, well, I'll just hop into package.json and change that 55 into a 74. Easy peasy, lemon squeezy. Turns out that that's not how it works. Something broke. So I thought, okay, no problem, I'll just upgrade React then. But that broke too. And then I tried to upgrade React DOM, and that broke too. And it kind of started feeling like one of those boxes that can I get a show of hands, please? Do you all have one of these at home? A cable box? Let me see some hands, please. The vast majority of you, please keep them. Don't let the haters stop you. You will someday need that Nokia 3310 charger, I promise. For the purposes of this presentation, however, to me it felt more like knitting. Don't let my terrible art deter you. That is, in fact, a ball of yarn tangles next. Actually, I didn't draw either of these, but I tried to draw the ball of yarn. I failed. Anyway, it felt more like trying to untangle a bunch of dependencies. And so, what I'm here to talk about, you might be wondering, what are the best practices for managing dependencies? And well, let's be more honest, what are my favorite practices for managing dependencies? And that's what we're going to be talking about today. But in order to do that, you might know, but who am I? Hi, I'm Carmen, pronounce she, her. I've worked a lot in developer education, and I just love tech community so much because of that aspect of sharing and learning and vulnerability. Like one of the things that my friend Jess and I founded was the Bad Website Club, which is a free learning initiative where we just make websites no matter, maybe they don't look amazing, maybe they're not using, the latest and greatest frameworks, but we're still getting out there. And like, I'm so grateful to be here today with all of you. If it wasn't for the opportunities that I've been given, I wouldn't be here. And I want to encourage all of you to also share and also learn and also be vulnerable when needed. So, let's talk about dependencies, because I don't know about you, but like sometimes I feel I take dependencies for granted. And the thing about dependencies is, sure, it's as easy as running npm install or yarn add or whatever. And the thing is, they add up. Have you seen this meme? The like heaviest objects in the universe? Somebody made a game where, like, I don't know if you all know the game Katamari Damacy, like where you play as a little guy rolling a ball and you pick up stuff and that ball gets bigger and like you can pick up bigger stuff. Somebody made that where you give it your node modules folder and then you can like pick up bigger dependencies and stuff. It's a lot of fun. But sometimes it feels like a careful balance act working with these things. And like, sometimes we feel tempted to go in and change something and it can feel a little bit tricky, like a giant game of Jenga. Now I'm going to do that thing, that super cool thing where I like bring in a clever quote. Art is never finished, only abandoned. I want to clarify. I tried so hard to find out if it was actually Leonardo da Vinci that said this, because it could be one of those quotes that like keeps getting attributed to people like Mark Twain or whatever. Like, but look, I couldn't find anything to the contrary. But like, I feel like a lot of this applies to software as well. We have to keep stuff up to date. We need to keep, bringing out updates as platforms and vulnerabilities prop up. So I'm going to go through a handful of strategies that I've picked up over the years and hope to share some of them with you. Then I want to hear from y'all, what are some of your favorite strategies? And the first one is trying to understand better what kind of dependencies exist. Because, you open up your package.json and you see your dependencies and your dev dependencies. I'm going to be honest. For the longest time, I kind of struggled to figure out which one was for which. And I was like, well, I developed React. I'm developing in React, so I guess it's a dev dependency? I don't know. So here's the thing. Dependencies get bundled into your app, into your production build. Dev dependencies are tools in order to build that production build, but they don't go in, most of the time. Some bundlers can get this mixed up, and there has been some issues on like frameworks. I think it was Meteor that had that a few years ago that turns out they were putting their dev dependencies in their bundles. And we know those. Those are called direct dependencies. And we know the other type as well. And I didn't know they have a name. Transitive dependencies. And these are the dependencies that your dependencies depend on. Wow, that actually came out super smoothly. And these can add up. And they're always just sort of like sneaking in there. But it turns out there's other kinds of dependencies. Have you all heard of peer dependencies? Can I get some hands? Cool. These are dependencies that our package is compatible with. Say we are developing a fancy charts package. If we declare let me try that again. If we declare chart.js as a peer dependency, then when we go to install fancy charts, chart.js will be installed as a dependency along with it. And this means that they're compatible. And then there's the world of the package lock.json. Can I ask, does any of y'all open this file when not rebasing? Okay, cool. This is a declaration of every version of a dependency and its codependent dependencies. And look at that. That's like 18,000 lines long. That's a lot of dependencies. Understanding this has helped me manage my dependencies better. But the other thing to remember is, look at us here. I'm not the only software developer in the world, believe it or not. And I don't know about y'all, but I find it incredible when people go out there and make tools to manage those dependency upgrades easier. Have y'all heard of either of these? Yarn Upgrade Interactive or NPM check updates? I see a couple hands. This is such a great tool because what it allows you to do, I don't know if y'all can see it okay. Yeah, that looks all right. What it allows you to do is see what version you have installed and what is the version available for you to upgrade to, and helps you manage this in a visual way. Can we give a shout out to React Native community? Like, oh my goodness. Has anybody used the upgrade helper before? I mean, isn't it just amazing that somebody out there made a tool that you can be like, I'm going from version 55 to 74, and it gives you not only instructions on how to upgrade, but diffs of those configuration files, so that you can go line by line and upgrade accordingly without, you know, everything breaking, because it does. And when stuff breaks, how helpful it is to break the problem down. Am I the only one who's seen this? Error resolve could not resolve when trying to upgrade something? Am I the only one? Come on, I can't be the only one. That's what I thought. What helps me when I am in a situation like this, and I'm like, you know, deer in the headlights, I'm like, what do I do? I don't know what I start. What helps me is to break the problem down. I'm going to laser focus first on getting the iOS build running. And then I'll worry about Android. And then I break that problem down into smaller problems. Adopt to auto-linking. That's how far away we were. Done. Fix compiler errors. Done. Fix broken UI elements. Done. Fix bugs introduced by upgrading. Done. Fix compiler warnings. Done. All done. Now that that's working, now that the iOS build is running, move on to Android. Same thing. Bam, 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 all done. Then you get back to iOS, stuff's broken again. Doing that systematically kind of reminds me of one of my favorite video games. Hear me out. Please don't make me feel old. Does anybody know Greenhouse from Game & Watch? Amazing. We have one. Okay, I mean, look, I'm not that old, but there was a version on the Game Boy. I know that's old, but hear me out. Anyway, what I loved about this game is that you played as a gardener taking care of their garden, and like bugs were coming in, and you had to focus on each bug. See? Bugs, software. Anyway, you had to focus on each bug at a time. And having that laser focus really helps me not drown when managing so many moving parts, when spinning so many plates. Cool, I'm going to do the thing now where I talk about tools and people have opinions and like, look, I'm going to be honest. You go with the tool that works. I'm a big advocate for the right tool for the job. I'm going to pick Yarn because it has like parallel installs or whatever, or like, oh, fun fact, did you know that the P in PNPM stands for performant? I looked it up for this presentation and that alone. But I can't speak enough about how important it is to understand, yes, the right tool for the job also involves what is working for you. If you know PNPM better, go with that. And a lot of these offer tools to make and understand why those dependencies are installed. Have you all heard of NPM-Y? Nice. It's so cool because you could just be like, hey, NPM, why does my project have dequal? Dequal? I don't know how to pronounce it. And it just tells you which packages are declaring that as a dependency. Have you all heard of knip? Knip? I'm going with knip. Have you all heard of this? Oh my God, it's so cool. It lets you find unused files, look at it there. Dependencies and exports to JavaScript and TypeScript projects. It helps you trim out the parts that you may not be using or don't need. But what about monorepos? Do we have monorepo fans in here? If you're not familiar, monorepos are these giant code bases that share dependencies and are made up of smaller projects. Have you all heard of Yarn workspaces? Nice. This allows you to have those separate code bases that share dependencies. Things like websites, multiple packages. Fun fact, I love when somebody makes a tool that they themselves use. That's called dog fooding, by the way, and it's such a strange term. Rumor has it that it comes from the fact that a dog food company's owner would eat the dog food. Look, unconfirmed. Somebody did look it up. It is a rumor. Anyway, Yarn uses workspaces. Like the Yarn code base itself uses Yarn code spaces, workspaces. I love that. Maybe y'all have heard of NX? Same thing. I mean, NX offers a whole bunch of stuff, but I've used NX for my monorepos, and it's amazing because I just need to worry about dependencies in one place for several code bases. Okay, this one surprised me. Have y'all heard of npm shrink wrap? This is a publishable, okay, hear me out. It's like a publishable package lock. And this is fantastic for when you have things like CLI tools will be locked or published so that you can declare exactly which dependencies you need. Sorry, just saw somebody taking a photo, wanted to give you the opportunity to do that. Have y'all heard of npm audit? Cool. Same thing. Having these tools to find out which dependencies have vulnerabilities and you gotta upgrade them. Because sometimes you know, in order for consistency, in order for release schedules, you don't want to upgrade right away. But when you really have to, there's npm audit for you to tell you which of your dependencies has that issue. But why do it manually? Have you all heard of dependabot, sneak, or renovate? Again, these are tools that automatically help keep your dependencies up to date and monitor for vulnerabilities. But what about upgrading? How big a leap do you have to take to make that upgrade? Because when I was in my situation, sure, I could have gone from React Native 55 to 59 because, well, I don't know, something about JavaScript, Java stuff, JavaScript core stuff. And cool. I could have gone from 55 to 60 because cool, native modules are now auto-linked. Again, this is how far behind this project was. I decided to go all the way. And you might be wondering why in one go. And the answer is, why not? I mean, the thing about platforms like this that we sometimes take for granted is that we're kind of depending on like at least 3 or 4 entities, right? Like, you're dependent on the iOS platform, you're dependent on the Android platform, you're dependent on React, you're dependent on React Native, and every other platform. In a way, you're dependent on every package that you're using. And staying up to date, I find to be more stabilizing, and like, honestly, you're gonna have to do it eventually. I'm gonna take another quote, I'm gonna be fancy. This time from Martin Fowler, talking about doing painful tasks. And it says, if it hurts, do it more often, with the express intent of minimizing that harm. I want to talk about one of my favorite strategies for working on complex dependency management, and those are bleeding edge branches. Have you all heard of these? I get to talk about something they'll have never heard of. This is one of my favorite strategies for doing a big, messy task in Git. Because what you're doing is you've got a branch that you call, I don't know, like I call it Carmen Bleeding Edge. And what I do is I just go wild in there with the express intent of having large, small, a set of broken commits that maybe don't work. And like, I have a history of like my experimentation, and it's easy to go through. And most importantly, easy to rebase and clean up. And finally, I want to talk about knowing when to stop. Because in this project, for example, there were 72 packages. And I still had a deadline. I'm not going to upgrade all of them. And even so, knowing when to go, you know, with semantic versioning, how far to go can be really important as a consideration. And what I try to do is go MVP, minimum viable package, and go from there. But that doesn't mean that I'm not going to, of course, upgrade all of them, because I have to eventually. But going step by step is important. All right, folks. So we've talked about all of these 7 lessons learned. We've understood what dependencies are. We know that we're not alone. We know how to break problems down. We've picked our tools. We've made those leaps. We've used our bleeding edge branches. And we know when to stop. And the thing is, that's not a one and done. We'll be back here upgrading our dependencies, and feeling a little bit of a headache. So am I done? Not really. Now I'm going to do that cool thing where I bring back the quote from the beginning. I like to think that if Leonardo da Vinci was, developing software today, he would probably say, software is never finished, only abandoned. Okay, friends, well, this has been a joy. If you want to get these slides, I'm going to post them on socials. If not, you can get them at carmenh.dev/dependency-management.pdf. And well, it's been an absolute joy talking to you. Sorry, my slides are sassing me. Carmen, don't forget to tell them you promised you would. Right, I should mention something for the sake of transparency. I used a lot of knitting metaphors. I'm more of a cross-stitcher. I just thought for transparency's sake, I should tell you that. Thanks, everybody.
Woohoo! Thank you, friends, for keeping the applause going. And thank you, friend, for giving us such a great talk. Alrighty. We have one more talk, and then we're going to have a little break, and then we're going to get some goodies. So, before we get too excited about what the mystery surprise might be, let us continue stretching our brains ever bigger with our next speaker, Charlotte! Everybody bring it again! Woo! Yes! And we're going to be taking a little break, which hopefully we will be catching up with our regularly scheduled content. So after this next talk, I will let you know exactly what time we'll be coming back. And then I'm going to give you a little surprise of what you're going to be picking up from the organizers. So before we jump back in, again, can we give a huge round of applause to the volunteers that are making all of this happen? They've been running food back and forth. They've been getting us coffees backstage for the speakers and for me and so on and so forth. So huge thank you to all of the GeekConf crew. All right, take it away, Charlotte.
Hi everyone, I'm Charlotte. I'm a React Native Tech Lead at Theodore Apps, and today we're going to talk about flows. Most of our apps have flows, like an onboarding or auto payment. Flows are a succession of pages where you know where the user is going to go next. They are defined in a predefined order. Most of our apps have flows, but when they grow up to be more complex, it's very easy to end up with unclear code. Last year, when I joined a new project with an already implemented flows, I was tasked with the simple task of simply adding a page within the flow. But the code was so complicated that I couldn't even do that. I was the only developer arriving on the project. I lacked guidance. So I spent days digging within all the pages, trying to figure out the flow as a whole, trying to decipher all the navigation paths. And even after all this time, I wasn't confident about adding a single page. Fast forward a few months, and I'm tasked with developing a new flow. So this time, I was determined to do it right. This is the story of our reflection towards building flows that are as clear as possible. Today, we're going to use the power of state machines to enhance React navigation to handle even the most complicated flows. Before we dive in, let's properly define what a flow is. A flow is a succession of pages, like an onboarding, where you know where the user is going to go next. Contrary to regular navigation, where the user can just decide where he wants to go to. With flows, the user doesn't have to make a choice. He just hits the next button every time, and you can know in advance which page is going to be the next one. The flow I had to implement looked somehow like this, only more complex. You don't have to read it through to understand it has lots of conditions, lots of intelligence in it. It's still a flow. With certain parameters, you can still know where the user is going to go next in advance, but it just has a lot of logic. And the problem is, if you just simply use regular page-to-page navigation for this kind of flow, it can get really hard to get a good overview of the flow as a whole. If you simply define your pages this way, like we normally do, you define your pages, but you don't define their order. To know all the possible pathways, you have to dig inside every single page and look at this conditional navigation. So how can we solve this? How can we write code that screams at us, these are all the possible pathways? That reassembles all the logic, all these possible paths together in one single place. That offers new developers a good overview of the flow without requiring them to dig inside every single page. That's the problem we're going to try to answer today. Before we talk solutions with specific tools we tried, let's abstract ourselves away from all possible limitations. Let's imagine in a perfect world what the ideal solution could look like. I have two criteria. First, get a good overview of the flow in one place. And second, remove from the pages the responsibility of knowing which page is the next one. So instead of navigating inside cart review to this specific page, we'd like to have a method like go to next step. This way, cart review doesn't have to know its position inside the flow. So what could be our first approach? This go to next step methods, it may seem familiar to you. It actually looks a lot like a state machine. Let's define what a state machine is with a simple traffic light example. We could define a traffic light system with a state machine. A state machine has states, in our case colors, and transitioning events to transition from one state to another. Inside your state machine, you define both the system and its current value, and you can send a next event to transition to the next state. This way, all of your logic is handled only in one place. So, what does this mean for our flows? Our states could be our pages, our steps. Then, when the user hits the next button, we could send the next event and transition to the next state. This would look somehow like this. We define our state machine here with all of our steps, all of our pages, A, B, C, D. And inside the A step, we define this next event. And when we hit next, we are going to transition to the next state, to the next page, B. When we transition, we are also going to perform navigation. We are going to navigate to the next page to make sure we see it on the screen. This way, inside our A page, we can simply just send the next event, and A remains unaware of its position within the flow. This is a great solution, but it actually has a very big problem, that our state is duplicated between two. Our state, which steps are we currently focusing on the flow, is split between two states. Obviously, the state of the state machine, which is our source of truth. It tells us where we are within the flow. And also the navigation states, which determines which page is currently focused on the screen. When we send the next event, we change the state of the state machine, and we have to make sure we update the navigation state as well to display the correct page on the screen. If we forget to synchronize these states, we have a bug. We fall out of sync. So this implementation is very bug-prone. If we just forget to navigate within the state machine, we have a bug. So instead, we went on to our second approach, a more declarative one. Instead of defining our pages this way inside a traditional navigation stack, we defined it this way. From the value of the state machine, we defined our pages. So instead of defining a stack, we simply return the correct page. This way, we don't have to navigate manually anymore inside every single event of the state machine. This is a little bit better, but there is still some configuration that we really should not forget, otherwise we have a bug. And also, we lose transition animation. We don't have a stack anymore. We just return the pages. And React Navigation actually never tells us to do something like this. So we went on to our third and last approach. When one of our colleagues asked us, have you thought of building a custom navigator? Turns out you can build your own custom navigators tailored for your own specific needs. This way, we could merge our two states into one. We could build one navigator that could have a state with the shape of a state machine. So let me introduce you to the Flow Navigator. To show you its API, I would like to use a simple payment flow example that has only 3 pages. Remember our 2 criteria. First, we want to get a good overview of the flow in one place. So this is how you would use the Flow Navigator. It really looks just like any regular other navigator. Only when you define your pages, you also define their order. So here you're saying, I have cart review, then payment, then success. This way, you have in one single place the order of the flow. Then, second criteria, we want to remove from the pages the responsibility of knowing which page is the next one. So inside cart review, you could simply call this go-to-next-step method. The way that this works internally is simply through an index, which states which page is currently being focused. Initially, it's equal to 0, so initially we're on cart review, and when you call go to next step, you simply bump the index and move on to the next page in the order, so payment. This is our Flow Navigator, but we have a new functionality now. We want to be able to handle conditional steps. We have now this new document page that has to be displayed only once to each user. This could be implemented somehow like this. Here I define this Boolean has to sign, currently using Jotai. And according to its value, I'm declaratively adding or removing the document signing page. So initially, this value is truthy. So document is within the stack. So when I call go to next step from cart review, I move on to the second step, document signing. Then inside document signing, when I click on the go to next step button, before I call the go to next step function, I'm going to switch off this Boolean to false. This triggers a rerender on this component. So here we have has to sign false, and we're removing the document signing page from the stack. We called go to next step, so we moved on to the next page within the flow, payment. And if on payment we call go to previous step, as document signing is not in the stack anymore, we are going to go back to cart review. This is simply how it works. But you may want to have several conditional steps. If you do, you may group them together simply using groups. And this is our solution. It solved lots of our problems of architecture, but it still has some limitations. First, the most important one is that we can't actually really see all the possible pathways within the flow. Here, you know that you have 3 conditional pages, B, C, and D. But you can't really know all the possible pathways at any given time. You don't know the value of these flags. So here, from this view, you can't tell whether it's possible to navigate from B to C, for example. If we wanted to solve this for more complex cases, we could imagine adding another API that's closer to a state machine. If we had a configuration like this, it now becomes clear that from B, it's not possible to go to C. You can only go to C from A. The second big limitation we have today is that it's currently possible to use the Flow Navigator with React Navigation. We haven't built it for Expo Router yet. And this is all I wanted to share with you today. I hope that you've enjoyed this reflection on architecture and responsibility. And next time you see some logic that's spread throughout your app that could use a state machine, I hope you think of Xstate. Also, building a custom navigator is very easy, and you can build it for your own specific needs, whether it's logic, just like with the Flow Navigator, or whether it's design, like the bottom tab has a different design than the drawer. Big shout out to the people at Theodo Apps who helped building this Flow Navigator. Here is its code if you're interested in checking it out, and here is the code of the first 2 examples. Thank you so much.
All right, folks, keep it going. Thank you so much, Charlotte. Woo! Yes, I know, we're all in need of a coffee, right? Let's give it up for coffee. Yeah. Okay, so we are going to take a break, and we've actually more than caught up to our schedule. So we have a nice long break, and we will be back here, back on track with the schedule at 4:50, so 10 minutes to 5. And we will have our last chunk of talks. Okay, so during the break, you're probably all wondering, what are these exciting goodies I've been teasing about all day? You are all going to discover a literal goodie bag from the GeekConf and the amazing sponsors and organizers. So you can pick it up in the in Building 2 in the registration desk area anytime between now and the end of the day. So enjoy the sunshine, enjoy the caffeination, and we will be back here at 50 minutes past the hour, 10 before 5. See you then. Woo!
Welcome to the GeekConf. 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 Welcome to the GeekConf.
geeks are all outside. Everybody outside, come back inside for our last talks. Are you excited? We have a few more talks for you today. Are we ready to bring home the GeekConf with some amazing crowd energy that gets back to the speakers and gives them energy to give you great talks? Are we ready for the last talks of the day? Yeah! Amazing. You are a fabulous audience. And I'm also talking to all of you outside. You're also a fabulous audience who needs to come inside. Okay. Anywho, before we jump in, I hope everybody's been getting their tote bags. If not, don't forget to, yes, exactly, get your beautiful Geeky Ants tote bag from the registration desk in the building next door. And stick around for the last talks. And we're going to have a couple of thank you words at the end. And we're going to take a historical photograph, the first ever family photo of everyone in attendance at the GeekConf. We will take after the end of the conference out there by the pillars in front of the venue for those of us who are in person. And for those of us on the live stream, we'll Photoshop you in later. No, just kidding. In any case, so don't forget to stick around. You won't want to miss showing the world that you were there. You were in the room where it happened, of the very first of the GeekConf. All right, so let us continue on with our final section of the day. A little bit sad, but we're not sad, we're excited. And so we are going to show that excitement very loudly and very energetically to our next speaker from Software Mansion. Everyone give it up for Łukasz! Yes! Woo!
Okay, I think we can start. So, okay, so let's meet Dave. He's a software engineer working on mobile app using React Native. He's really good at it, but he doesn't have any experience with native mobile development. One day, Dave's boss sent him a list of new requirements for a mobile app. That list was impossible to fulfill for Dave, and it was quite ridiculous. But Dave needed to meet those requirements to satisfy his boss and not lose his job. So Dave did what everyone else would do in his position. He started searching for help. Recently, React Native ecosystem has been thriving with a wide array of modules available. You can easily find what you need. You can, such as Expo Video, React Native Video for video-related tasks, or even libraries to display charts or 3D graphics. But each project is unique, and sometimes the key is to do something different than everyone else. That is when you might find yourself looking at the blank result screen. Or maybe you need to use certain third-party libraries. So for sure, at some point, you will end up on that screen, just like Dave did. That is where most people start to panic, because they are not familiar with native tooling or different workflows that you have to learn. But really, is there anything to be afraid of? Today, I want to show you that you don't have to be afraid of writing native code. It's just a code, like everything else. And if you are familiar with programming, it won't be a challenge for you. You can build your first module even today. So, hi, I'm Łukasz. I'm working at Software Mansion on Expo. And I think we can start. So, what we can do first? I think the best advice is to just search for help on how to get started working on native module. You will quickly learn there are 3 parts that compose a native module. A static specification defined using a type system, like Flow or TypeScript. Generated glue between JS and the native world, and the module implementation. So the TypeScript spec or Flow spec makes sure that everyone else will use your API correctly. On that slide, you can see a pretty easy spec for a module that contains only one method, add. The CodeGen is a tool that takes the spec and creates a conversion layer between JavaScript and native using some C++ magic. Usually, it's added as a build step, but you can run that command on your own and play with the output and see what will be generated. And finally, we have the meat of our module, so the native implementation. On that slide, you can see implementation of the add function using Objective-C on iOS. That system is called Turbo Modules, and you will end up using Objective-C on iOS and Java or Kotlin on Android. That is cool, but it seems really complex, isn't it? Are you supposed to deal with C++ layer? What if the native API is different on each platform? Or you might be curious about those and many other questions about that thing. So for those who still think it is a little bit too complex, there is actually another way of building native module. You can use the Expo Modules API, which was built on top of the JSI, so you won't lose any performance. That is the same tech that powers the Turbo Modules. It was designed to be modern, so you can use Swift and Kotlin, and it will work very nicely with the newest feature of those two languages. There is no need for additional tooling, such as CodeGen, and we put a lot of effort optimizing the time that we need to spend finding our modules, so it won't slow down your process and build systems, even if you have a lot of them in your projects. And I've been thinking a lot how I can showcase you the Expo Modules API, and I decided to go with example. And normally, that is the part where I'm doing a live demo, but every time I do, something just blows up, so maybe it's not a good idea for today. We will be sticking to slides. And I prepared a simple demo. We'll be implementing the clipboard module on Android. OK, so we can start by defining a class. We can choose a name here. It doesn't really matter, but choosing something meaningful is always a good idea. However, it has to extend the module class. That class gives us access to some helpers, other modules, or functionality like sending events. So it's a nice base on which we can build on. We need to also override one function called definition. The definition is just entry point for our module. Here we can describe how that module would look like, what parts will be exported to the JavaScript, using DSL-like syntax. And here we can see the first component, which we need to learn, the name. That name tells our API under which key the module is exported. Using that string later, we can basically get our module on the JS side. OK, now we can start to implement something useful. So we can use async function component to describe a function, to export an async function to the JS. That component takes two parameters, the name, which is just a string, and the body, which is just a lambda that also can take some arguments. But for now, we will leave that empty. So we just exported our first function. It doesn't do much. We need to now somehow access the native clipboard. That is quite simple. We can obtain the clipboard manager using Android context. But what is Android context? Context is just a big box with all the important stuff for your app. Basically, all the shiny tools are in that class, letting you use some services, hardware sensors, and more. So we can access it via another context, which is fun enough, the app context. The app context was provided by the Expo Modules API to give you modules-related stuff. And yeah, that's it. That's what we need to do to actually get the Android context. However, the context may not be available, and we have to handle that case somehow. While working on multiple Expo modules, we found out that we are following the similar patterns for reporting errors. Each package has its own string that is passed as a promise rejection if the context isn't available. The same problem is described using a different sentence across multiple packages, which make your users confused. So we decided to provide a set of common exceptions that you can reuse in each of your package. And here you can see the one of them. And we are throwing. Does it mean the app will crash? What will happen? So if something throws inside of the async function, inside of the lambda we defined previously, it won't be a crash. It will be converted into promise rejection. So basically, you are using the native way of saying, OK, something went terribly. We need to handle that somehow. And we have to handle that on the JS side, but it won't crash your app. OK, we have the context. So now we can get the clipboard manager. Also, quite simple. We are defining another property. That is how you can get system service from the context. Normally, those kind of lines you will find in the documentation, so you don't have to understand them. You just need to Google. But there is one important part, that question mark here. It means that the clipboard manager may not be available, so we need to handle that as well. So let's throw something, but what we should throw. So as you may guess, we cannot provide you a default exceptions for everything. You have to sometimes create your own one. So we can do that really quickly. So to define exceptions, we just need to define a class that extends coded exception. By doing that, we are saying to the API that that exception was meant to be thrown and was meant to be sent to the JS side. If you throw something that doesn't extend the coded exceptions, it will mean it was probably unexpected error. It still will be a promise rejection at the end, and still you can handle that on the JS side. But we are distinguishing those two cases, and if you are not extending the coded exception, we will be wrapping the error with the unexpected exception at the end. Also, we can provide the message to clarify what happened to the users. OK, we have that. So now we can implement our function. OK, so I'm using the clipboard manager to get the primary clipboard and the first item. And then I just convert it to a string. Everything else will be handled by the API. You don't have to do anything else. That is cool, but the clipboard can contain different data types, such as plain text, HTML, or even images. We should handle at least 2 of them. For that slides, you can handle images on your own if you want. But we need to get a user input on what type is expected. So we will end up adding another first parameter to our lambda. But let's define types first. So I would like to use enums to represent the difference between plain text and HTML. The name here doesn't really matter, but that string is very important. That tells the API by which type your class should be represented on the JS side. You can choose between strings and ints and other types here, but probably strings and ints are the most common one. To make it convertible between languages, we need to implement a special interface. And then you can just provide your values. The first part is the native identifier used in Kotlin. And that string is the string which will be converted into or from on the JS side. That would be enough, but when dealing with options like that, it's always a good idea to wrap it inside of some kind of object to make it possible to extend in the future without changing the API, because you can provide a default value and that would work. So we can create a class options that extends record interface. Here we are facing another very important concept related to Expo Modus API, records. It is a struct which allows each field to have its own type, and you can also provide a default value. This makes it perfect to describe plain data classes, objects that are sent between JS to native or native to JS. So basically, we are saying that function will need an object with a property called format. The syntax here is quite simple. The property name will be used as a key. We need to add a notation to make sure that property will be part of the conversion mechanism. And you can also provide the default value. Now we can come back to our function and start to modify the body. OK, so I've added the additional argument. And now I can decide what to do with data based on the user input. OK, we created first async function, but we can easily switch it to synchronous using a different DSL component. It's not a big deal since we are not doing anything fancy inside of the Lambda. We are not switching threads. We are not running anything that may block the JS thread. So changing the function type is quite simple and let you test different ideas and see what would work best for your application. OK, we did it. We implemented our own first module. It wasn't that scary. And the Expo Modules API has a lot to offer, but I won't be able to get into details about every DSL component, about every functionality it provides. However, I want to mention a couple of features that I found quite interesting. So we support the type arrays known from JavaScript. You can use them as an argument for a function, or you can just return them. They are very useful when you are dealing with audio or video processing. They let you easily share huge chunks of raw memory between languages. They are also optimized by JavaScript engines, so probably is the fastest way of doing things like that. And currently, they are not supported in Turbo modules. Our API also provides you ability to describe classes, which will be represented by the JavaScript prototypes. Each class can have its own methods, properties, and even events. That feature may seems quite simple, but actually it is really powerful because it allows you to create objects that exist between languages, making it like with that you can easily make object-oriented APIs. The object can also have a native state, and I have an example for you. So here you can see a player defined in Expo Video package. That player contains information about the current frame, current status of the video. It was created using a hook just to connect it with the React render pipeline. But you can use the plain constructor if you want. However, the data on the native side is quite heavy because we are basically holding a buffer there. So we want to ensure that we can release as much memory, as much resources as soon as possible. So we want to deallocate the native stuff when the component is unmounted. That's why we have that hook in our API. And everything else would work as you expected. So you can have getters, setters, and functions that will change the native state, will change how the player is behaving. And to use it, to display the video, you can pass the player object to the native view, and that's it. And all that API was defined using only DSL without any need of extra JavaScript code. So you don't have to switch between languages. You can define that fully on the native side. Now you can see a comparison between old and new API exported by the Expo image manipulator package. When creating that API, we focus on using classes as much as possible. I think the result is quite nice. We have a simple and ergonomic API. Also, after each step, you can display the preview of that image without saving it onto the disk, which is quite nice and quite fast. It's not available yet, but it will be soon, so stay tuned for that. And like classes and modules, you can also define native views. When using a traditional way of creating native view, you will often end up duplicating some part of your implementation for both for old and new architecture. And the biggest advantage when you are using Expo and Expo way of creating native views is that you can reuse the same definition. The same definition will work on both Pair and Fabric, so you don't have to change anything. You get that for free. So how can you start? Creating a new module is quite simple, because we have a command for that, like always. So you can run npx create expo module to create a new, fresh project with everything set up to be released on the npm. However, you can also use the local flag, add the local flag, because probably you have an existing project, and you just want to add some native functionality to it. That is the easiest way to actually do it in such a case. OK, so the Expo API isn't only used by the Expo team. Community members have made a bunch of awesome packages with it. Here you can see some of them. We're really happy that people start to using the API. Because of that, we were able to find, to spot and fix some bugs, and even introduce new features. So make sure to check out those packages. They are really awesome. Yeah, and that would be it for me. If you have any questions, feel free to reach out on the GitHub or on Twitter. And yeah, thank you for listening, and happy coding.
Awesome! Thank you so much. Oh gosh. All right, keep it going, y'all. We still got 2 more awesome talks. You ready? I know you are. Are you ready, live streamers? Live streamers? I don't know where to look at you, but somewhere. All righty. So we are going to hear now from another of the geeky ants who are behind all of this magic from the GeekConf. So everyone, please give a huge welcome to our next speaker, Shivraj! Woo! Yes, that's right. I hear you. I see you. Thank you. Woo, woo, woo! Who is, again, coming to us from Geeky Ants. Can we get a round of applause for Geeky Ants who have made this all possible today? Thank you, Geeky Ants, for all that you do to take care of us geeks. You know. Alrighty, so we are going to have one more talk after Shivraj is done, and then don't forget, family photo will be after the announcements that follow. So don't go anywhere. There's still plenty of geekery to ensue. Alrighty, I think we are going to be needing another round of applause for computers to summon the slides to the screen. Getting closer, come on, y'all. Yeah, see, it works, it works. All right, okay, take it away, Shivraj. Give it up one more time, y'all. Woo!
Hey, hi everyone, good evening. I'm Shivraj. I work as an engineer at Geeky Ants. And today I will be talking about TV app development with React Native. So yeah, before we begin, let me just quickly ask a question. How many of you build an application using React Native UIs? OK, not a lot. OK, anyway, let's move on. OK, so before we begin, let's just quickly have a look at what we'll be covering today. We'll discuss about some brief history of React Native for TV. We'll have a look at the current TV market. We'll also have a look in terms of why React Native could be a good choice for TV apps. And then we'll discuss about some key differences when it comes to TV app development and even mobile and web. Then we'll talk about some of the core components that are required for TV app development. We'll discuss about the navigation and interaction, how that works specifically for TV apps, and how it is different for web and mobile. And finally, we'll also discuss about some of the challenges or limitations when it comes to TV app development, and maybe some consideration in terms of how to optimize for that. Yeah, so let's get started then. OK, so TV apps, React Native's journey for a TV app has been an interesting one. It all began in 2017 when Apple TV support came in for React Native with version 0.49. The following year, in 2018, Android TV support also came in. The bigger change came in 2020 when React Native's TV support was moved out, and it was created as a React Native TOS library. Then just last year in 2023, Hermes on Apple was also introduced. Then just this year, Expo SDK kind of started supporting TV app development. So with Expo SDK now we can build for TV, web, and mobile. So yeah, throughout this time we have seen some change. I mean, not significant, but we have been seeing some changes into the TV-specific features with React Native. Now let's look at the current market, what we have for TV. So before that, if you see here, there are a lot of devices and platforms when it comes to streaming media, right? When it comes to web, we can target all those with just a single app, maybe with React. And when it comes to mobile, obviously iOS and Android covers at least 95% of the OS market. And obviously, we can cover that with React Native. But when it comes to TV, there are a lot of different platforms on OS that we have to support. Nothing like what we have for web and mobile. If you see here, some of the platform OS that we can see, Android TV, TUS, there are web-based systems like Tizen for Samsung, or even WebOS for LG, and there's Roku, and there are a lot of many more that we have to support when it comes to streaming media with TV. So why React Native? Given the fragmented market that we have for TVs, why React Native could be a good choice? These are some of the reasons why we could consider React Native for TV app development. So let's imagine a streaming app, say something like Netflix or even Hotstar. So if you have to build an application for different platform OSs, you would have to have a lot of teams, right, to support these platforms. Or even when you consider mobile and web, again, you will have different teams working on that. You will have different code base. And to sync all those, to have the same specific features or even deploy them or sync the development or the deployment together, that will be very difficult, right? So here, React Native can help. I mean, if not all, but specifically few of the OSs or platform, it can help to target those. So given that, obviously, same as what we can do with React Native for mobile, we can obviously use the code for different platforms with React Native TUS. Obviously, we can unify the development team using the same code base. And yeah, that would obviously create faster development cycle and also the deployment of it. And obviously, with the React Native experience that the developer have for mobile, we can leverage the same experience for TV development as well. So if you look at here, these are the platforms that we can target with React Native TUS. Android TV, Apple TV, WebOS for LG, Tizen for Samsung. I mean, both of these are web-based platforms, so we can target those specifically, not with React Native TVS, but we can extend React Native web to support that. And obviously Fire TV, because it's just an extension of Android TV. So now that I've looked at why React Native could be a good choice, let's look at some of the key differences of TV apps from mobile and web. So the biggest difference that we could see with TV is the user interface, right? I mean, obviously, the screen size that we have for TVs and obviously the distance through which we watch TV apps, right? So that's the biggest difference, and also the navigation, how it works. In mobile, we use something like touch. We can just see what we want to interact with, and we can just touch those elements in the mobile. And same goes for web. We can just interact with them very easily by just moving a mouse cursor and also maybe keyboard interactions. But with TV, it's completely different. We have to interact with them with TV remotes, right? So yeah, that's a couple of major differences. Obviously, the interaction that happens, so remote. There's another major difference, that's hardware limitation, which we have for TVs. This we'll talk about later in the slides. So let's look at these aspects one by one. So yeah, talking about the user interface for TV app, these are some of the major core components that we use. So the drawer component, which is majorly used for navigation. You usually see this in most of the application as the entry point where we interact with them, where we kind of navigate through different screens or different elements of the components or the TV, right? And then there's grid. This is majorly for displaying the content, majorly the layout of the content that we see as soon as we land into the application. Then obviously cards to showcase individual items, let's say the movies, the shows, or the categories itself. And these are the components that we mostly interact with or navigate through. And then there's obviously the buttons, which are for interaction and selections. And also, there could be some platform-specific components, which maybe we can use it as native components, maybe like something like video player or audio player. So yeah, most of these components are basically UI components, right? So we can use libraries like GlueStack UI, Atomic UI, to create these components. I mean, obviously, these libraries are universal and are very responsive as well. And obviously, this comes with a lot of customizability, right? So we can use these libraries or something like other libraries similar to these to target the UI components for TV app. And obviously, we can create our own components and use it for TV apps. Now, let's look at how navigation and interaction works in TV apps. So if you look at here, majorly the navigation and interaction in TV apps are handled by, obviously, the user inputs, which happens to be by remote controls. And there's app navigation, which I already mentioned, like it's like through the content that we see in the main screen, right? It could be horizontal, vertical, through the remote controls. We just click on left, right, up, down, right? We just navigate through that. And the major function that happens there is focus management, which is very crucial for TV, a good TV experience, and very tricky to handle as well with when it comes to TV. Let's deep dive into each of these aspects to have a look in terms of how these works. So in TV primarily, obviously it relies on remote controls where we click on those buttons, click on those buttons to interact with each element. Obviously, when it comes to mobile, we can just see each element and just click on those elements by tapping on it, and we can interact with those components or navigate through different screens. And when it comes to web, we can just move our mouse cursor and click on it as you visually see those components as well, right? But when it comes to TV, we have to kind of click on the remote controls. We are not sure whether it is moving in which direction in terms of, like, visually we can't understand where it is going, right? So that has to be handled. So that is handled with TV event handler component. And if you see the code here, so depending on the event, like left, right, up, down, even play and pause, the TV event handler component listens to the event that is happening through the remote and handles it depending on how we want to. The back handler component of the API that we had for Android earlier, right? The hardware button. That same API also works with Android TV and Apple TV to handle the same thing for back, with the menu button or the back button as well. Next, we'll talk about app navigation. So for TV apps, we often see, grid view, which are two-dimensional. As I mentioned, we just can move into multiple direction where up and down or left, right. So that is something called spatial navigation. So usually, this is the layout that we see in the TV apps, something like, the interaction that happens through the remote control in both the direction, and we interact with those components. If you look at here, this is majorly the layout that we see in most of the applications. Depending on the remote control inputs from the user, we navigate between those items in the screens, right, in different direction. So if you closely look in this video, the elements that are selected are also focused, right? And if you see on the left of the screen, you see a drawer, which I mentioned earlier is one of the core components as well. So if you see on click of those elements on the drawer as well, the grid or the content that we see on the middle of the screen are also changing, right? And if you see the content as well, depending on the focus or the selection of it, the top element that we see is again also changing, right? So that's where, we usually see the player or the banner of something we want to kind of select as, right? So that's majorly the place where we put in our banners or players, all those things. So if you see here, I mean, we are able to see the focus on the elements or visualize that, OK, this is the element that has been selected. So how is this handled? So this is handled by something called focus management. OK, so this is very critical, as I mentioned, and it is very tricky to handle as well. So if you see in this video, as we interact with the remote, on the right of the screen, if you see, like, on click of, on tap of the buttons on the remote, like left, right, the movement of the focus is also moving, right? It does not matter whether the element is directly adjacent to it or it's on the same layout as a same column or the same row. We are able to interact with each element on the screen depending on how it is structured, whether it is adjacent or not. And that's majorly handled by TV Focus Guide V component, which is provided by React Native tvOS API. Okay, so this is how it works. So essentially, it's an invisible view which we can place just to interact with elements which may not be adjacent to each other. It can be used as well as when you want to skip an element as well, right? So it acts as a component where we could focus on that depending on how the adjacent elements or how the placement of the components are there. It is very tricky. I mean, the focus management is very tricky to handle in TV applications. And yeah, so TV Focus Guide V is a very powerful tool to achieving focus management in TV apps. Next aspect that we'll be considering, as I mentioned, is hardware. So, I mean, we are in the era where mobiles and laptops have 16 GB, 32 GB of RAM. And these are very common nowadays, right? But with TVs, the RAM has always been low for a long time now. And we always see the processors that we are using for TVs are also older. And that's the biggest limitation that we have with TV apps. And also, considering these things, we still have to optimize for the TV apps so that the experience is smoother. I mean, obviously, people want to watch content, not just interact with the TV, with the elements that we see, right? The performance has to be better. So yeah, that are some of the limitations. And obviously, there could be some platform-specific limitation as well, right? With React Native, as I mentioned earlier, we can just support few of those platforms. We cannot target all the platforms. So there's, again, a limitation with React Native. Obviously, we can build with platform-specific code base. But yeah, React Native has that limitation that we can just support few of those. So yeah, that covers most of the aspect that we wanted to consider building for TV apps. Now, look at some challenges that we might face when developing TV app with React Native. So yeah, as I mentioned, handling focus management across platform is very challenging. Obviously, we have different guidelines for maybe Android TV or Apple TV. And there's, again, different guidelines for web-based application as well. So dealing with that and handling focus management consistently throughout different platforms is a very, challenging part. Then again, different platform-specific guidelines, as I mentioned, could be tricky as well. Handling the layout differently, maybe depending on the guidelines for different OS of different platforms is again challenging. So yeah, and as I mentioned, working with the hardware limitation and optimizing for that is a bigger challenge. Then there's a limited capability when handling background tasks with React Native itself, and with React Native OS, that remains the same. I mean, we have some limitation there as well. So yeah, now that we have talked about some of the limitations and also some of the challenges when we're building TV apps with React Native tvOS, let's look into some of the consideration in terms of how we can optimize for that or how we can optimize for some performance when we are building for TV apps. So one of, great library that we can use, which majorly focuses on navigation, focus management for key smooth experience with React Native tvOS is TV space navigation. I mean, this library tackles focus management and navigation very smoothly and across multiple different platforms. And yeah, if you see here in the video, I mean, the elements that we're interacting with, it has some kind of animation as well, and it is being handled very smoothly. So the most crucial part of the application, which is navigation and focus management, and again, when it comes to navigation with animation, is being handled with this library, and it is very smooth. And this library also comes with few components of the APIs which handles list data as well. So there's something called spatial navigation virtualized list, and there are a couple of more depending on the layout that you want to build for TV app. So this handles rendering large data very smoothly, and it automatically handles focus management as well. So although, I mean, flat list is there, which works fine, but you all know, I mean, with flat list, there could be some limitation where we're handling large data. So yeah, having these APIs, which handles the data very smoothly and able to render the large data very smoothly, is something that can help. And if you see the matrix here, I mean, it outperforms the flat list anyway. So yeah, that's good to have. And if you look at the example code, the syntax that it has is very similar to flat list. So you don't have to worry about, learning a different component altogether. And just to mention, flash list also works. So yeah, we can give that a try, but yeah, that's something to mention. So yeah, I mean, considering all the limitations and even the hardware limitations, we have to optimize for TV app when we are building with React Native TV OS. I mean, we will have to consider something like memory usage, CPU usage, or even the load time when it comes to building the TV app, right? Obviously, that's majorly because of the limitation that we have with the hardware. But yeah, we'll have to consider that. Either we are creating with React Native or any language, platform-specific language as well, but we have to consider that. And I mean, with the recent React Native new architecture and the support with suspense, concurrent mode, all these helps in terms of optimizing the performance for building TV apps, giving a smoother experience to the user when creating an application for TV. And obviously, I mean, not just that, we can obviously consider to build few of the stuff on the native layer as well. That's always handy. Something like video player, I mean, that could be very specific, but it can be handled differently for different platforms. Yeah, so before I wrap up, I have a, quick demo. Yeah, let me just play that. I mean, I just created this in a couple of hours. I didn't handle the optimization part, so yeah. I mean, if you see here, the optimization part is not working well because the video is, kind of laggy in terms of when it shows up. So that is something that we can work on. Yeah, before I wrap up, a few things to mention. We recently had, as I mentioned, Expo SDK supports TV app development now, so we can use the same code base for mobile, web, and TV. Now with the Expo SDK 51, Expo Router is also supported for TV app development. Then we have a boilerplate code from Ignite as well, which works. We can use that to bootstrap our project for TV app development. Then React Native IAP, which is for in-app purchase, that also works with React Native TVS so that we can target for Apple TV or Android TV and even Amazon Store for building an app. And yeah, for testing, we can obviously use APM, which works perfectly fine with React Native TVS as well. And yeah, we are seeing, not completely fast growth, but we are seeing some kind of growth in terms of the React Native TVS space. So yeah, recently we have seen some development over there, so we could expect a lot of resources and talks over that that could be coming in. Yeah. So yeah, thank you, everyone. Have a good evening.
Everybody, one more time for our second to last, penultimate, if you will, speaker, Shivraj. And now we are about to come to our final talk of the day. I know, it's very sad. However, again, the day will not be totally over after this talk, so stick around. We are going to have some announcements from the organizers and also some details about some after-conference festivities that we can participate in should we so choose. So make sure to stick around after this last talk, and don't forget, we're going to do a family photo after the announcements. So we will meet all on the by the pillars on the entrance to the venue, and we will take a photo proving that we were here, because pics or it didn't happen. Am I right? You know? So now we are ready to go with our last, but certainly not least, talk of the day. Everyone, give your loudest, cheeriest welcome ever to Mo from Theodo! Woo!
Thank you very much. Can you all hear me? Amazing. So before I came on stage, someone from the crew pointed out two things to me that I want to share with you. Firstly, I'm the last person speaking, so apparently I have a very difficult job ahead of me. And secondly is that if I put one of the other mics on, apparently my beard would make a lot of noise and you guys would all be going deaf, so I'm going to have to hold this, so we'll see how this goes. Lovely to be in Berlin. Thank you, everyone, for everything. Big shout out to Sanket, his team, the crew, the volunteers. Give them a round of applause for everything they've organized. It's their first year. By the way, random thing, did you know this building used to be a church? It's really cool. It's my first time giving a talk at a church, so I feel like I should be giving like a sermon or something, not a talk about front-end development. But hey-ho. It's the last talk of the day. I'm going to say some stupid shit, so buckle in. It's the only way I can keep you guys awake. Awesome. So we're going to talk about how front-end is going to change in the next 5 to 10 years. And hopefully, things will go well. Several times during the day today, we heard about write once, run anywhere. You've already heard this a couple times. It's the ultimate goal of front-end developers and UI engineers. Could we develop an app from a single code base that could run on any platform that we wanted to? And it turns out it's nothing new. If we go back to the late 1990s, and you come home after a long day of work, and you sit down on the couch, turn on your TV, you might see an ad like this playing.
Who would have predicted that Java could change the way we view the world and the way we live? It entertains, it communicates, it transacts, it speeds across the ground, soars through the air, seeks out new frontiers. Anywhere and everywhere, Java is there.
And just like that, write once, run anywhere, and Java everywhere became the mantra of Java. Suddenly you could use Java as this magical technology to target web, phones, and your desktop devices. Great, right? Definitely how that stayed. Fast forward a decade into the late 2000s, and it's the age of Flash. Great time, right? Raise of hands, is there anyone here who hasn't experienced the web in the age of Flash? You lucky buggers. Honestly. And so congratulations to you, Anisha, and to the other person who raised their hand, and to the rest of all of us, condolences, because it was a shit time. So late 2000s, early 2010s, Flash was everywhere. It worked on Windows, Mac, Linux, and the web, and then all of these other platforms as well. They were supporting the mobile platforms of that age. Android, BlackBerry, Palm, Windows Phone, Symbian. Great time. And they were trying to take this write once, run anywhere approach and move it to more and more platforms. They were targeting PlayStations, the Wii, Xbox, so on and so forth. So you saw that they were going through this expansion. And they had a whole ecosystem of partners around them. They really felt like the contender that was going to solve write once, run anywhere. Now, both of these technologies at their respective times were actually at the forefront of app development. They promised to let developers write once and run anywhere. But they ultimately ended up failing, and write once, run anywhere became a joke of the dev community, and it changed to write once and debug everywhere. Not a great look. And both of these technologies declined over time. So if you look at Google Trends and compare Java and Flash, you'll see from 2011 to 2024, they've both declined relatively, and Java is including Kotlin within that umbrella term. So this is taking into account that a lot of people in the Android development or in other places have moved from Java to Kotlin, and with that in mind, it's still declined significantly. And then sometime in 2015-ish, some new technology came into fruition, and suddenly it's been climbing up the ranks. And it's promising something very similar. Write once and run anywhere? So is this one going to be true? Is this one going to work out? Or are we just chasing the same pipe dream as our predecessors? My name is Mo. That was the longest introduction I've ever done to a talk. So I work at Theodo. I work very closely with Charlotte, who just did a talk a couple slots before me. I head the mobile team in the UK. And what that means is I do a lot of research into what the next trends are in mobile development, app development in general. I organize the React Native London meetup, which is probably one of the funnest things I do in my job. And I also maintain the React Native TV blog. That's like a knowledge base of React Native TV information. And so a lot of what I do with mobile has to do with universal apps. And recently I was giving a talk at a meetup, and I mentioned write once, run anywhere. And in the QA section, an older gentleman who definitely has a much longer career than I have looked at me and basically asked this question. He said, I've been hearing the promise of write once, run anywhere since the 90s. It was the promise of Java and Flash, and they both failed. Didn't work. So, young engineer who's giving a talk today, what makes you think React Native will succeed? In a very patronizing tone, he said that to me. But his question was very valid. And it links back to the architecture of how we're trying to target cross-platform applications. So if we look at Java, the way that a Java front-end application would typically work is you would have Java source code that goes through a compiler. That compiler compiles out to bytecode that needs to be run on the JVM. So you have a custom runtime that sits on top of the OS that's interpreting and running your bytecode. And so your bytecode is not being run by the operating system, but it's actually being run by the JVM. So there's that level of abstraction, and it means that it's not actually truly running natively. Similarly, we have Flash. So Flash was ActionScript source code. It goes through a compiler, and then it comes out as a file that needs to be run in the Flash runtime. It's, again, a custom runtime. It's not native, so it means that you can tell that it's not running on the native device. And if it needs to interact with the OS, it'll connect. But by and large, your app is running in this custom runtime. The best comparison I can draw is that it's kind of like a really good Bob Ross painting. Like if you just like stare at it straight from like a direct angle, maybe what you'll see is it'll look like a real picture that someone's taken. But the moment that you kind of step a little bit and look at it from a different angle, you're like, ah, that is a fake canvas. No dig here at any other cross-platform technologies. So it looks a lot like the real thing. It looks a lot like native applications, but it's not really native. So that leaves the question, what about React Native? And React Native is a bit different. It's subtle, but that difference makes a difference. And the way that it works is you've got React code. It goes through a bundler and a build process. And basically that build process is the native build process for each of these operating systems. So your native app is truly native code that's being added with a layer of JavaScript that orchestrates some of the native functionality under the hood. It's a very gross oversimplification, but bear with me here. And then for iOS and Android, it has individual native app bundles that run. So what that really means is that when you have a view in React Native, under the hood in Android, it becomes an Android.view, which is the native view component. And on iOS, it becomes a UI view. It's a common API that uses native components under the hood for each of these platforms. And the best quote that I could say for this is React Native is native. And that's by Taz, a good friend of mine. I need to stress this again. It's a common API with native components. So when you've got an app like this is straight from the docs. The views are Swift views, or sorry, Objective-C views. Image views are the same, and so on and so forth. All of these components will be native layer components. They're not some web view, which is surprising how many times people think that they're web views. So it's a subtle distinction, but it's incredibly important. And the key to success is the right abstraction when it comes to building these solutions. Now, as we saw with Java and Flash, these technologies come in waves, right? Nothing is permanent. And these waves only last for a certain period of time. So I think it's a good time for us to take a look at some of the eras of front end from 1995 all the way up to 2025. So going a little bit into the future. If we draw out our nifty timeline, from 1995 to 2005, we had the desktop first era. So this was the time when Windows was predominant as an OS. Nobody really used Mac OS back then. It was very rare. If you wanted to write a document, you would need to buy a copy of Word, take a CD, put it into your computer, install Word, install PowerPoint, install Excel, and the icons looked all glossy like that back in the Vista days. If you wanted to shoot messages to your friends, you'd have to use Yahoo Messenger. Did anyone here use Yahoo Messenger? Of course. Yes. It was a good time, wasn't it? And then you needed to have these clients for emails that were running on the desktop as desktop client applications. Some point between 2005 and 2015, Chrome really popped off, and everyone started adopting Chrome, and the web just became more and more powerful. And we transitioned to the web first era, where suddenly a lot of the things that you would need client applications for, you could just do with the power of the web, and my screen is flickering. That's not a good sign. Okay, fingers crossed. And so you could use Google Drive instead of having to download a client app. It was just all web-based. Facebook came in, so you had a web platform for social interactions with your friends, and you could poke them. Jeez, that's concerning. This is not a good omen, is it? There we go. Woo. Thank you. Ah. This is going splendidly. All right, let me see what I've... Should I disconnect and reconnect it? Let's try. That's good. Can you see my screen again? Oh. That's great. Do you want to connect this HDMI directly into my machine? Yes. Okay. Fingers crossed. Apologies for that. And then you didn't need mail clients anymore. You just had Gmail on the web, and you could just use that. And then we transitioned more recently into the mobile first era. So this was the era of the app stores. It's when WhatsApp, using messengers as your default form of communication, became normal. Side note, I really like making phone calls. Like, I just pick up the phone, call people randomly. And I'm weird like that. Like, phone is great. You don't need WhatsApp. You always have connection. There's no internet issues. Usually it's quite reliable. And without fail, when I call someone these days, they hang up the phone and then they WhatsApp me saying, "Why are you calling me?" Like, I'm trying to speak to you? I think we've just all associated collectively phone calls with our great aunts who we've been ignoring for 6 months and don't want to pick up their phone call. I don't know, like, there's something there. We've changed, our wiring has changed in the mobile first era. Streaming music became a thing instead of owning music. You know, social networks like Instagram popped up. You've got, you know, news on your phone. There's an app for it. Ordering a taxi is an app now. Like 20 years ago, if you told someone, they'd look at you and think you're crazy or something, but this is the reality we're living in. So this has been the case for the last 10-ish years that we've been in this mobile first phase. But I think it's time to address the elephant in the room, which is that the mobile-first era is over, empirically. And I realize this is probably a very unpopular thing to say to a group of React Native developers, like, risky. But hear me out here. Technologies typically follow this S-curve. So they start off really strong and they have this exponential growth, and then they tread off and slow down. And you can see this with mobile phones and smartphone usage in general quite significantly. If you look at a graph of global smartphone users, that is pretty much like for like an S-curve. This is something I really like. So in the last 30 years, it shows the increase in the population, the adult population around the world, PC users and mobile users. So take a look at that. You know, slow growth in the 80s and the 90s, PC usage is going up, and then some point in the late 90s, you get a lot of mobile users. But in 2007, 2008, it just exponentially explodes, and suddenly everyone has a mobile phone. The vast majority of the public have now got smartphones. It's been adopted. It's a technology that's mature now. And one more graph to prove it to y'all. If you see here, 4 different technologies. One in the 20s was radio. It reached 100% of the population had access to radio by the 40s and the 50s. Same thing with TV, just a much faster growth. Internet was the same, but happening in the 90s. And mobile, this has been happening recently, and you can pretty much see it's starting to reach that asymptote as well. And also the same thing when you look at engineering jobs. Mobile demand has, oh God. This is what I get for saying this stuff at a mobile conference. Cool. Mobile jobs have just declined. This is the first 4 months compared to 2023. So the mobile first era is just categorically over. Maybe it's the age of AI and agents? I sure as hell hope not, because that's not going to be fun. Is it perhaps the end of front end? No, that doesn't seem right. Not quite. You see, there is light at the end of the tunnel, and I genuinely saw some people leaving this crowd, so I have lost people that like me now. Great. I think we're just evolving. So what we need to be asking is, what is this next era of front end going to look like? And the best way to answer this question is to understand how the best applications that we have out there that we interact with are influencing and changing and adding new behaviors and functionalities that users start to seem to expect. So I'm going to kind of tell this with a story. So when I wake up in the morning, I usually spend quite an obscene amount of time scrolling in bed. And it's not on TikTok or Instagram or anything like that, as you might expect. I'm incredibly boring. I scroll through my emails in bed. It's really quite sad. And then one of the things that we see on the OS level is when you want to use that or pick up that session and use it on your Mac, there's automatically an icon there to hand off that experience. So the session, the state, everything is passed to your desktop automatically, and you don't even have to think about it. So you click that, and you open up the email on your mail client on your laptop with minimal effort. It's all automated now. It's not just on the OS level. This happens on applications as well. So if you look at something like Google Maps, if you search for a location on the web, and then you get into your car, and you want to go to that same location, it's already pre-filled for you. This is very subtle, right? You might think, oh, this is not a big deal. But actually, when you don't have this in your app, your users notice it, because their whole experience across all these other apps has been straightforward without needing to think about syncing between their different devices. And then if yours doesn't do it, suddenly they're like, wait, I need to send this location via WhatsApp and then open it up, copy it, and put it inside of this app from the desktop. It's too much. People just expect this by default. It's now the status quo. And it's not just between desktop or web and mobile. You see it with all of these different devices around you. So if you've got a talk that you're watching on your commute back home, and you get into your living room, you don't want to watch it on your phone anymore. So very easy for you to hit a cast button. And when you click on that cast button, it's automatically put up onto the TV, and you pick off where you left off without you even having to click any buttons on your TV remote. Like, it's reached that stage where everything is interconnected. And it's not just TVs. You've suddenly got YouTube has got an app on a smartwatch. They have to support CarPlay. And then it gets even weirder form factors. Like, you've got these like tablets that kind of sit in the kitchen. They're kind of tablets. They're kind of not tablets. The interactions are a little different. Fridges. For God's sake, who thought we should add Android to a flippin' fridge? Like, it's ridiculous. But it's just like you're getting these digital smart home experiences being added on everywhere. And a lot of apps will start supporting them, and your users will start expecting you to be also supporting them. And then suddenly you're in this sort of hell of supporting 7 different platforms. And then there's the more popular ones that are emerging. Everyone's seen this, right? So the Vision Pro changes UI quite significantly. So when you put on a Vision Pro, everything looks different compared to what you're used to on your phone or your laptop. You've got these translucent environments and UIs and little surfaces, and you got 3D objects. But then the crazier part is that when you're using your MacBook or your phone in the Vision Pro, it's all interconnected. So you can see your screen of your MacBook from your Vision Pro. Like, it's all of these different interconnected, seamless handoffs between the Vision Pro and the Mac and the phone and so on and so forth. So you're getting all of these experiences becoming interconnected more and more. And it's not just Vision OS. There's Meta's Horizon OS as well. So that's one of the things that's happening. You're seeing all of these different form factors come through. And there is one more thing that's been popularized in the news lately. It is the shit show that is Gen AI. And this has already been mentioned in a talk before mine, which kind of makes me feel a bit more confident saying this now. When you look at Gen AI apps, they almost always seem to have the same interface. A bland chatbot. Like, I don't know about you folks, but whenever I go on a website and need customer support help and I see a chatbot there, I run away. I never want to use a chatbot willingly. And for some reason, we've decided that chatbots are the way to go forward. So will the next age of front-end be chatbots? I sure as hell hope not. And I don't think it's going in that direction. And this is basically going over Tejas' talk, so I'll just go through it very quickly. But if you look, there are some really good examples of how people are actually integrating AI. So this is the new Windows, and they're actually adding small AI features that are rather interesting in some ways, but some of them are smart. They're augmenting your experience rather than just throwing a chatbot in your face. It lets you add creativity and augments the experience of you creating paintings or writing text and so on and so forth without it being this big chatbot that you have. Things like live captions. It's not that the AI is the experience, it's that it's augmenting your pre-existing experiences all on the native layer. You see the same trend with the new Mac OS update. You can see that there is this AI that's integrated natively into the operating system, and all third-party apps can start using them from day one if you have a native app. If you want to shorten text that you've written inside of your app, it's already there in the AI. If you want to transcript audio that's coming in from voice calls and so on and so forth, it's already there. And you also get accessibility stuff. This is really important. If you have a native app on iOS or on Mac OS now, there's accessibility tools baked in because all of this is native code that the OS can understand, and it can liaise back with the AI that's there to help people that need that from an accessibility perspective. Like, these are all good movements and good uses of AI that I think are phenomenal. So if you look at all of these experiences that we've just talked about and you put them together, the next era of front end has seamless handoff between all your different devices that you use throughout the day. There's a lot more form factors of devices coming out. There's AR, VR, and there's AI. So we're going towards an era with increasing fragmentation and new form factors coming out. One where AI is going to be deeply integrated, but basically augmenting the UX as opposed to becoming the thing that people use. Where people have, a single user may have multiple devices that they switch on throughout the day, and where users expect universal seamless experiences. Universal seamless experiences, that's the key here. I think that's the common trend that you see, that those experiences are not limited to a single device. They're going across multiple devices that they use throughout the day. Ultimately, we're going into the universal first era. So then the question arises, well, what technology should we use for this universal first era? What's the best technology to create these universal experiences? Is it Flutter? Well, Flutter doesn't use native runtimes. It's very similar to how Java and Flash works. It's got a canvas, whether that's in Skia or Impeller. It doesn't support 3D and spatial computing, so AR and VR are just out of the picture. And it has really poor web support because it renders everything on a DOM. It renders everything on a canvas as opposed to the DOM. So definitely not Flutter. Let's burn it and burn it with fire. I have wanted to do that for a long time. Maybe it's Kotlin multi-platform and Compose multi-platform. The issue, again, lies with Google, thinking that they can do everything better by just popping it into a canvas. So they use canvas-based rendering for both web and iOS. So not native. Poor SDK compatibility. So if you ever try to use KMP with Swift, you'll know that sometimes it does really poor job, and you have to do a lot of manual work to make sure your libraries work. And again, poor web support. So not that either. Maybe we all just become native developers. But again, that's expensive. It's slow. People usually can't afford that anymore because it's costly and the economy is in shambles. And that seamless handoff actually becomes really difficult when you've got a bunch of native teams to coordinate, and we're adding more and more and more devices. So it's only going to get worse. So native is no longer an option. And so ultimately, we're really just left with one technology. I may be a little biased here. Whoever that one person is who's doing all of the, you're amazing. Love you. Okay. So React Native, we know, is a platform-agnostic API to define UI that maps to the native layers. And so you have truly native experiences. Yes, it started from mobile experiences, but you can now target desktop, you can target web, and you can even target TV, as you saw. I'm doing a recap of all the talks at this point. Vision OS, native support for Vision OS. No other cross-platform technology has gotten this. Tools like Expo Router already have solved handoff between all of the different platforms because, again, you're dealing on the native layer. So you can have seamless handoff of the state of the user by just natively integrating it into the OS. It's all already there and baked in, and we've made all the right steps there. When it comes to AI, Copilot, which Microsoft released, is built in React Native. So there's a lot of React Native-based AI applications. And we can even go a step further, because if you've seen the recent talk that Evan Bacon did with a demo of RSCs, it actually works perfectly well for generative UI, as we saw with Tejas' talk today, because it knows how to render native layer components inside of an AI-based application. So you can basically render context menus and native alerts and timers and all of that and hook that into the native layer. Whereas if you look at the existing apps that are already there, like ChatGPT, Gemini, or even Claude, none of them have this functionality because it's just not something that's really possible and feasible and scalable with any other technology. And then, of course, when you look at AI, you've got to also address the elephant in the room, which is like we're going to all be using AI to code as well. And if you look at the top languages on GitHub in 2023, JavaScript and TypeScript are at the top of the list. Kotlin and Dart are very low. You don't see Swift or Objective-C anywhere. So there's far more training data on JavaScript, TypeScript, and React effectively to train LLMs on and effectively have better Gen AI to generate code for you. Do I need to say more? It's backed by big tech, and it's being used on the App Store. So it's already a very stable technology. It's not going anywhere. And it ticks all of the boxes we've talked about. It handles seamless handoff. It works on smart devices. AR, VR is already being worked on and is pretty decently supported. I mean, there's still work, but it's as far ahead as any of these cross-platform technologies can be. And AI support is something that is only going to get better, and I think it's the technology to build AI-based applications with. So then have we hit the holy grail? And the pun is very much intended being inside of a church. Is write once, run anywhere finally a reality? There's still a little bit to go. We're very close, but there's a few things that we need to work on as an ecosystem and as a community to get there. So the first thing is React Native works incredibly well on iOS and Android, but the moment that you step out of those platforms, you're now in out-of-tree territory. And parity with the core React Native in that situation is not great. So big shout out to the Microsoft team who've been maintaining React Native Windows and React Native macOS. Is probably one of the best out-of-tree platforms in terms of maintenance. And even then, when you look here, they have over 160 open issues on places where there isn't API parity with the core of React Native. And this is one of the better ones. So it's a real challenge to keep up to par with core on React Native. Let's look at another platform, tvOS. tvOS has developed a whole bunch of different APIs that have not been standardized, are not on par with React Native Core, to handle things like remotes and focus management. You can use track focus, autofocus props. Then there's a whole bunch of components you can use. There's an imperative API that you can use that just fundamentally goes against anything that React stands for. Like, you can do that. There's now a TV focus guide. And so there's about 6 different ways to do the exact same thing when you're using TV navigation, because there's been no standardization around this. And the kicker here is that none of this works on web-based TV operating systems. So you'd need another solution for any platform that isn't Android TV or tvOS. So that's the state of where we're looking at when we're at out of platform. And I have a hypothesis as to why this is. And if you open up the APIs for React Native Core, so this is from the reactnative.dev webpage, and you look at any of these components, let's say Pressable, and you scroll down, you'll find props that are a bit odd. Props like these two. Android underscore disable sound. Android underscore ripple. Okay, maybe it's a fluke, maybe it's just Pressable. Let's look at text. We have 2 different props that effectively are doing very, very similar things. Text break strategy, that only works on Android. Line break strategy iOS, only works on iOS. And the issue, I think, is that React Native is actually currently tightly coupled to iOS and Android. It makes them first-class citizens and inherits some of the mobile native APIs and basically creates the API design around them, which is not a scalable way to do this, because React Native should be a platform-agnostic API to define UIs. It shouldn't be tied to any platform, mobile, web, or so on and so forth. So maybe it's time for a cleanup, perhaps Lean Core v2.0. Now, when we look at some other platforms like web, there is really good effort towards bringing the web APIs closer to native. And this is really important, and the Microsoft team has been working really hard on this. The key factor here is that web APIs are incredibly mature. There's a lot of React libraries that already support web APIs. So if you support web APIs in React Native, you can inherit a lot more from the web ecosystem and use it in native applications, which is honestly the direction that we should be going towards. So big kudos to them for doing this. And React Strict DOM as well is another element of making web support more first class. Right now, if anyone's used React Native Web in production, show of hands, has anyone used React Native Web on production apps? 1, 2, 3, handful of people basically. You'll know that there will be serious bundle size issues with React Native Web, and it'll slow down performance comparatively to not using React Native on web and just using bare React. And I think the key is that React Native Web has actually become a really bloated dependency that pulls in a lot of stuff that you oftentimes don't want. Like Animated is a JavaScript-based animation runtime. You want to probably use CSS for that when you're dealing with the web. And so React Strict DOM is almost the right direction to go because it reduces the bundle size footprints, but it also uses the web where it makes sense to use it for the web. Again, looking a little bit into more detail on the website, CJS versus ESM, just a quick reminder for anyone who's not familiar. CJS imports and exports come from nodes. Back in the day, they look something like that. On the right-hand side, you've got ESM. One of the key benefits of using the import syntax from ESM is that you get access to things like tree shaking, which is really important when you're dealing with the web, and bundle size is incredibly important for you as a core web vital. Unfortunately, React Native, and this is a personal opinion, is far behind other frameworks in this JavaScript ecosystem in terms of adopting ESM and getting rid of CJS. And you see that when you're trying to use React Native on the web. So there's many libraries that are just CJS, like AWS SDK is one of them. It adds a whole bunch of bloat into your bundle, and a lot of that is not even shown here. They're unmapped. So it's all just a single CJS export. But then it's not just the CJS only libraries. There's ESM libraries that get referenced by CJS libraries, and then all of those libraries also get fully imported in, so you've lost all hope for tree shaking in the React Native ecosystem, which means your bundles are massive if you import the wrong library into the web bundle. And so Expo's been doing the work of God with this. I really like Expo Atlas because it basically tries to address this problem. React Native's never cared about bundle size because we've had Hermes, our startup times have been fine, it's never been a factor for us. This, I think, is a step in the right direction for this type of thing. And then on just third-party libraries quickly, if you look at something like Expo, it's probably one of the best set of libraries in terms of supporting web as well and supporting some out-of-tree platforms. But even then, it's incredibly inconsistent. It mainly supports iOS and Android, but some libraries will support web, some will support tvOS, some will support, other out-of-tree platforms, basically. So I think this goes back to that whole factor around React Native not having a complete API surface. If you look at Microsoft's RFC, they say that we have a wild west of community modules right now. Each of these have their own behaviors, and ultimately it means that it's the developer's responsibility to figure out what libraries to use. And when you're trying to create a universal app, what that means is you'll need one library for the web implementation, one library for iOS and Android, and then if you have any other out-of-tree platforms, you may need to find another library. It's not scalable because it's on the developer's responsibility to do that. Now, on the bright side, we have some really good UI libraries that we can use universally. So Tamagui, GlueStack, Native Wind, these are all amazing efforts to make it easier to share UI across native and web. And the handoff issue is being worked on because of the Expo folks and Expo Router, so all good. It wouldn't be a React Native talk without a final mention of the new architecture. It's coming soon. One of the things that the new architecture is promising, which will make it much easier to create universal first apps, is that you have turbo modules as a new concept, and you can use C++ code that is shared across all of these different platforms natively. And sometimes it'll be a little bit of C++ code, sometimes you'll have a bit more C++ code, or you may have mostly C++ code, or even all C++ code. And when you have C++ code, all of your out-of-tree platforms can use the same native level code, and you don't have to duplicate iOS-specific, Android-specific, and so on and so forth in terms of the platforms that you have. So ultimately, what that means is that you can share a lot of code across different platforms, and library maintainers can have a lot more flexibility to adopt out-of-tree platforms. Okay, I'm out of time, and I've talked about a lot. A lot is changing in this ecosystem. If there's one thing I'd like for everyone to take away from this talk, and effectively from all of GeekConf, it's been this notion that React Native is not only a mobile platform. We need to shed this notion that it can only be used to create cross-platform mobile apps, because ultimately we're only hurting ourselves. There's so much more potential to this technology. React Native is a desktop framework. It's a web framework. You can use it for TV, AR, VR, and yes, you can also use it for mobile. Ultimately, React Native is a universal language for defining UIs. And if all of these different efforts come together and we put all of these as a forefront in our ecosystem, they're all individual puzzle pieces. And if the stars align perfectly and all of these puzzle pieces are completed and put together, React Native will power the next age of front-end, because it'll become the clear contender for building the experiences that we're all going to be expecting in the next 5 to 10 years. So it's really the front runner to solve all of these problems. And I really do think this will become a reality. And my personal belief is that the future of React Native and the brightest days of React Native's futures are ahead of it. So the future of React Native is incredibly bright. Thank you very much.
Yes! Keep it going, y'all, for Mo! Bringing it home! Our last talk of the day, but absolutely not the least. Look at that bright future. Amazing job. Thanks so much. Hoo-wee! How we doing, y'all? Yeah! It has been quite a day, am I right? You all have been the best audience. I say as an MC and also as a speaker at other conferences, it matters so much to have that engagement, that energy. You all have been showing it all day despite the long, wait for coffee and things like that. So please give it up for the best audience. Woohoo! That's right. Clap for yourself. Clap for yourself. That's right. Little pat. Good job. Okay, now we have done it. We have successfully made history. The GeekConf #1 is a go. Woo! We did it. Yeah! And so now to tell us a little bit more about the conference and to wrap things up, please join me one more time in welcoming the mastermind behind it all, Sanket!
I wish I had the energy what Anjana has. I love it. I mean, she did an amazing job throughout the day, from the first talk to the last one. And I'll quickly talk about the idea behind the GeekConf. So while I was coming backstage, I met somebody near the entrance. And this guy came and called me, "Hey, Sanket, do you remember me?" I was like, "I'm sorry?" Then he was like, "We met in 2017, almost 7 years back in Bangalore, in the first ever AngularJS meetup at Geeky Ants." I was like, "Okay, I'm meeting all the old friends." And this is where it all goes back to. We have been doing open source. And in fact, like, I started my journey as a freelancer, started working and building things for our customers. And when we started putting things out in the open source world, we realized the power of what incredible community that we can build. And soon after doing some open source, we started doing some meetups in our little office in Bangalore. And we used to see like 20 people, 25 people, but very close-knit group of people who used to like show up at our meetups and talk about different ideas, different projects that they were building. And it soon like grew into a big community in Bangalore. And that's when we thought, okay, we should do something beyond just meetups. And we came up with the idea of the GeekConf. And we have almost like 8,000 members in the React Native meetup group in Bangalore. And the React meetup group where we usually collaborate with in Bangalore, they have like 15,000 plus members. And then we started thinking about, okay, probably we should do a conference. And it would have been much easier to do it in Bangalore because we have the whole community, but we wanted to explore more. And after talking to our friends from different companies in Europe, we realized that it's a good place to run a React Native conference. Looking at Software Mansion's AppJS conference, for example, the first ever international conference that I was invited to was React Native EU, run by Callstack. And then another one in Portland, where I was invited as one of the panelists, Chain React. And we realized, okay, Berlin could be a nice place. And we were involved with the React Native meetup group here. And we thought, okay, let's do it. So here we are. We have successfully, we are done with the first ever the GeekConf, and we are super excited for it. Thank you so much for being a part of it, everyone. Yeah. Can we have a round of applause? Yeah. Great. And another reason why Berlin was because we had like close friends here who we knew could pull it off. And the people behind this conference, definitely the people of Geekabyte, Sahil, Manjula, and the entire crew team. From the Geekian side, Prem was on his knees all the time. So thank you so much, Prem. Yeah. Prem has worked all like the past 2 months. I think he has not slept, much like the Geekabyte team as well. Ashwati and the team back in India. If you are looking at the social media posts, they are actively watching the stream and asking us for pictures and posting it on different platforms. Coming to the most important members of this conference, definitely all the speakers. Thank you so much for believing that we can pull it off. All the volunteers who helped us today, right from, you could have seen people running around the conference and trying to fix the AV and whatnot. So all the volunteers, thank you so much for making this possible. And the AV team who are like trying their best to stream stuff and make sure that we stay in the camera angle. Am I there? Yeah. Thank you so much to the AV team. Yeah. And yes, all the sponsors, apart from Geeky Ants, right from all the companies, BAM or Theodo, AntEngage, Hydroscope, CallStack, Software Mansion, Bolt, Rise Tools, all the sponsors, thank you so much for making it possible. Great. And yes, Anjana, thank you so much for being the best MC ever. And yeah, I think, yeah, you can come. Yes.
Hi. I believe, you know, we've spent a lot of time on this stage today.
Yes, totally.
Do we need to get some other folks
yes,
up
totally.
on stage?
Yes. Probably we should have the speakers.
Yeah, let's get all of the speakers who are still around to come up on stage. We can get a photo. Yo, give it up one more time for the amazing talks today. So good, so good. Come on in, come on in. I'll go over that side. Oh, keep it coming, careful. Don't, I mean, I've been wishing everyone to, you know, they say in the theater, it's bad luck to wish someone good luck. So you have to wish them to break a leg. But not literally, y'all. Okay, get in there, get in there, get in there. Okay, everybody keep it going one more time for the speakers. Swish, swish. Did you get the photo? In. Oh.
Shorter people at the front?
No, this way. That way. You'll go in, fill in this area, no? Yeah. Nice. How we doing? Do we got it? Don't forget, you all also get to be in a photo shoot in a few moments.
Mike, come over.
Mike. Get off the phone, Mike.
Peer pressure. Squish. Nice.
Can we have one movie like this one? Yes, like that.
Yes. Woo!
All right, I think we can call more people on the stage. Yes, the organizing team, the volunteers, and the sponsors. Please join us on
give
the
it
stage.
up for these
Yes.
folks, these Geeky and the GeekConf volunteers, the sponsors who made it all happen. Anybody who's not actively behind a camera, come on up here. Yes. Where are Manjula and Sahil? Anjali. Huh? Come on.
Apurv.
Yeah.
Kunal, come. Ashwati.
Nice.
Anjana, do you think?
Squish.
Yeah.
Squish.
Yes.
Yeah?
Probably after this picture, we can do a picture here. I think we don't have a lot of people.
What?
Yeah,
We
let's
can-
do
okay,
this one.
yeah. Alrighty. Yo, give it up one more time for everyone who made this happen.
Come over, Sahil.
Yeah.
Manjula.
Gigabytes. Woo! These folks, you might not have met them. You might have seen them around, running from room to room, making things
Manjula,
happen.
you guys want to come this side?
Over
Yeah.
here.
Yeah.
There's some space to fill in.
Kushag,
here.
I think this we have got space on this side.
Yeah, exactly. Sorority squad. Come on. All right. Yes. Woohoo! Can we get everybody looking like not super tired? Woo! You all deserve to be super tired. Totally earned it. All righty. We do a fun one? They need your help. Woo! Okay, and
All right, and we can do the family photo outside or here.
Yep. So we will do the family photo for the last and most important thank you of the day. You all have been an amazing crowd. So please, one more time, give it up for all of us. We did it together.
Outside.
And we will meet outside by the pillars for a big family photo.
I need to interrupt this because he thanked everyone. Hey, everybody, give it up for Sanket. Sanket, Sanket, Sanket. Woo!
Thank you. Thank you. All right, I think we'll head for the picture outside. Yeah.
And we will see you all outside. And don't forget, there will be an after party, a little shindig at Brew Dog, which is a couple minutes away, starting at 7. We're allowed to be here until about 6:45, and then everybody will need to migrate out of the venue. So we'll see you at Brew Dog at 7. It's buy your own drinks, but we will have lots of great nerdy, geeky chats there. So thanks again. We'll see you there.
Welcome to the GeekConf. Welcome to the GeekConf. Welcome to the GeekConf. Welcome to the GeekConf. Welcome to the GeekConf.